perform VCO characterization. This not only speeds up the lab processing time, but also multiplies the measurement throughput in VCO manufacturing lines. As the leader in this area, Roda and Schwartz was able to develop the best phase noise and VCO tester on the market, whose pre-configured setup allows easy testing and instantaneous results for the lab, as well as for production applications. The R&S FSPN, unrivaled sensitivity meets high speed. Find more information and learn about phase noise and VCO testing on our website.
"5G is revolutionary. It promises extremely fast communication, ultra-reliable low-latency data links, and support for huge numbers of connected devices. To make it work, network providers depend on micro-base stations to provide high-capacity coverage through beam steering and massive MIMO, that is, multiple input and multiple output systems. The best route to each device is determined by pilot signals and computations on the base station side of the network. Through virtual prototyping with Simulia electromagnetic simulation, specifically CST Studio Suite, you can ensure the best possible network connections, even in complex environments where a hand or a large object in the street may block the direct signal path. You can also optimize antenna arrays and high-speed circuit performance, as well as ensure safety and critical regulatory compliance. Simulia electromagnetic simulation gives you the ability to simulate complex multipath environments, measure signal strength virtually rather than time-consuming manual measurements, and optimize microcell placement. Taking real-world scenarios into account, clean handoffs between base stations can be ensured with no coverage gaps. Simulia electromagnetic simulation provides efficient end-to-end 5G simulation solutions, allowing you to deliver high-performance designs in a short time frame and at lower costs, without compromising compliance, reliability, and safety. Let the revolution begin.
Jurnal Elektronika dan Telekomunikasi or JET is a journal published by Pusat Penelitian Elektronika dan Telekomunikasi LIPI. JET presents high-quality articles on the latest research and development in the field of electronics, telecommunication, and micro or nanoelectronics engineering. JET provides a platform to share research in the areas such as digital signal and image processing, network theory and circuit design, radar and sonar technology, antenna and wave propagation, wireless and optical communication, microelectronic system, electromagnetic and electronics materials, emerging and advanced fabrication technology, and so on. JET is indexed by internationally renowned indexers such as DOAJ, Google Scholar, Mandiri, and etc. JET is also ranked as Center 2 in Kemendristek Green accreditation system. There are 2 JET editions published every year, and all of them are available in open access to support global exchange of knowledge. All submissions in JET are accepted online, and each submission will be blindly reviewed by at least 2 peer reviewers. Most importantly, all submissions are free of charge and therefore no article processing fee applies. For more info, please visit www.journalet.com or visit our social media accounts.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by various research institutes, and have more than 70 research centers and supporting units. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Good morning, honorable guests, distinguished speakers, presenters, and participants. We have come to the second and the last day of the 2021 International Conference on Radar, Antenna, Microwave, Electronics, and Telecommunications, or Icramet 2021, with the theme of managing the impact of COVID-19 pandemic, together facing challenges through electronics and ICTs. Today, we will have 3 keynote speakers and 6 parallel sessions. There is a change in the schedule for today. First keynote speech session consists of one talk by Dr. Budi Prawara as the head of Research Center for Electronics and Telecommunication BRIN that will be moderated by Dr. Yusuf Nurwijayanto. Next, we will have our patron from PT Rohde and Schwarz Indonesia, represented by Mr. Andreas Larsen, followed by our paper presentation session 10, 11, and 12. Next, we will have a rather longer break, followed by the last parallel sessions of 13, 14, and 15. The final keynote session will consist of two keynote speeches by Professor Muhammad Slim Alawini from King Abdullah University of Science and Technology, Saudi Arabia, and Air Vice Marshal Juleksi Tambayong as the head of Research and Development of the Ministry of Defense Republic of Indonesia, prior to the closing of the Icramet 2021. And this keynote session will be moderated by Dr. Nasrullah Armi. Now, we move on to the first agenda of the second day of Icramet 2021. That is a keynote talk from Dr. Eng Budi Prawara that will be moderated by Dr. Yusuf Nurwijayanto. I will introduce you a brief profile of Dr. Yusuf Nurwijayanto. Dr. Yusuf Nurwijayanto received his Bachelor of Engineering degree in Electrical Engineering from Institut Teknologi 10 November Indonesia in 2004. Then he received the Master of Engineering and his PhD degree in Electrical Engineering from Osaka University, Japan in 2010 and 2013 respectively. Since 2005, he joined the Indonesian Institute of Sciences, LIPI, Indonesia, or now known as BRIN, with a placement at the Research Center for Electronics and Telecommunication. His activities working on electrical optical conversion techniques, radio and optical technology, wireless and wired communication and imaging. To Dr. Yusuf Nurwijayanto.
Okay, thank you, Dr. Adita, for your kind introduction. Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, hello and good morning, everyone. I hope everyone is doing good this morning. First of all, I would like to thank the organizing committee of Icramet 2021 for inviting me as a moderator. So, I am Yusuf Nurwijayanto, already introduced before. I am a research scientist in the National Research and Innovation Agency, BRIN, and I'm going to be your host for this morning session. Okay, in this morning, we will have one exciting talk from our distinguished speaker. He is a Dr. Budi Prawara. And good morning and welcome to Dr. Budi Prawara. Thank you for your joining us this morning. But before we proceed on the first speaker, I would like to read some general guidelines. So each keynote, maybe Dr. Budi Prawara will make a presentation for about 45 minutes, including Q&A. And for the audience, if you have a question at the end of the talk, please use raise hand features in the Zoom. Okay. And participant menu, I will call out your name so that you can ask your question in person directly. Alternatively, you can also write down your question in the chat menu, and I will try to read the question after that. Okay, let us proceed for the first. No, this is only one talk. Yeah. Let us process for the talk, which will deliver by Dr. Budi Prawara. But before that, let me briefly introduction about him. This okay. This in the slide we can see that Dr. Budi Prawara already graduated from the Brawijaya University for the bachelor degree and also for the master and doctoral degree in the Ryukyus, Japan. He working and research about the material composite coating, something like that, and deposition, and then some thermal spread coating, and also he has the experience for the head of research center for the electronic power and mechatronic, and currently he is the head of the research center for electronic and telecommunication. And the research interest is about the deposit of the metal, metric, composite, and coating, energy conversion and conversion research, and also the renewable energy. Actually, Dr. Budi Prawara has many awards from the society and for the Indonesian government. Maybe the committee not so in this slide. So, okay, for the directly, let's give the make a presentation for the Dr. Budi Prawara. Please, the time yours, please. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. I do hope all of you are keeping well. First, I would like to thank you to the committee who has invited me as a keynote speaker for this conference. In this opportunity, I would like to share one of our research and innovation activity during pandemic, the current inventions and innovations for the prevention and countermeasures the spread of COVID-19. Please allow me to share my presentations. Yeah, as we know, COVID-19 has been declared as the global pandemic since March 2020, and according to WHO, it has been infected almost country of the world. The number of confirmed cases and deaths is still growing now. Likewise, in Indonesia, this pandemic not only causes health problems in community due to the coronavirus, which is quickly spreads at various age levels, it also causes damage to the economic order and setting up our socio-economic structures. The Indonesian government has made various efforts to reduce the spread of COVID-19, including by establishment a COVID-19 research consortium for the prevention and countermeasure of these diseases. Our research center for electronics and telecommunications, also contributes to this effort by carrying out various kinds of inventions and innovations through several research activity. Yeah, this is the contents of my presentations. First, I would like to introduce to you our new organizations, National Research and Innovation Agency, or RIN. Then I will talk a short profile of my centers. Next, I will talk about research and innovation for prevention and countermeasures of COVID-19, which is can be classified into medical equipment. We have research on ventilator, information technology. We have research on wearable device, sterilization system based on UV lamp, detection system based on sensor and microwave. And the last, I will make some conclusions. Yeah, this is the new organizational structure, National Research, Innovation and Agency. As you know, since September 2021, Indonesia government was established National Research and Innovation Agency, which is consists from several former research institutions such as LIPI, BPPT, LAPAN, and BATAN. The BRIN chairman or Kepala BRIN has a direct line with our president, and he has some deputy that consists from 7 deputy, and also the former research institute now become organizational research. And our former Indonesian Institute of Sciences or LIPI now become for organizational research. Organizational research for natural sciences, earth sciences, technical sciences, and social sciences. Okay, next is a short profile of our research center for electronics and telecommunications. The history of our center began from 1965 when National Electronics Institute established, and then on 1987 we joined to the former Indonesian Institute of Sciences until 2021, and now we join or merge with BRIN, or National Research and Innovation Agency. This is our former building, and now we have a plan to construct new building in our location in Bandung, in Jalan Cisitu. This is our website, and we have also Instagram. This is the resources and program of our research center. We have 6 research groups. The first is a research group for radio frequency, microwave, acoustic, and photonic. Research group for antenna and propagations. Research group for electronic system and signal propagations. These 3 research groups can be classified into research area for telecommunications, and the other is a research group for a device solar cell, smart sensor, actuator, and transducer, and research group for device magnet and thermoelectrics. This research group can be classified into research area for electronics or device electronics. Now I'm going to talk about research and innovation for prevention and countermeasure of COVID-19 in our research centers. In our former research institute, Indonesian Institute of Sciences, we have been doing the research and innovation in this area. We can classify it into 7 areas. The first is Indonesia Herbal for antiviral, rapid diagnostic test, medical equipment and detection system, whole genome sequence and vaccine, personal protective and sterilization equipment, information technology, and socio-economic and demography. Our center have contributed to the medical equipment and detection system, personal protective and sterilization equipment, and information technology. First, innovation on medical equipment. We have been doing research on ventilator. Several COVID-19 caused significant number of patients to develop respiratory symptoms that require intensive interventions. Initially, the treatment for severe respiratory failure included early intubation and invasive ventilation, as this was deemed preferable to be more effective than non-invasive ventilation. However, imaging evidence has shown that non-invasive ventilation may have a more significant and positive role than initially thought. For non-invasive ventilations, includes this type of ventilations. We say CPAP, BPAP, continuous positive airway pressure, and B-level positive airway pressure. The CPAP and BPAP, this is the method of choice for those with complex respiratory condition who contract COVID-19. Yeah, this is our research products. You can see the current status of this product is this already certified by Badan Pengendali Fasilitas Kesehatan or BPFK from Ministry of Health, and we have also registered patent from this product. And yeah, there are some product advantage. For example, this ventilator has a compact design, a smart feature, easy to operate, and electrical safety according to IEC 60601. And this product also already and now ongoing to license to our partner PT Pesana Indovindo. And the next step for this product, we are now ongoing for a clinical trial. Yeah, this is the picture of our ventilator, and this is the technical specification. Yeah, the important parameter is inspiration pressure. We can adjust it from 5 to 40. And this is the red one is standard parameter for COVID-19 patient treatment for a medical person. So we can see that this parameter is okay. Yeah? And for expiration pressure, we can adjust to 5 to 20. And for tidal volume, we can adjust from 250 to 800 milliliter. For example, if you have a weight 50 kilogram, so this tidal volume will be about 400 milliliter. So it is okay. Yeah. And this ventilator has refrigeration rate from 10 to 40 breath per minute. And we can also adjust the oxygen fraction from 21% to 100%. This ventilator also equipped with some alarm when the parameter is, for example, for the pressure, when it is low pressure, they will warn with alarm also for high pressure. Also, this ventilator has power backup with a battery, so we can operate this ventilator for about 4 to 5 hours when the electric shut down. Yeah, we say this is a smart Indonesian Smart Innovative Ventilator Indonesia, or Venesia, because they have some smart feature. For example, we can collect data from patients during using this ventilator. Also, we can connect this ventilator with other communication system by Wi-Fi or Bluetooth. And for same ventilator, we can mirror it with the control room. So nurse no need to go to the patient room for monitor the patients. They just monitor from the control room. Yeah, this is a small size, so it is suitable for small space. For example, we can put it on ambulance on also, because they have power backup. We can use it on a remote area or the area where electricity is not so good. Yeah, we already did the endurance test in laboratory and also in BPFK or Badan Pengendali Fasilitas Kesehatan in Jakarta. The function test has been carried out at 20 days non-stop without being turning off, and changing parameter settings should not contain a deviation that exceed the acceptance standard. And after that, all electronics module and mechanical component are still normal. And then we obtain a certificate from BPFK. Yeah, next, innovations on information technology. We have individual monitoring system based on wearable device. Yeah, recently after Peduli Lindungi, one of our apps to monitor and tracing is implemented. There are some cases where confirmed patient or confirmed individual made violations. They went to the public area such as a mall or supermarket, and even they tried to traveling using public transportations. So we can imagine that actually there are more violations during this pandemic, as we can see on some news. And several monitoring and tracking applications currently being developed still have weakness that cause individual under surveillance to cheat on this device. So it is necessary to have a reliable system capable of detecting violation attempts with economically valuable wearable device so that it can be implemented on wide scale. Yeah, similar implementation has been implemented in Korea and Hong Kong from last year. Yeah, for example, in Korea, they have tracking wristband as shown in this picture, and they begin to placing these electronic bracelets for people who have disobeyed self-isolation order. Also in Hong Kong, with you can see bigger size, they also implemented this technology, to help curb the spread of the coronavirus by enforcing compliance with quarantine and tracing the contact of those infected. This table shows that country who has been implementing this technology, they can control the spread of COVID-19 compared than our country. This is the last year data. Yeah, this is the basic of technology of this device. This device has a Bluetooth Low Energy or BLE chip, which is implanted in the bracelets and will continue to be attached to the confirmed individual until the isolation or quarantine period is complete. We can set the special ID, and this device is designed so you can only communicate with the smartphone that is your partner by registering this Bluetooth device on the mobile apps installed on the smartphone. And the BLA device send the information periodically to the smartphone device. Yeah, on the smartphone device, we can install the apps. So these apps function to register, send information to the server, and check periodically to the Bluetooth device that is their partner. Also, by this device or apps, we can retrieve information periodically from the Bluetooth device. And we use the GPS on the device to provide the location information to the server. And in this device, they have some feature to detect the violation of quarantine rules. And on the server, we can identify the mapping database of individual under surveillance. Also, database for the supervisor for each area, for example, in one village or kelurahan or RT or RW. And we can monitor the individual. They have some dashboard. And also, when there are some violations, it will be send the notification system to the supervisors related to the area if there are some violation of quarantine rules. This is some feature from this wearable device, because this device will be used when the individual should be quarantined or self-isolations. Usually, they do the isolation for 14 days. So the battery life, this device can be used until 40 days, more than 40 days. And this is a kind of rechargeable lithium battery. They have range 20 meter with our cellular, and the application based on Android. Also a feature for detection real violation and fake GPS. And also notification will be sent by email or SMS. And because this device will be used on daily life, so this is water resistance, and also secure and keep the privacy. For security and privacy, we already developed, so we guarantee this is safe for security and privacy. And this is the picture when our wearable device used by individual. And this is the screenshot of in our cellular. We can see the status of this device, and also this is the screenshot in a server, so the supervisor can be monitor the individual when using this device. We also now make some engagement to some partner to license and make some next plan for production. For example, we already make engagement to the PT Land Industry and PT BIM. This is the web-based server interface appearance. So we can monitor all of area in our country when people using this device. And this is dashboard. For example, when we monitoring in one city, for example, this is Bandung city, and this is the monitoring database management. Also, we can tracking, when there are some violation, we can tracking the individual using this menu. And this is the push email and alarm display. This is the registration process appearance on the mobile apps. And this is the mobile apps appearance. The next innovation is sterilization system based on UVC. As you know, the UVC technology radiation has the wavelength between 100 and 400 nanometer, and we call it with ultraviolet radiation, and we find it in sunlight. These are classified into 3 categories depending on the wavelength. UVA radiation with a wavelength between 315 and 400 nanometer, UVB radiation with a wavelength between 280 and 315 nanometer, and UVC radiation with a wavelength between 100 and 280 nanometer. And ultraviolet radiation with a maximum germidicial effect is UVC in the 245 nanometer wave spectrum. Yeah, we already make some experiment. For example, we have one experiment to measure the spectrum of 222 UVC nanometer lamp. We can see result of this measurement. The peak of that indicated that this lamp has 222 nanometer. And also we did some experiment to determine the intensity of the lamp with various distance. And by this data, we can determine the time exposure, optimum time exposure according to the dosage, effective dosage to kill the virus. Yeah, this is the our innovations on UVC sanitizers. We say Susan, simple, smart UVC sanitizer. This is a portable room sterilizer using smart control UVC light. This device can manage several UVC irradiation parameters from the Android applications, including the length of exposure according to the area of the room and the type of virus or bacteria to be irradiated. Also, scheduling radiation and equipped with security sensors, because 245 radiation is not safe to the human being, so we equip with the sensor. This device was developed very simple, portable, cheap, so that it can be used by household, clinic, puskesmas, school, office, and other place. Yeah, this product have been licensed to one of our partner and already certified by Ministry of Health to be implemented. Yeah, I would like to show you the short video of this product. Yeah, you can see in this video when people or somebody enter the room, the device will automatically shut down. And we can adjust how long this lamp will be active following the size of the room. And also we can adjust the dosage following kind of bacteria or virus that we will kill. Yeah, next innovations. We have one product, sterilization chamber with 222 nanometer per UVC lamp. This is the picture of our sterilization chamber that consists from 9 lamp. Yeah, 9 lamp. So we already make some experimental. By how long people will enter this chamber, so they can kill the virus when enter this chamber. Yeah, this sterilization chamber has some potential application, for example, on school, also on some public areas such as airport, hospital, and etc. Yeah, the time needed to sterilize the individual who entered in this chamber just less than 5 seconds. And on the right side, this is the 222 nanometer per UVC lamp when we implement it on the in the room. Yeah, in the room. So by this schematic, we can calculate the intensity and how long the time effective the lamp should be active for sterilize the room. Yeah, we do hope this technology also can be implemented in Indonesia, because this is new technology, quite still high price, but in other country this is already implemented. Next research is research on detection system. This is the biosensor, electrochemical biosensor to detect SEA as a protein-based biomarker for non-invasive COVID-19 detections. Yeah, as we know, the COVID-19 is a recent outbreak occurred worldwide and created a colossal dysfunction of various activity all around the world. COVID-19 stands for coronavirus disease 2019, and the primary concern related to this virus is early diagnosis, cost effectiveness, and reduce the chance of spread, so that working professionals also do not get affected while testing. And currently, RT-PCR is being used for testing the virus, which is time-taking and costly. Moreover, some of the research group has recently developed biosensor for COVID-19 detection through different approaches, but they all are invasive and lead to virus particle exposure. To overcome this issue, a biomarker-based biosensor can play a pivotal role. And our objective is to develop a biomarker-based biosensor system based on electrochemical method. We select serum amyloid A or SAA for first trial biomarker detection of COVID-19 patients. Yeah, the scope of work of the research consists three main activities. First, design and fabrication of strip biosensor based on screen printed with amperometric configurations. Second, functionalize the surface of working electrode with gold nanoparticle and conjugate by antibody SAA. Third, design and fabrication electronic measurement unit. The main function of this part is to provide voltage supply and current measurement subunit to sense and calculate currents, which has been generated by interaction of strip biosensor and SAA sample model. And finally, integration between strip biosensor and electronic measurement unit into a compact system. Yeah, this is the preliminary result, the biosensor strip of SAA detection prototype, which has been functionalized with gold nanoparticle and antibody SAA portable electronic measurement unit or pattern stat reader prototype. Preliminary data has shown that sensor has working successfully by generating enhanced cyclic volumetric current as shown in red line compared than strip biosensor with gold nanoparticle when sensing SAA sample. The integration and measurement still ongoing process to gain more data for further performance evaluations. The next innovation is vital sign. And yeah, this is the background of this study is, as we know, that the method of transmission of COVID-19 by droplet and airborne need attention in handling patients. Remote or non-contact inspection method will minimize the potential for transmissions, including through the use of medical equipment. And respiratory monitoring in patient is an important process in the management on infected patients. Yeah, this is the schematic diagram, our experiment where there are some patients and we put the vital signs detection, which is developed from FMCW radar. This is yeah, this FMCW we use as a kind of a sensor for respiratory monitoring sensor. And also there are one server to collect the data. Yeah, the principle of the experiment is by the FMCW radar system, we can create some bit frequency detection. And from the bit frequency detection, we can have some phase detection after it is used by the reference signal synthesizer. And from the phase detections, we can make a respiration rate estimation, and by the data collection and extraction from the respiration pattern, we can have respiration information display as shown in this laptop. Yeah, this is the picture when we measure the signal from the patients where they laying on the bed, and we put the sensor on the top with a certain distance. Yeah, you can see on the right picture or right photo when there are some pace detection from the patients when the patient breathing and stop the breath, so we can determine the phase. And by this phase, next we have a plan to collect more data from health people, from people who have a problem with the respirations. So we can next we do hope that this system also can be implemented to detect where the people is confirmed with COVID-19. Yeah, the non-contact monitoring system or patient breathing measurement is currently an emerging technology which is then needed in handling of COVID-19. And non-contact operation also provide comfort for a patient in addition to better hygiene aspect. Okay, this is some conclusions from my presentations. The current COVID-19 pandemic is not yet over. So for example, the fourth wave is now currently hitting Europe and several countries in Asia. Joint effort to overcome and prevent COVID-19 with future research and innovation can reduce and even end this pandemic. And promising technology to kill COVID-19, such as far UVC 222 nanometer, is currently being implemented. It is necessary to study the effect of long-term exposure to the human being. And the last is the development of accurate and fast and inexpensive detection technology, as well as the use of information technology can be used as a tool to suppress the spread of COVID-19. Thank you very much for your attentions. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you very much, Dr. Budi, for your alignment. You have make some presentation of very good experiment result for the ventilator, and then the pandemic tracking for the tracking and with the Simonic, and then another one is for the treatment of the sterilization, and also for the RT lamp, and also the final one is for the radar for the detect all the our bit of the our for the users, something like that. Okay. So currently time for the time discussion. If you have some question, please for the participant, raise your hand, please. Anyone? Mr. Yuyu, Dr. Yuyu, you have?
Okay.
Okay, please.
Thank you for moderator, Dr. Yusuf. Pak Budi, I have the one question. I heard that the research center for electronic and telecommunication is the excellent of the radar technology. Would you please to describe to me, to us, how the program for the excellent for radar in the future? Yeah. Thank you.
Thank you very much, Pak Yuyu, Mr. Yuyu. So our center has declared as Center Excellent for radar since 2019. We started the research for radar, I think from 2006, when some of our researchers went to Netherlands to study the radar, and after come back from Netherlands, we make some research on radar technology, and there are some. We have been doing some research on radar technology. For example, we did research on LPI radar, X-band radar, S-band radar, and the current research is FMCW radar for navigations. And you also implemented it for other application for medical device. I think in the future we have good opportunity to develop radar in Indonesia, and as you know, we are now merged into BRIN. And there are also some researchers in this area. For example, we can find some researchers on radar in LAPAN. What we say LAPAN in English? Aerospace agency, a former aerospace agency. Also, maybe in Balitbang Hub, we can or in a university. I think there are some also some researchers doing this research. We can unite, and we can contribute to our country. For example, we are in Indonesia now. As you know, we are is island country. There are 1,000 islands. We have also a border, some border to be monitoring. And as I know, some border there are still we say a blank. We cannot monitor the for example, a ship coming from other country to our country, maybe, I think there are some potential market, such as for navigation, for also for our defense. For our defense, we can make some joint experiment or research with Balitbang to develop, for example, GCI. I think that is our idea. So I do hope by this Center of Excellence we can what we say kemandirian bangsa, to have self national product for radar. Thank you.
Thank you, Dr. Budi, for your
enough.
Okay, thank you, Dr. Yuyu, for your question also. Thank you, Dr. Budi, for your answer. Okay, for the next question, maybe from the Dr. Novita, please.
Okay, thank you, Pak Yusuf. I have one question for Pak Budi. I see there are many products or devices from our research, our researcher, to overcome the pandemic COVID-19 that have the potential to be commercialized. What is your strategy or planning for that to commercialize? You have planning, Pak Budi?
I already presented some of our research on for countermeasure and for what we say to prevent the COVID-19. Some product now still ongoing research need to be improved to make it suitable for implementation. For example, for example, for the biosensor, I think it is need to be tested. Make some tested in I think BSL, BSL 2 or BSL 3, and going to the clinical trial before the implementations. Also, for ventilator, now we are going to make a clinical trial, and we do hope this product can be passed for clinical trial and will be certified for marketed. Some of products now already have license with our partner, for example, Sisusan, and also for the 222 chamber. It is some of our research that we develop. Still a new technology, for example, 222 nanometer UVC lamp. It is still high price, and we need more. What we say, we introduce to the people, to the scientists, or to the our stakeholder this new technology, so they can understand that this technology can help to reduce the spread of COVID-19. We do hope also government will support us. So in several times, me and some researchers visit to our stakeholder to introduce this product to be implemented. I think that's my answer.
Okay, thank you, Dr. Budi.
Thank you, Pak Budi.
Enough, Dr. Novita.
Okay, thank you.
Thank you, Dr. Budi, for your answer, and Dr. Novita for the question. The next, maybe this is another question from the Dr. Teguh Kalbi, please.
Thank you very much, Mr. Yusuf. I'm not a doctor. Good morning. Thank you, Mr. Dr. Yusuf and Dr. Budi. You are very good presentation. Very good for looking, and I'm happy I can join in this meeting. I hope Mr. Budi always have a good, healthy, and be happy. So, salam goes.
Thank you.
Okay, I have some question. I'm interested to your product about Venetia, maybe Venetia. Yes, it's a good name, like my doctor Venetia, and place of from the Italy, maybe like that. I want to know why you have what is the history you have the name is Venetia, number one. And the second presentation, I want to ask Mr. Budi. It's a very good system for help the patient and at the hospital, maybe like that. And I want to know how you what is your strategy for the future strategy for expansion or development for this Venetia. Maybe this number one product, and what's your idea for expansion for this Venetia. And the second and the third question about what is the system is Venetia if the patient have a urgent condition. Maybe if I hear your presentation, alarm the Venetia will be give the sign if only in that room patient. How about at the night, maybe in the patient room has no nurse. The nurse in the other rooms, but and the time the patient is urgent condition. Thank you very much.
Yeah, thank you, Pak Teguh, for your interesting questions. So, first question about name, yeah. Yeah, it is just name. Si Venesia means smart, innovative ventilator Indonesia. So before we make a name for this product, I discussed with our member of team, and they gave me some suggestion how we can make names so the people easy to remember. So yeah, we decide to give this product name is si Venesia. I think all of you will remember this name. And second question about the strategy to develop. Yeah, now as you know from my presentation, this ventilator now has two modes, namely first mode is CPAP, yeah, continuous pressure, continuous positive airway pressure, and the second mode is BPAP, bilevel positive airway pressure. This is, I think, the middle type of ventilator. The lower type is ventilator who no need clinical trials such as high flow nasal cannula. This is middle type. The technology more higher than the, for example, HFNC. And yeah, as you know, we started it from our knowledge from our researchers. So please don't compare with existing ventilator that already marketed from, for example, from USA, from Germany, from other country. But we try to develop this ventilator. So it is we can make a benchmark with other existing ventilator. We do hope it can be used in a hospital. Yeah, for the strategy to make this product can be used in the hospital. In our team also, we, beside the researchers from our center, we also include medical doctor from hospital, anesthesia specialist, who now next will use this ventilator. So we got some input from medical doctor. Yeah, I think this product is ready to be implemented after clinical trial. And the next plan, we can improve this ventilator with other modes, such as combined with high flow nasal cannula, and also the other mode that we can in the future can do it. Even we can improve it to the ICU. Yeah, ICU is the highest ventilator technology in ventilator. The third questions about the alarm system when this ventilator operated in a patient room. So we say this ventilator with smart ventilator. You can collect that data the patient from USB, and also this ventilator we put some Wi-Fi or Bluetooth communications. So the same type of ventilator we can in one floor in the hospital, we can monitor it from the control room. The nurse no need go to the patient room to control the ventilator. But for adjust the parameters, yeah, I think we can do it by IoT. We can do it by IoT. We can adjust the parameter from the control room also. But I think in first stage, just for monitor. That is my answer, Pak Teguh.
Okay, Mr. Budi. It is have a sound, maybe sound alarm. If the nurse not in the room of the patient, maybe.
Yeah.
Maybe the nurse at the night is sleepy, maybe like that, sleepy.
Yeah.
So the patient is need urgently tindakan. Urgent.
Yeah. I mean the same type of ventilator, because this we also have a feature Wi-Fi and Bluetooth communications, so we can control same type of ventilator in, for example, in one floor of a hospital from control room. So only one person control or monitor several ventilator with same type. She or he no need go to the patient room, just monitor from one room. Yeah, that is the maybe for the next improvement we can make some feature. For example, it can be integrated with our nurse gadget or nurse wearable device. So when she sleep, the gadget will vibrate or his
ringing.
Ringing or vibrate. So she will wake up. That is my idea, Pak Teguh.
Mr.
Any idea?
I have one question, maybe. I'm sorry about what is the system about the system at the working at the frequency 222 nanometer wave. What is the name? That's the system.
Oh, you mean
220 nanometer wave?
Yeah, that is.
I want to know how what is the effect for our health. That is safe for our health. That's wave nanometer wave.
Yeah. Okay.
222.
Okay. So for UVC, you mean? Yeah.
For UVC, yes.
Yeah. There are some wavelength in the UV wave that can be effective, can be used for kill the virus or bacteria. The first spectrum is 244. This spectrum is now already implemented in hospital for sterilize the medical equipment. It is not safe. 244 not safe because it can be pass our skin and can be burn our eye. And 2000, I think from 2015 or 2016, researchers from Columbia University have invented this 222 nanometer, also effective to kill the virus or bacteria. Its spectrum cannot pass our skin and also our eyes, so it is safe for the human being when this lamp is exposure to our body. They also make some experiment to the animal, to mice. Yeah, mice. They expose with this lamp for, I think now, more than 5,000 hours, and the result shows that this spectrum is safe for animal, which is for next development. I think it is need to be make some trial also to the existing the human skin. Yeah. Now I think some researchers is doing it, but for safety, we develop some applications so we can measure how long this lamp will be active and effective to kill the virus or other germ. I think that is my answer, Pak Teguh. So by this product, you can adjust, for example, the size when you have the room with, for example, 12 square meter. We can input it to the application, and the application will calculate how long this lamp is effective to kill the airborne virus or other germ.
Thank you, Dr. Budi and Dr. Yusuf.
Okay, thank you very much, Dr. Budi, for the answer and question for the Dr. Teguh also. Okay, on the maybe this session is I think it's a little bit longer. If anyone make some question again, please. Anyone, please.
Okay, Mr. Yusuf.
Yeah, please.
Thank you.
Please, Prof.
About the opportunity. Hello, everyone. Are already in a good health, everybody here?
Sure.
Okay. I just want to know a little bit more about the mechanism of killing the virus by the UVC. And then how much the intensity of the UVC ray to make the virus die or maybe damage? It's maybe that's my question. Please, Mr. Budi.
Okay, thank you, Professor Pamungkas. Please, Dr. Budi.
Sorry, I'm not professor. I'm not.
Yeah, thank you, Pak Pamungkas, for your questions. Yeah, as I know, we have some reference, yeah, for this kind of development. For example, for 222 nanometer UVC lamp, we found that it is effective to kill 99.6% of SARS-CoV-2. Yeah, these research have been doing by researchers from Japan, yeah, from UCO. They found that by dose of 5 millijoule per centimeter square, it is effective to kill 99.6% of SARS-CoV-2 with a certain distance. Previously on my presentation, I show you the experiment how to determine the intensity of far UVC lamp, and by this graph, then we can determine how long the effective time to kill the virus. We know the intensity from measurement from apparatus, yeah, UV vis, yeah, the name of equipment, and we know the dosage, so we can find the effective time to kill the virus with a certain distance. I think that is my answer. And yeah, fortunately, also Dr. Yusuf, moderator of this session, is lead team for the research for UVC land. Maybe Yusuf have additional comment.
Okay, thank you, Dr. Budi, and thank you for the question, Professor Pamungkas. Maybe if I give some additional comment for the to kill the virus for the COVID-19 is about 2 millijoule per centimeter square. Okay. So we can calculate the intensity between distance, consideration the distance for the land and the target. So we can calculate it later. Okay, maybe I think that. Any question more?
Maybe there is a table about the distance and the intensity that you have already calculated or make a data. Is that all right?
Yeah, we got the data from experimental.
Okay.
The intensity from various distance. We can measure the intensity by apparatus of UV vis. Yeah. So by this data, then we can calculate the effective time to kill the virus with various distance also. If we know the dosage effective for the kill the virus.
The explanation of Dr. Budi and Dr. Yusuf. Thank you.
Okay, thank you. Thank you very much, Pak Pamungkas and Dr. Budi. Any question more? If no, I will like to conclude. Okay, I would like to conclude this session with the keynote speaker of the Dr. Budi. Thank you for everyone who have participated in this discussion. Thank you very much also to Dr. Budi on behalf of the organizing committee. We would like to express our token appreciation for delivering keynote talk at the 2021 Icramet. Thank you again for your time and willingness, and we hope to see you again in the future. Please give round of applause for the Dr. Budi Prawara. Thank you very much, Dr. Budi.
Thank you very much.
Stay healthy and safe always. Okay, so the session is already end. I will back to the MC. Please, Miss Ardita. Thank you.
Thanks to Dr. Yusuf Nurwijayanto for facilitating the keynote speech session, and also for Dr. Budi Prawara, and also all participants who have actively participated in this session. Next, we will have a morning break, and we will continue the patron session with Rohde and Swartz Indonesia at 10:10 before the paper presentation session begins. Thank you.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development, and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by various research institutes, and have more than 70 research centers and supporting units. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Jurnal Elektronika dan Telekomunikasi or JET is a journal published by Pusat Penelitian Elektronika dan Telekomunikasi LIPI. JET presents high-quality articles on the latest research and development in the field of electronics, telecommunication, and micro or nanoelectronics engineering. JET provides a platform to share research in the areas such as digital signal and image processing, network theory and circuit design, radar and sonar technology, antenna and wave propagation, wireless and optical communication, microelectronic system, electromagnetic and electronics materials, emerging and advanced fabrication technology, and so on. JET is indexed by internationally renowned indexers such as DOAJ, Google Scholar, Mandiri, and etc. JET is also ranked as Center 2 in Kemendristek Green Accreditation System. There are 2 JET editions published every year, and all of them are available in open access to support global exchange of knowledge. All submissions in JET are accepted online, and each submission will be blindly reviewed by at least 2 peer reviewers. Most importantly, all submissions are free of charge and therefore no article processing fee applies. For more info, please visit www.journalet.com or visit our social media accounts.
Imagine that you are responsible for designing a modular GPS smartwatch. With each segment of the strap containing a different electronic module, there are hundreds of possible configuration alternatives. How do you identify challenges with connectivity, signal integrity, and electromagnetic interference early on? With electromagnetic simulation technology, you can not only analyze individual modules, but also the entire product assembly. Here, the antenna sensitivity of the smartwatch is shown with the strongest signal directions shown in red. This allows you to evaluate your product connectivity performance in all possible configurations early on. Human proximity effects can also be analyzed, enabling designers to verify not only connectivity when the watch is worn, but also ensuring that it meets regulatory compliance and electromagnetic safety standards. In this case, you discover that the antenna becomes detuned when not worn on a user's wrist, causing the connectivity to degrade. With electromagnetic simulation technology, you are able to redesign the module's antenna to work on and off the wrist and verify the quality improvement. Now that you have considered electromagnetic challenges, what about considering structural ones? By also performing detailed structural simulations, you can assess the reliability of the watch. This includes advanced simulations such as drop testing and other harsh loading conditions for detailed evaluation of the watch's structural and functional integrity. Another critical component of the smartwatch is the touch screen. Simulating pressure-based sensing requires coupling between the electrical and structural simulations to ensure the screen is sensitive, but not too sensitive. Soon, touchscreens will provide haptic feedback. Electroactivated polymers, which deform with electrical input, can provide tactile feedback to your hand as you interact with this screen. Imagine a feelable button click. We feel that coupled electrical structural simulation will play a key role in evolving flexible electronic design, enabling the development of future products that will provide extraordinary experiences to consumers.
Next-generation technologies like radar and satellite communication with high data rates call for innovative testing solutions to develop and manufacture RF components. A critical part in the development and design of large communication systems, as well as single RF components for microwave devices like oscillators and amplifiers, is phase noise measurement. This is used to show developers if a signal source noise is as low as it should be. With the launch of the R&S FSPN, Roda & Schwarz is adding a new member to their phase noise analyzer portfolio, enabling increased efficiency and reproducibility of phase noise measurements and VCO characterization from lab to production. The R&S FSPN only takes a few seconds to perform VCO characterization. This not only speeds up the lab processing time, but also multiplies the measurement throughput in VCO manufacturing lines. As the leader in this area, Roda & Schwarz was able to develop the best phase noise and VCO tester on the market, whose pre-configured setup allows easy testing and instantaneous results for the lab, as well as for production applications. The R&S FSPN, unrivaled sensitivity meets high speed. Find more information and learn about phase noise and VCO testing on our website.
Saat ini, kebutuhan magnet permanen di Indonesia relatif tinggi. Magnet permanen adalah magnet yang memiliki sifat kemagnetan yang lama dan tetap, sehingga sukar untuk dihilangkan. Magnet permanen banyak dimanfaatkan pengaplikasiannya oleh industri dan UKM pada berbagai komponen elektronika. Namun, tahukah kamu, sebagian besar kebutuhan magnet permanen di Indonesia masih diimpor dari negara lain, seperti Cina, Jepang, dan Amerika. Salah satu magnet permanen yang cukup banyak digunakan adalah magnet barium ferit. Magnet barium ferit, atau yang sering dikenal juga dengan sebutan magnet keramik, adalah magnet permanen dengan rumus BaFe12O19 yang terbuat dari bahan baku utama oksida besi dengan teknologi serbuk. Untuk meningkatkan kekuatan magnet barium ferit, Pusat Penelitian Elektronika dan Telekomunikasi Lembaga Ilmu Pengetahuan Indonesia di Bandung telah menemukan sebuah invensi berupa magnet bonded hybrid. Apa itu magnet bonded hybrid? Magnet bonded hybrid merupakan penggabungan dari magnet barium ferit dan magnet neodymium iron boron (NdFeB) dengan menggunakan teknologi hot press bernomor paten P00201407033. Keunggulan dari invensi ini adalah harga lebih murah bila dibandingkan dengan produk impor. Jumlah, bentuk, dan spesifikasi dapat dibuat sesuai kebutuhan pengguna. Keunggulan lain dari invensi ini adalah menggunakan produk lokal limbah oksida besi, temperatur Curie, dan ketahanan korosinya lebih tinggi dibanding magnet NdFeB, serta kekuatan magnetnya lebih tinggi bila dibandingkan dengan magnet barium ferit. Saat ini, pembuatan invensi magnet bonded hybrid masih dilakukan dalam skala laboratorium di Pusat Penelitian Elektronika dan Telekomunikasi. Pengembangan selanjutnya, invensi ini dapat diproduksi secara massal dan digunakan untuk memenuhi kebutuhan industri elektronika nasional, seperti meteran air, printer, pengeras suara, keyboard komputer, alat bantu dengar, generator, dan motor listrik. Kami menantang Anda untuk menjadi teknopreneur melalui teknologi ini. Apakah Anda berani? Ayo membangun bisnis berbasis teknologi.
"5G is revolutionary. It promises extremely fast communication, ultra-reliable low-latency data links, and support for huge numbers of connected devices. To make it work, network providers depend on micro-base stations to provide high-capacity coverage through beam steering and massive MIMO. That is, multiple input and multiple output systems. The best route to each device is determined by pilot signals and computations on the base station side of the network. Through virtual prototyping with Simulia electromagnetic simulation, specifically CST Studio Suite, you can ensure the best possible network connections, even in complex environments where a hand or a large object in the street may block the direct signal path. You can also optimize antenna arrays and high-speed circuit performance, as well as ensure safety and critical regulatory compliance. Simulia electromagnetic simulation gives you the ability to simulate complex multipath environments. Measure signal strength virtually rather than time-consuming manual measurements. And optimize microcell placement. Taking real-world scenarios into account, clean handoffs between base stations can be ensured with no coverage gaps. Simulia electromagnetic simulation provides efficient end-to-end 5G simulation solutions, allowing you to deliver high-performance designs in a short time frame and at lower costs, without compromising compliance, reliability, and safety. Let the revolution begin.
Banyak terjadinya kasus pelanggaran terhadap aturan karantina bagi suspek COVID-19. Teknologi monitoring diperlukan untuk mengawasi gerak suspek COVID-19 agar menekan tingkat penyebaran virus. Sistem monitoring yang ditanamkan pada sebuah wearable device akan dipasangkan pada suspek COVID-19 di suatu wilayah karantina.
SIMONIC merupakan singkatan dari Smart Innovative Monitoring for COVID-19.
Teknologi SIMONIC terdiri dari 3 subsistem. Yang pertama adalah wearable device, yang kedua adalah mobile apps, dan yang ketiga adalah server.
Wearable device berbentuk gelang yang di dalamnya terdapat chip Bluetooth Low Energy yang dapat juga diaktifkan tanpa mengeluarkan suara ataupun bunyi. Software berbasis Android yang diinstal pada smartphone dari individu yang diawasi akan menjembatani komunikasi antara device dengan server, sekaligus akan memberikan informasi posisi dari individu yang diawasi melalui fitur GPS yang ada di dalamnya. Komunikasi antara gelang dan smartphone akan diterima oleh server dalam bentuk data lokasi, rute perjalanan, informasi waktu, dan lain sebagainya. Informasi-informasi tersebut akan diakses oleh pengawas lapangan untuk memastikan proses karantina mandiri atau karantina terpusat dijalankan secara baik dan benar. Individu yang memakai wearable device tersebut dapat melakukan berbagai kegiatan seperti biasa tanpa ada hambatan.
Untuk kerjasama, saat ini kami sudah melakukan penjajakan kerjasama dengan Badan Penelitian dan Pengembangan Daerah atau BP2D Jawa Barat. Kami merencanakan uji coba dalam skala yang lebih besar ya, dan nanti wearable device ini akan diuji coba langsung oleh orang dengan status positif COVID-19 seperti orang yang dengan status suspek, terkonfirmasi, atau juga orang dengan status kontak erat ya. Harapannya produk yang sudah kita hasilkan ini tentunya kami berharap agar ini bisa segera diimplementasikan oleh pemerintah ya, baik itu pemerintah daerah maupun di tingkat pusat ya. Artinya ada satu kebijakan yang mendorong supaya orang-orang dengan status positif ini bisa diawasi dengan menggunakan SIMONIC ini atau Smart Innovative Monitoring for COVID-19. Sehingga ini akan mempermudah pengawasan bagi si pengawas ya, untuk orang-orang dengan status positif tadi, agar mereka bisa melakukan karantina atau isolasi mandiri yang baik itu di rumah maupun di tempat-tempat yang sudah ditunjuk oleh pemerintah. Dan nanti sehingga harapan ke depannya bila ini dapat berjalan dengan baik, tentunya kita harapkan dapat menurunkan reproduction rate ya, baik itu di tingkat daerah maupun di tingkat nasional.
Next generation technologies like radar and satellite communication with high data rates call for innovative testing solutions to develop and manufacture RF components. a critical part in the development and design of large communication systems, as well as single RF components for microwave devices like oscillators and amplifiers, is phase noise measurement. This is used to show developers if a signal source noise is as low as it should be. With the launch of the R&S FSPN, Roda & Schwarz is adding a new member to their phase noise analyzer portfolio, enabling increased efficiency and reproducibility of phase noise measurements and VCO characterization from lab to production. The R&S FSPN only takes a few seconds to perform VCO characterization. This not only speeds up the lab processing time, but also multiplies the measurement throughput in VCO manufacturing lines. As the leader in this area, Roda & Schwarz was able to develop the best phase noise and VCO tester on the market, whose pre-configured setup allows easy testing and instantaneous results for the lab, as well as for production applications. The R&S FSPN, unrivaled sensitivity meets high speed. Find more information and learn about phase noise and VCO testing on our website.
Penggunaan sinar radiasi ultraviolet C atau UVC merupakan salah satu metode dalam sterilisasi. Sinar radiasi UVC dipercaya dapat melengkungkan struktur materi genetik virus dan mencegahnya berkembang. Pusat Penelitian Elektronika dan Telekomunikasi LIPI telah mengembangkan alat sterilisasi ruangan portable berbasis sinar UVC. Sisusan atau Simple Smart UVC Sanitizer memanfaatkan sinar UVC yang dikendalikan secara cerdas. Sisusan memancarkan sinar UVC yang menyinari langsung permukaan benda di ruangan atau kabin.
Seperti kita ketahui, sinar UVC adalah mempunyai kemampuan untuk melemahkan mikroorganisme, termasuk diantaranya adalah bakteri, virus, pada suatu permukaan benda dan di suatu ruangan. Sisusan dapat digunakan untuk menghambat penyebaran COVID-19.
Parameter penyinaran dapat diatur melalui aplikasi Android, seperti lama penyinaran sesuai dengan luasan ruangan dan jenis virus atau bakteri yang akan dibasmi. Penjadwalan penyinaran dilengkapi sensor keamanan dari aktivitas manusia. Sisusan didesain dengan sangat sederhana, portable, dan murah sehingga dapat digunakan di rumah tangga, klinik atau puskesmas, sekolah, kantor, dan lain-lain.
Next-generation technologies like radar and satellite communication with high data rates call for innovative testing solutions to develop and manufacture RF components, a critical part in the development and design of large communication systems, as well as single RF components for microwave devices like oscillators and amplifiers, is phase noise measurement. This is used to show developers if a signal source noise is as low as it should be. With the launch of the R&S FSPN, Roda & Schwarz is adding a new member to their phase noise analyzer portfolio, enabling increased efficiency and reproducibility of phase noise measurements and VCO characterization from lab to production. The R&S FSPN only takes a few seconds to perform VCO characterization. This not only speeds up the lab processing time, but also multiplies the measurement throughput in VCO manufacturing lines. As the leader in this area, Roda & Schwarz was able to develop the best phase noise and VCO tester on the market, whose pre-configured setup allows easy testing and instantaneous results for the lab, as well as for production applications. The R&S FSPN, unrivaled sensitivity meets high speed. Find more information and learn about phase noise and VCO testing on our website.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. to enhance science and technology's contribution to the national development, and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by various research institutes, and have more than 70 research centers and supporting units. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Thanks for all participants for coming with us again. Next, we will have our patron session with Mr. Andreas Larsson as the Regional Manager of Road and Swartz Indonesia, and this session will be moderated by Mr. Hana Arisesa. For Mr. Hana Arisesa.
Okay, thank you. Welcome back, and I hope you have a wonderful morning break. It is my pleasure today as your moderator in this session. This session is our partner and industrial partner from Rohde and Swartz. Joining with us, Mr. Andreas Larsson. He is a manager regional Rohde and Swartz. He will give a talk about oscilloscope-based solution for radar applications. Let me read you about the brief summary of this talk. Testing radar will require a number of test equipments and can be a cost-intensive exercise. Doing maintenance on site is difficult because the equipment needed with conventional technology. So the solution to the state-of-the-art oscilloscope can use as the all-round tool for radar repair maintenance and radar development as well. In many cases, the only test equipment that is needed is oscilloscope. The new performance of oscilloscope opens up the door for simplifying the setup in workshop and offer a better price performance alternative to traditional setups. This presentation will give an impression of what is possible with modern technology. So this is a 30-minute talk with 20-minute presentation and then 10 minutes for Q&A. Before we begin, I would like to remind you, all audience, may ask questions during the presentation. Please write down your question on the chat box, or you can do it later in Q&A sessions, or you may use raise hand menu as well, so you can directly asking in the room. So I welcome Mr. Andreas Larsson, and you might start your presentations now, please.
Well, good morning, everybody. It's a little bit early here in Europe, but yeah, I'm up and I'm awake, so I hope we have a nice presentation here. What I'll do is I've shown you my pretty face just to show you that it's not a recording session that I'm doing here. I'm actually on location here. And since I'm doing it from Europe, I'll actually stop my video and share my screen with you. So let's just start the thing, and let me see what I have to do here. Yeah, that should be screen. Yep, come on. Okay, I hope you can all see my screen. I'll take up my PowerPoint show now.
Yes.
So hopefully this is okay.
Yes. Go ahead, sir.
If you have some interruptions in between, just let me know. So here for today, we have seen that we can do a lot of things with our oscilloscopes because we have some new technologies in there. And basically, a lot of our customers don't know how useful an oscilloscope can be for testing radars. And if you're doing maintenance, if you're doing repair, even if you're doing development and production, stuff like that, the oscilloscope offers, let's say, a cost-effective way to test your radars. And you'll be hopefully surprised how much you can do with our oscilloscope for radar testing. And let's get right into it. So the thing is, over the last, I would say, 15 years, radars has changed a lot. Radars used to be, let's say, a simple device that sends out pulses, receive pulses, analyze the pulses, and gives you a position. But over the last years, they have turned into multi-mode radars. They have turned into frequency agile. They're phase agile. They can handle increased EW threats. And they are actually quite complicated instruments nowadays. With conventional test solutions, you would actually require a lot of different test equipments. And it can be an expensive exercise, it can be complicated, which we realized is not always a good solution if you are doing maintenance out in the field and you have to drag out 10 equipments to test a radar. And this is why we boosted up our oscilloscope to actually go in and have a look at what is going on. The oscilloscope is not a complete substitute for the solutions we have with spectrum analyzers, signal generators, and stuff like that. But for maintenance, for repair, and for testing and production, I thoroughly believe that our oscilloscope can actually handle these jobs. There are other things like noise figures and other things where you will need maybe network analyzers, spectrum analyzers. But you'll see even some of the new things that's coming into radar where there's even communication signals embedded on your radar signal. And we can even handle these with oscilloscopes. So this is something that we find is very new. So I'm going to talk also quickly because phase coherency is getting into a big topic on radars. And I'm going to talk briefly about the new antennas. They're not any longer just swirling around on top of the building, but they're actually having antenna arrays and can do beamforming and can do three-dimensional lookout for what is going on. And in this case, I'll just take a very, very small brief on radar warning receivers and what is going on in the EW as well. Okay, let's dig into it. Back in the old days, for the new antenna arrays, for multi-antennas, for beamforming, you would have needed a network analyzer to test these things. You still do for some, let's say, advanced measurements, but for maintenance setup, the network analyzer is actually, it's cumbersome to use because you have to calibrate it. You have to make sure that your cables is probably aligned, and there's a lot of other things. So it's not an easy thing to do these measurements on these antenna arrays. Our solution now is actually to go in and say, yeah, okay, phase coherency and oscilloscope, at least from our side, have the channels on the oscilloscope, they can work phase coherent. And this gives a very easy access to look at what is going on in these complicated setups. So basically here, you can go in and you can do, let's just go one up. So today, connecting the oscilloscope, you see I can do the phase coherency, multi-channel measurements, and I don't need a very complex setup, and I don't need a complex calibration. So this makes works in the field much, much easier. Even in production setup, it makes it much, much easier to do. So it's a cost-effective solution. We have on the oscilloscope, we have possibility to add different softwares on it. And with that one, I can actually do a big variety of measurements on pulse measurements. I can even connect it up to MATLAB, and I can actually do really a lot of things where you would need spectrum analyzers and you would need complicated test equipment. So here, this makes everything much easier. We are now capable of doing these measurements up to 16 gigahertz with our latest oscilloscope. Of course, as you can imagine, frequencies are going up. So watch out for new things that's coming if 16 gigahertz is not enough for you. Just to give you a brief introduction to what we can do with these softwares. We can actually go in and put a software on it, and I can use my oscilloscope as an IQ analyzer for baseband, and even up to higher frequencies than baseband with the 16 gigahertz oscilloscope. And I can do all these measurements that you would use a spectrum analyzer for. Bear in mind that these measurements is limited in dynamic range. So don't think that you can take the oscilloscope out with an antenna in the field and get the same results as a spectrum analyzer. For measurements in the field with interferer around and stuff like that, the spectrum analyzer is still the preferred choice. But at least in a control setup where I'm doing maintenance, I'm doing repair, I'm doing production testing, I can do these measurements up to a very, very high level. I can, for the radar, which is very important, I can do the pulse analysis here with a software. I can do modulation analysis, so I can do all the standard measurements on AM, FM, phase modulation. I can even do transient analysis with the radar since it's pulse turning on and off. It's important that you also have a look at how does the radar power up, how does it power down? Do I get the full signal within my pulse? I can even do vector signal analysis. I can do generic OFDM analysis, which will get into a bit of the future that we are starting with, because on the new radars, there are actually embedded some OFDM and special modulation signals to do certain kind of communications. So here you see, you would have needed a network analyzer to do this. You would have needed a special spectrum analyzer. You would have needed maybe oscilloscopes. You would have needed a modulation analyzer. And all of this can now be done with one instrument. You see, if I have the pulse measurements, actually with the oscilloscope, I can do all these standard things as pulse rate and how is the pulse, how is the stability of the pulses. I can do the modulation on the pulses. I can automatically go in and look at if you have a multi-mode radar that changes modulation from pulse to pulse, you can get an analysis of how is the sequence? Is it doing it in the right sequence? And as I said, now we can do it up to 16 gigahertz actually. And I'll come into the trigger functionality of the oscilloscope, and that gives really a much nicer intro to what you're doing, and you can really look for things. Our motto is, if you can see it, you can trigger on it, and this is actually very, very useful. So with the trigger functions, I can go in and say, okay, I can do all the standard triggering that you have on an oscilloscope. I can trigger on glitches. I can do defined masks on the time domain. I can do defined masks on frequency domain. So I can really go in and say, what am I looking for? Get the trigger. I don't have to sit and mingle around and hope that my trigger will find it. The oscilloscope will do it for you. So another thing is with radars, it's important that your radar stays stable over the time, whether it's multimode or whatever it is. And in most cases, you're not interested in what is going on between the pulses. You simply want to see what is going on every time there's a pulse coming up. And we have a functionality where we can go in and say, okay, only store the pulse itself. We can define the level for looking at the pulses. And by doing this, we can capture a long sequence. We can do measurements over a longer period of time and see that the pulses stay stable. And here, actually having this, you may think, okay, I'm losing some timing information. No, even though that we are just displaying the pulses themselves, they are always tied up to an internal timestamp. So I can even see over a longer period of time, are my pulses drifting in time? Are they stable at the time they should be? And in this case, it gives possibility to have a broader view on what your radar is doing. So let's just see. What can we test with the oscilloscope? Well, as long as your radar is below 16 gigahertz, I could even test also the RF part of my radar. But definitely where you can get a fantastic view of what you're doing is from the IF down and from the baseband up to the IF. And here you see in the green that I can test pretty much all of these things in the box. If I have a coho, a local oscillator, I may need or I will need special analyzers for local oscillators. And these oscillators is very high stability, they're very clean. And in this case, you need special analyzers for them. I'll need special network analyzers to test my up modulators, my mixers and stuff like that in details. But I can definitely have a look at what is coming out of my radar if it's below 16 gigahertz for the time. So you see, if you're working on radars below 16 gigahertz and you're not working out in the field trying to sniff out what the enemy is doing, you get pretty much a test equipment that will provide you with, I would say, 90% of the measurements that you need to do maintenance, to do repair, to even do a performance check of your radar. So I think with these things, you get a complete new possibility of do things that you may only have dreamed of, and everything in one instrument. So let's just, my computer is somewhere. Okay. With our oscilloscope, it's no longer just looking at time domain. With our oscilloscope, we can do the RF domain. It has a really very nice spectrum analyzer in it. I can look at the power supplies and see how is my power interface, how much power is being taken out. And for radars, I can go in and see, are there any glitches on my power supply? Because I'll degrade your performance of your power supply. Sometimes it's even the cause of faults on the whole thing. I can do bus interfaces. I can even use it as a voltmeter. And you see, for the bus interface, I can do all the standard buses. I can decode the buses and look into what is going on. So this gives you a possibility to look into all different angles of your signals. I even have a possibility that if EMC-wise something goes wrong, I can have a look in the frequency domain. If I have some glitches in the frequency domain, I can trigger on it, and I can see the exact same signal in the time domain, or I can trigger in the time domain and see the exact same signal in the frequency domain. And in this case, debugging and saying, where does this fault come from? What is causing the glitches in the EMC performance makes it much, much easier. So today, the radars, multimode, frequency hopping, whatever is going on, here, this means we're going into high-speed digital interfaces. We're using high-speed components, so you need really oscilloscopes that doesn't miss a thing, and oscilloscopes that gives you really a nice view of the signal fidelity of what you have, that you can really see what is going on. So let's have a look. Let me just get the whole thing on. So for the digital part, I can go in and look at the eye diagrams. I can define here a mask and say for my eye diagram, if it closes down below certain levels, it can trigger on it. If it's just a one-off fault, I can catch it. So I get a full look at what is going on. And here again, at the same time, I could have time domain, I could have frequency domain. I could even go in and look at the jitter. So here you get really a tool that can look into what is going on your digital part. And even for the buses that we have in there, we can do compliance. You have an old oscilloscope that makes a lot of noise. We are very silent, so you can hardly hear it working. We can making it very fast. We can do the eye diagram. We can do real-time histograms. We can get real-time up to 16 gigabits with serial pattern triggers, so we can trigger on the bus. We can even do measurements on the clock data recovery. We can do, what I think is very important, we can do a real-time de-embedding. So in this case, if you're not totally matched to your device under test, it doesn't have 50 ohm, we can put in these data of how is your matching with your device under test, and you will get a de-embedded display on your screen. So let's see. So it's fast eye diagram analysis. It's jitter. It's what is also a new thing. We can do time domain reflection, time domain transmission analysis. And here, this offers a possibility to look into things where you would have needed a network analyzer before. And now you can actually do these measurements with where you think, it's coming because something is broken down at the front end of my board. Then you can actually go in and say, I have a golden device, and you can go in and take a golden device and say, what is the time domain reflection that I get out of this device? And then you can go in and take your faulty board and look at it. So if any component is causing a mismatch on the front ends, you can go in and say immediately, okay, you have a fault. Not only seeing that, yes, it's not matched anymore, but you could also go in and look at the time domain and say, how far into the board is this failed or this fault actually occurring? So it offers complete new possibilities for repair and also for a fast analysis in the field where you can say, yeah, definitely it's my front end where something is not matched anymore. And these things, you would hardly be able to find it with standard small test equipments as it was before. We also realized that with the fast radars, you need very fast RAM circuits on your board, and sometimes it could be maybe loose connections or whatever. And here you actually get a full capability to go in and look at read-write, and you look at data eyes and a combination of real-time and de-embedding. So even for your memory section on the radar, you have pretty much a full test setup with just one oscilloscope, the right probes, and you can really look into whether it's some faults from your memory section. We can go in and do express debugging. So even for PCI, we can go in and look at how is the PCI conformance. You can easily find the faults on PCI, which is still used in quite a lot of radars actually. We can go on and say, yeah, if we can do the high speed, of course, we can also do the low speed digital, which is still a part of, let's say, the control interface and stuff to the radar. So here you see we have a large variety of buses, which is directly supported. So you can go in here and say, okay, I'm using maybe a mill bus, and you can get it directly decoded. You can use it for trigger events. So if you have a feeling that your radar on certain trigger events where it's shifting mode or whatever, that it may be doing something wrong, I can trigger on this specific event and get the measurements. So in this case, I can get the measurement for time domain, frequency domain. I can get the whole thing in one. And of course, I can go in and look at the protocol. So let's have a look. So here I get actually a very comprehensive insight. So if you have in your protocol that you control the gain and stuff like that, I can see all of these parameters straight off the oscilloscope. I don't need to have complicated setups. I can even trigger on the protocols, as I said before. And I can, of course, analyze up to the different standards here. So let's have a look here. So for the thing here is very often people don't realize, but mobile phones, radars, whatever, anything that's pulsed, maybe your power supply is not doing the right thing, and it can have glitches in there because switching on the transmitter, switching off the transmitters, a lot of things can happen. So in this case, it's actually very useful to have an oscilloscope where you can look into not only the RF and the performance of the components and the boards and the radar, but also having a look at, is my power supply actually stable? We have an option for, or not an option, for some of the higher end oscilloscopes. We can actually go in and get a 16-bit resolution on measurements. We don't have the full bandwidth when we do 16-bit resolution, but it offers me a chance to go in and look at ripple on DC, and looking at it at a very, very high resolution. So I can find very, very low ripple. I can find anything that has glitches on it. I can look at drift over temperature because I'm not using the AC input. And I can actually use it also to do EMI debugging. For mobile phones, it's actually also a question about how much power is my phone using. On radars, we normally have, let's say, a high power interface. So it's not so much of a concern how much power does my device consume, but this could also be done just to have a look at if something goes wrong, your power consumption may go up, and this one you can easily find as well. So with this one, we have the 16-bit high definition modes. We can do sensitive triggering. So we can even do triggering on these ripples. We can do frequency domain triggering on it. We have a extensive set of power rails. So it offers you really a possibility to hook into your power supply section And it gives you very good analysis because, as I said, you can do it both in the time domain and the frequency domain. So if some kind of spillover from your oscillators is creating some kind of harmonics, you can also find this very, very fast here. Okay, just one thing here, if you're working with satellites, basically also the power consumption is of concern. And with the satellites, all of these measurements is actually something that you have to look out for. Okay, so with the oscilloscope, we can do the power integrity, we can do RF, we can do low speed, we can do high speed. So it should leave almost no wishes that we can't fulfill. So this was a really fast tour through what we can do with the oscilloscope, and I hope I managed to show you some things that you have dreamed of. And with standard oscilloscopes, most of or a lot of these things is definitely not possible. From my side, if you have any questions, please contact our frontline in Jakarta. We have an office in Jakarta, and you can contact them. If they can't answer, they will probably put you direct in contact with me, and I'm happy to help you out. So this is something where hopefully I got you a little bit interested. And from our side, we think this is a way to cut down cost on testing radars. Testing radars is a very complicated setup if you want to do it to the full extent. And here we think that we offer a very, very cost-effective solution. And definitely for work in the field, we are sure that instead of dragging spectrum analyzers, signal generators, and whatever into the field, having the possibility to get really an 80% look into what your device is doing with one instrument should be something very, very interesting. Thank you for your attention.
Thank you, Mr. Rasan, for your interesting topic. So we have a few time left here. So I want to open the Q&A sessions. Maybe one or two questions that is possible. So please, for audience who want to ask, write down in the chat, or you can directly ask in the room, please.
So far, I didn't see anything in the chat. So.
Yes, maybe still.
Well, I mean, this is always the case. I hate this thing with the computer. I would like to be on location and see your pretty faces. And then I could probably see if any of you is looking really amazed and then say, hey, what didn't you understand?
Yes.
But anyhow, with COVID, I saw that you're doing a lot also on monitoring COVID people and stuff like that, which I'm really saying it's a good thing. But here with the COVID, I guess we have to do it this way. And here in Germany, the situation is getting really horrible, I can tell you. So it's not only Indonesia having this problem.
So there is no questions, I think, but I want to just make some question for you. Just
yes, please.
During this presentation, if you want to say that the measurement using network analyzer is not possible again, or you might want to say that measurement using network analyzer can be changed with oscilloscope once. It's correct?
Yeah, that's correct. I mean, there are limitations. Let me put it this way. If you're doing development, if you're doing really the high performance test of radars, you will still need conventional test equipment. But my personal feeling out of experience is that at least something close to 98% of the measurements for maintenance and for repair and for fast check of performance, you can actually do it with an oscilloscope nowadays. So this is something I personally find is new. And the next thing is, I'm sure that everybody working with radars have been using oscilloscopes, because we have to look how is the pulses in time domain and stuff like that. And we all know how tiresome that can be. And especially with old oscilloscopes, where you had to fiddle around with the trigger for probably even up to 1 hour before you get the trigger settings right. And then you don't get a stable view of what you want to measure, because then the trigger one time is there, then some noise comes in and it shows the wrong signals. But having these extensive trigger possibilities, it makes it so much easier. So seen from that point of view, I think that we are onto something here where, yeah, maybe you have old oscilloscopes and you're getting to the point, they're hard to work with and they don't always show what we want. They have their limitations, of course. So maybe it's time to think about exchanging your oscilloscope to the all-around test equipment, which is available now.
No, thank you for your explanation. So I think there is no more question. So it is my pleasure to moderator, and I would like to give your appreciation during this time. I think early time in Germany. So
very early.
So it's my pleasure to give your very interesting presentation. So this is the end of our presentation. So thank you very much for our audience, participant, and all of you. So I will come back to MC. Thank you very much for all.
Well, thank you for having me on. It was a pleasure for me.
Yes,
so
you're welcome, sir.
I hope that in near future we can meet in Indonesia, then meet face to face.
Yes,
so
someday.
Get back to normal.
Yes, I hope
so. For you guys, I wish that you have a very nice session and enjoy the rest of your session, because it's going on for some time, as I understood. So I'm happy to see that there's so much interest, and thank you for arranging this thing.
Yes, thank you.
Thank you. Okay.
Thanks to Mr. Hana Arisesa for having moderating our sessions, and also to Mr. Andreas Larsson from Rohde & Schwarz Indonesia for having joined us really early from Germany. And now we are continuing our agenda, that is the parallel sessions. And also, before we assign the breakout rooms, I would like to remind you several points regarding the paper presentation sessions. First, keep the naming convention according to the guidelines, so our host can monitor whether you are in the correct rooms. Second, we also encourage you to keep logged on even during the lunch breaks. For the presenters that are in their assigned sessions, please turn on the video for the whole session, including when you are not presenting. Please be reminded it is compulsory for presenters to be present at their respective Q&A sessions, and also please prepare your presentation file ready for the Q&A session, so it will be easier rather than checking from the video. Also, do not forget to fill in the attendance form as the presenter when you are in your own session. And for all the participants who want to ask some questions during the Q&A sessions, please use the raise hand menu that you can access from the reactions menu in your Zoom applications. Tes, tes.
In many applications, such as in defense, in medical detection, vehicle or autonomous vehicle, and so on. So before we start our discussion, let me check for all presenter is already in here. In this session, we have 4 presenter come from Indonesia, Japan, and Mr. Budiman. Oh, Mr. Budiman, okay. Okay, there is have a technical issue, I think. Hello, for Anjasmara. Please switch on your mic.
Hello?
Yeah,
Am
okay.
I ready to hear? Oh.
Second presenter is Dwi Sinta Anggreni from Universitas Tadulako, Indonesia. The third presenter, M. Faisal Amri from Indonesia Institute of Sciences, Indonesia. And the last presenter is Ahmed Hussein from Prince Muhammad University, Saudi Arabia. I would like to check if all the presenters are already standby here. So for the presenters, please turn on your camera. William Lupito, okay. Muhammad. Dwi Anggreni. Dwi Anggreni. I couldn't find Dwi Anggreni. Oh yeah, okay. Okay, thank you. Okay. For participants who would like to ask the question, you can type your question on the chat box or use the raise hand feature if you want to ask the question directly to the presenter. I also would like to remind all attendees to fill out the attendance form, which will be shared in the chat box. And we already have the pre-recording video from each presenter. And each presenter will be given 20 minutes for presentation and Q&A. So for all presenters, please have your presentation file ready, just in case you need it in the Q&A. And without further ado, I would like to welcome our first presenter, Mr. William Damario Lukito. Mr. William Damario Lukito, the time is yours.
Okay, thank you, Mrs. Carrier-Well. I think the video should be played from you.
Yeah, okay. Let's start the video, please.
Greetings, everyone. My name is William Damario Lukito from the School of Electrical Engineering and Informatics,
Recording in
Institut Teknologi
progress.
Bandung, Indonesia. In these special occasions, I would like to present our title, Multi-Features Based Baseband Modulation Classification Using Support Vector Machine. The authors of this work are myself, together with Faras Eldi Rashad and Evrina Yanti. the background and the motivation of this work. Next is features extraction that will present about the feature selection that we used in this work. Then we will discuss about implementation of this work, following by the results of our work that also covered the analysis of the obtained results. Finally, the conclusion sections that will present about the conclusions of this work and the feasibility of the future works. Now we are going to start with introduction. Automatic modulation classification term refers to a system that would automatically classify several types of modulation without knowing prior information related to incoming signal. It becomes a very challenging problem in communication system theory, considering its useful application in various real-world problems such as link adaptation, as well as military scenarios. Lately, the implementation of modulation classifier has been widely based on traditional methods. Meanwhile, in this technological development era, machine learning has been frequently used to solve many classification problems. Therefore, an idea to implement machine learning for modulation classification came up and is expected to complete complex problems in modulation classification implementation, including both interclass and intraclass modulation classification. Before modulation classification could be enabled, a classifier system needs a pre-signal processing to acquire some unique features for its modulation that registered in the pool. This process is called as features extraction. It is known that each feature has its own advantage and disadvantage, particularly on interclass and intraclass classification capability. Some of the signal features are only performed properly on interclass classification or only on intraclass classification. Many algorithms could be used for classification problem. However, this research will be focused on support vector machine because of its robustness and reliability on many classification cases. In this research, SVM algorithm will be used to obtain a classification rule model that could classify BPSK, QPSK, 8PSK, 16QAM, DFSK, and 8PM. The first three will represent intraclass classification, and the remains represent interclass classification. Basically, most of modulation classifier systems were built based on RF or radio frequency signal processing. However, RF-based signal processing, therefore the computational resource could be decreased. Now we will present about features extraction. There are three bases of features that we are going to present: the wavelet transform, spectral, and higher order statistics. In order to classify modulation types, wavelet transform could enable a lower computational complexity for classification algorithm. It is good for interclass modulation classification. The main idea of using wavelet transform as a feature is utilize the variance of its detail coefficient outputs. Multi-level outputs could be used, but this research was using level 3 and level 4 detail coefficients. Discrete wavelet transform could be calculated by passing the signal to low-pass and high-pass filter simultaneously. The output of low-pass is approximation coefficients, and the output of high-pass is the detail coefficients. To increase the detail coefficient resolution, several wavelet transform will be cascaded with the approximation coefficients will be set as the next wavelet transform input, and so on. Therefore, we could get a multi-level wavelet transform. After a 4-level wavelet transform has been implemented, we acquired a level 3 and level 4 detail coefficients. Finally, we could obtain the variance of level 3 and level 4 detail coefficients. There are 3 main spectral features that could be extracted uniquely for different types of signals, such as amplitude, phase, and frequency. But in this work, we choose the phase and amplitude only. The first feature is related to the symbol phase, which is the variance of symbol phase. And the second feature is connected to the amplitude, which is the standard deviation of the absolute value of the normalized and centered amplitude of signal samples. The last feature basis is higher order statistics. There are 2 features that we use: moment and fourth order cumulant. And for the Gideon moment, we use x equals 4 and y equals 2. And we need to take note that 4 order cumulant has a good performance in interclass classification. Next is the implementation section. Related to the implementation, there are 3 crucial factors that we need to prepare: the data set, classification algorithm, and pre-signal processing. Machine learning needs to train its predictors by using a data set. Since there is no related data set available, we need to generate a tailor-made data set. Data set will be generated using one SDR as a receiver and one SDR as the transmitter, and the signal will be transmitted over the air. We use adalah Pluto as the SDR, and we need to take note that in this dataset generation, we will not observe any channel distortion such as multipath. As it was mentioned before, we use SVM. And the implementation of SVM algorithm is using MATLAB's classification learner, since it is easy to use and compatible with the signal processing function that we use in this research. As we have mentioned before, here are the table recaps classification features that we use. And the last part is pre-signal processing. Pre-signal processing is used to generate the data set and the testbed for the classification model. Processing takes place in the baseband frequency range instead of the RF frequency range. There are 3 parts of pre-signal processing: automatic gain control, port synchronization, and finally the fine synchronization. And the output of the pre-signal processing will be the feature extraction phase. Now we are going to present our results. After SVM has performed its training, we acquired a confusion matrix as the classification rule model performance. This obtained model has a 91.4% of accuracy, with the lowest classification rate is for QPSK, which is 76.2% of accuracy. We can see that the most common error occurred in QPSK, 8PSK, and 16QAM classification, since these 3 modulation types have relatively the lowest accuracy. Meanwhile, BPSK, BFSK, and 8PAM are showing better results, with no classification rate under 90%. BFSK classification has 100% of accuracy, and it is logical since FSK is the only non-constellation based modulation type. However, for further analysis, one of the ways is to find out the uniqueness of the predictor. Identify the uniqueness of each modulation type, we could find the expected values of each predictor. If we plot the table into line curves, then possible misclassification errors could be identified with a graphical approach. Logically, when two or more lines are coinciding to each other, then we have to take a note that errors might occur. It implies that the features we use are not unique enough to perform this classification. The figure shows us that QPSK, 8PSK, and 16QM line tend to coincide. It proves the three lowest accuracies given by the confusion matrix. And another undetected error also might occur on BPSK and 8PM classification, since those two lines are also coinciding to each other. Meanwhile, the figure also shows us that BFSK has the most independent line. This corresponds to the confusion matrix that shown BFSK classification has 100% of accuracy. From these results, we could say that the chosen predictors are not unique enough to perform both interclass and intraclass classification. From the results that we have got, finally, the conclusions. SVM algorithm obtained a classification rule model with 91.4% of accuracy without any optimization applied, with the lowest rate is 76.2% for QPSK classification. However, some errors might occur in QPSK, 8PSK, and 16QM classification. According to the expected values of the predictors, the classification of BPSK and 8PM also might be confused. From this research, we could conclude that the combination of 6 predictors used are not robust enough to perform both interclass and intraclass classification. Therefore, in the future works, it will be better if we could find more unique features as the input predictors, or just performing optimization to the model. Thank you for your kindly attention. Stay safe.
Okay, thank you for the presentation. And we will continue with the Q&A. So I would like to invite the audience. If you have any question, you can ask directly, or you can use, or you can type it on the chat box. Yeah. Any question from the audience? Oh yeah, Muhammad Rizky. Muhammad Rizky has raised hand. Yes, you can directly ask the question.
Okay, can my voice be heard?
Yeah.
Okay, thank you, Mr. Lukito, for your interesting presentation. I would like to ask you about your work. How do you suggest development to your work so that you can better predict the different modulations, such as QPSK and 8PSK, which in your work doesn't have the best prediction capability? Thank you.
Okay, thank you, Mr. Rizky, for the question. I think there will be several alternatives to do better in prediction QPSK and 8PSK. First, we might change the SDR types, since I think that the SDR types Adrian Pluto is not performing better at classification and also the operational processing. And the second alternatives, I think we might to find and explore another feature base that could perform better in the classification. And finally, I think before we do create the classification rule model, I think it is better to analyze it first and do the uniqueness of predictor analysis before we train the model. I think that is my question.
Hi, may I ask a follow-up question?
Yes, please.
Any more question from?
Yeah, I'd like to ask a follow-up question, please.
Okay, thank you.
You said that this the SDR that you chose, the Adam Pluto, have a effect on your result. Can you tell us more why that is? Why do you think that is? Thank you.
Okay, thank you, Mr. Rizky, for the update question. So after we do create the data set with the Adam Pluto, we see that the Adam Pluto cannot receive the constellation diagram from the transmitter good, and the Adam Pluto has slightly in phase correction, and we might do the I think the good phase and carrier recovery, but the Adam Pluto cannot handle it. So the constellation at the receiver was bad, and I think that is affect our work.
Okay, thank you very much for explanation, Mr. Lukito.
Okay, thank you, Mr. Rizky, for the question.
Okay, thank you. Any more question? Would conclude this presentation, and I will welcome our next presenter, Inta Anggreni from Universitas Tadulako, Indonesia. The time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Thank you for the opportunity. I want to present our paper with title Influence Intelligent Partitioning SIM for Audio Data Hiding. My name is Dwi Sinta Anggreni. I'm from Department of Information Technology, Universitas Tadulako. And my co-author is Tohari Ahmad from Department of Informatics, Institut Teknologi 10 November. This research is talking about data hiding, where it is a technique to hide useful information into digital files such as text, images, audios, or videos for various purposes like confidential communication, copyright protection, forensic tracking, and content authentication. Data hiding consists of two categories, and in this paper we're talking about reversible data hiding, which is the method that what we use in military and medical areas, because in these areas original images are no less crucial than the secret message itself. Previous work has been done in reversible data hiding method, particularly with integer transform. And one branch of this method is different expansion introduced by Tian, and another method is proposed by Avatar. And the method is called generalized different expansion. Low et al. Extended Tian method by adding reduction function in different value of the pair pixel and called LDE. But all of these reversible data hiding methods are mainly applied to image data. In 2015, Choi et al. Utilized GDE and image data hiding method to audio data. Xing and Lee introduced reversible audio data hiding method that uses non-causal prediction of alterable orders, while another improvement of audio data hiding based on RDA and mirror embedding method proposed to maintain the audio quality by Samudra and Hari Ahmad. Related works that inspire our research are intelligent partitioning method and concurrent expansion method. Intelligent partitioning method is defined as a partitioning audio files into 2 or more data dimensions with smaller bit. This dimension aim is just to make the dimension of the audio data similar to image data in order to make the image data hiding method can be applied to audio data. While controlling expansion method is a method from Anggreni and Ahmad developed a data hiding method where the embedding process is executed in a pair of pixel and a random value to control the expansion. This method is the improvement of DE and RDE, and the embedding process is performed on the difference value of the pixel and the random value. There are 2 proposed methods that we introduced in this paper. That is proposed SIM1 and proposed SIM2. But before, I want to explain about the main process in this experiment. The first process is encoding process, where we conducted intelligent partitioning process and then embedding process. And then decoding process is the process where we conducted intelligent partition, and then we perform extraction and recovery process. Proposed scheme 1 is the figure of our algorithm. So we need to input is audio data. This is the audio data, is the original data. And then after that, we find the average value P, segment for every digit, and calculate variance for V. And then we calculate the capital P. And after that, we sum the P in order to sort the p-value in ascending mode. The partition then performed based on the odd and even ascending index. We can see that we have 1 to 14 digits, while digit 15 and 16 is safe because we want to use it on the last process. So we share the index by odd and even index. So the odd, we give it to the part A, and the even index we give to the part B. So in this proposed scheme 1, we separate the audio data into 2 parts. While the proposed scheme 2, we separate the audio data into 4 parts. You can see that the process is also the same with the previous process, while the differences are we save the digit LSB is 13, 14, 15, and 16. After that, the rest of the digit we share by the odd and even ascending index. The data used in the experimental test was audio.wav format. The audio data encompassed a collection of musical instruments with 3-second duration, 570 kilobyte size and 1411 bit rate with 16 bit depth and 44,100 frame rate. 12 audio files with various instrument and genres were derived from the IRMAS dataset. The secret message used was in a text format with 2,579 bytes and 3,971 characters, consisting of 5 paragraphs and 5 versions from Lorem Ipsum text. Quality and capacity measurement. The quality measurement is used signal to noise or SNR, while the capacity measurement is determined by calculating the size of audio data that is formed, in this case is the LSB. The experimental result. Table 1 shows comparison of the audio quality and the reading capacity toward IP method. So we use the method in 9, and we can see that the lowest SNR is for audio with guitar and jazz blue for purpose 1, while for IP purpose 2 and IP is saxophone and pop rock. While the highest SNR is goes to piano and classic for all of the 3 methods that we use in this experimental. So we can see that the genre of the audio is also impact the result of the quality after the embedding process. Experimental result. Comparison of the audio quality to our image dividing method. So in this experimental, we test the quality of the audio through data hiding method, which is DE from Tian, RDE from Lo et al., and controlling extension from Andal and Ahmad. We can see that from all the 3 methods we tested with IP method and IP proposed 1 method, where the lowest SNR is for BETR, which is 6, and the highest from Tian is 24 for piano classic, and the lowest from Tian for IP proposed 1 is 10.21 for piano classic, and the highest is 15 for piano pop rock. While method at for method Lu et al., the lowest for IP is 11.07 for saxophone and pop rock. It's also the lowest for method from Andal and Ahmad. And the highest is for the audio piano classic, which is for Lu et al. And Andal and Ahmad. While the highest for Lu et al. In IP proposal is 2. You can see that the experiment showed that the second experimental test, we compare the audio quality toward image data hiding method to IP method and IP purpose 1. We didn't test with the IP purpose 2 because the method from DE, Tian, and et al. Cannot be applied to IP purpose 2 because the partition is more than the dimension that required for both of the methods. So we restricted the test with only using IP and IP proposed one. You can see that the result from method Anggreni and Ahmed is better than other method, and the capacity also is better for method Anggreni and Ahmed. Quality is the comparison of the audio capacity toward the original capacity of the audio. The capacity of original audio is 264,598, while IP is double of the original size. IP proposed one is also double the original size, while IP proposed two is quadruplet the original audio size. We can see that this is the real size before the method of the embedding process is conducted. So this is the real size after the partition method is conducted. So you can see that IP proposed to get more or better result than the other method. For dual quality, the experimental result revealed that combining piano with classical genre, piano with blue jazz genre, acoustic guitar with the pop of piano generate better SNR values than other combination instruments. While the capacity of the application of the method is influenced by the data hiding method that was used, the comparison of capacity with the combination of data hiding method, Anggreni and Ahmed, and partition method, and the original capacity of the data can be seen in table 3 and 4. And can be seen that the proposed method 2 is better than other method. For the robustness, research shows that SNR results were above 55 dB. This indicates that this method is good as masking changes or distortion that occur after embedding. Reversibility, this proposed method utilizes reversible data hiding, so the partition method must be reversible also. Because in the process of returning the index return to the original order, but only needs variance data and even out sorting from index 1 to 14 or 1 to 12 for IP proposed to. So there's no need for additional information to be inserted into the data cycle. The conclusion, this paper introduces the proposed method of intelligent partitioning. This method were proposed to support the controlling expansion method applying to audio covers. The experimental results reveal that both proposed methods obtain better capacity and SNR values than the existing method in some instances. The first proposed IP method generated better quality results above 30 dB, while the second proposed IP method has higher capacity values. In a nutshell, the data type could alter the performance of the proposed method on the capacity and audio quality. For future studies, the partition method can be improved to support particular data hiding methods and be adapted to other image data hiding methods. Thank you. That's all from me.
Okay. Thank you for the presentation. And we still have 2 minutes for Q&A. So if you have any question, you can type on the chat box or ask directly. Yeah. Mrs. Arum Jenny Nitayani, let's go ahead, please.
Thank you, Ms. Karia. Congratulations to Ms. Sinta for delivering a very good research in this session. I just want to ask you how you handle the noise, because as far as I know, if you convert the audio or something then the noise could be created, and how did you handle it? So that's all. Thank you.
Okay, thank you very much for the question. Actually, we try to keep the original data as it is. So before we embed it, we just convert it so that we can make the data to be easy to be reversible. But after the embedded, it's really, really difficult to what it is called. If the noise is added, then we can prevent if the noise is added. So we just have to calculate it. If the noise is really bad, then the SNR is maybe lower. Then if the noise is just a little, then the SNR is mostly above 30 dB. So yeah, the noises, most of it is from the secret data that embedded to the cover data. Thank you.
Okay, thank you, Ms. Sinta. Actually, your research is very interesting. So good luck on your research.
Thank you very much, Ms. Arum Jenny.
Okay, I will conclude this presentation, and we will move on to our next presenter. Please welcome our third presenter, M. Faisal Amri. Let's start the video, please.
Hello everyone, my name is M. Faisal Amri. I am from Instrumentation Development Center, National Research and Innovation Agency, or BRIN. Today I will present my research paper, and the title is Toward Early Abnormalities Detection on Digestive System, Multi-Filters Electrogastrogram, EGG signal, classification based on machine learning. For the introduction, a problem on the digestive system or digestive disorder are suffered by more than 40% people in Indonesia. That data is based from the Ministry of Health in Indonesia, and I got the data from the Tempo magazine on the 2012. The digestive disorder classified are as gastritis, GERD, peptic ulcers, constipation, celiac diseases, gastroparesis, and more than that. But the common problem or common disease that suffer from the people are these diseases. And the newest research finding, the COVID-19 viruses can cause problem in the digestive system. For the citation I got from the gastrointestinal representation in COVID-19 in Indonesia case report. This is from the year 2020, and another paper is from American Journal of Gastroenterology. And for the digestive disorder, there are several tools or techniques for detection and analysis. They are using CT scan, MRI, ultrasound, X-ray, radioisotope, and endoscopy, and another technique. But from these techniques, they have a deficiency or a problem with their method. They are invasive, or maybe make a user or patient not comfortable, relatively expensive, and need a long time for analyzing. So in this paper, I use another technique. They are using electrogasogram. This electrogasogram is a biosignal that record from the stomach muscle, then record the activities and translate it to the wave that we can analyze. The electrogasogram is one of the non-invasive method for stomach problem detection, and record it using some electrodes. And we can combine using artificial intelligence and IoT for faster detection compared to the conventional method that I said before. And the electrogasogram application can be used for electrophysiological studies, therapy, and detection of slow wave abnormalities. And in this paper, we are focused on the third or fourth detection of slow wave abnormalities. And this is the block diagram and that common use for the electrogasogram utilization. And the first, there are some EEG device that placed on the abdomen or stomach of the user and record the raw signal from the muscle and then translate it using the signal processing and using the classification for the get the result or obtain the result. And in the right side, this is some experiment that we have done. We use some simple prototype of EEG amplifier. We built some prototypes. They're using the IoT devices and some microcontroller, and we propose the system for the record the subject in 5 conditions. But in this paper, we not use the data yet because we will use some public data set. And this is the data set that we use in this paper. The data set was acquired from the public data set by Ninat P. Propovic with the sampling rate 2 Hz. And the condition is condition R and 2 stage only. There are fasting for 6 hours and the postprandial after the fasting. And for the postprandial, the recording stage was conducted after 10-minute meals. And for the data recording duration, for each stage, there are 20 minutes. And for the data set, they are using 3 electrodes or channels. And this paper only used 10 persons, and the condition of the subjects or person are healthy without any minor condition or suffer some diseases. And for the placement, we can see in this image on the right PowerPoint presentation, the placement of the electrode was arranged by using 3 electrodes. They are in channel 1, channel 2, channel 3, and the placement in the center of the stomach. And for the reference electrode, they place on the right far from the main electrode. And for the signal processing, there are several stages, and the first stage was preprocessing with the signal conditioning or center by using the T-trending process, and then bandpass filter, and we use 0.03 until 0.25 Hertz because the wave of the electrocardiogram is very, very slow or low, and there are several noises or artifacts from the muscle, so we need to filter using the very low frequency. And then after the bandpass filter, we rectify the signal by using the rectifier. And for the filter extraction, we have 5 filter extractions. They are mean absolute value or MFV, average amplitude change or AAC, waveform length or WL, maximum fractal length or MFL, and rod mean square or RMS. And for the sample for using the filter extraction of root mean square or RMS can be seen on the image on the right side. This is the right signal, bandpass, and after detending or signal conditioning. And this is the rectifier result. And then this is the RMS. And this is the same method, but in different condition from the first image. And after got the filter extraction, the data that acquired need the scaling the filter value because we need to get the same value between 5 filter extraction. And then from the 3 channels all electrode, we conducted the data averaging and then the normalization. And for the classification, we use the super vector machine or SVM, and then artificial neural network by using a 2-layer or P-layer. And for the configuration of the data before the classification stage, we use 10 subjects that classified or used by 2 classes and 3 channels, and then the total data of data are 60 data. And for the first experiment, we used 2 filter extraction, so in the total are 120 data, and until the experiment 4, we use 5 filter extractions, and the total are 300 data. And for the data averaging, this is the sample, the result sample from the MFV and SSC means, MFL, and RMS, and also WL mean. We can see the result from the data averaging. They are very, very different from the error or the data deviation. We can see there are some uncommon condition between 5 filter extraction. So we need a normalization, and this is the result from the stage above. We need a normalization because we can see from the slide before, the trend are very different, so we use scaling before the normalization, and the scale is from 0 until 1, and then we use a standard deviation for the normalization. And this is the result from the normalization. From the 5 filter extraction, we have a same trend, except from the MFV filter extraction that have different trend compared to the other classification normalization. And for the data was at 70% for training and 30% for tests. And the result, we can see the highest accuracy was occurred from the SVM or for the 82.3%. We can see the complete result and the comparison between the and SVM and the number of sample and also the filter extraction from this table. And this is the for the complete result for the supervector machine. We can see the result here on the table also. So comparing from the SVM classification, we have a trend. They become higher on the accuracy if we use more feature extraction and also dataset. But the best result is still on the SVM compared to the ANN. And for the conclusion of this presentation, we have been conducted the data classification on the 5 filter extraction and 2 classifiers using SVM and ANN on the 2 classes that are postprandial and also fasting condition. Results show that SVM classifier have better accuracy than ANN. And for the future folks, we will implement other classifier, maybe on the using deep learning based to our self dataset that we have done on the 11 subjects until now with the 5 conditions. And that's all for my presentation. Maybe if you have some questions, can share and give or.
Okay, thank you for the presentation. And we have 4 minutes for Q&A. If the audience have any question, please go ahead. You can type on the, okay. We have one person. Yeah, please, Mr. William.
Okay, thank you, Mrs. Carrier and Mr. Faisal Amri for the interesting presentation. And I have a question about the overfitting occurrence. And what do you think about the overfitting occurrence in your classification model? Because I see that you had 6 features as for the features extraction. Thank you.
Okay, thank you for your question, Mr. William. For the overfitting, yeah, that's a problem for if we use or classify for the classifier. If we use more than 2 classifier model, and as we can see at my presentation, the data is very different from first classifier until 5 classifier. So for the overfitting, I use scaling method. So for the result from the 5 classifiers, I use scaling from the Z-score. So the scale is a range from only 0 until 1, and then for the error or the deviation, I use the standard deviation. But for the input or the set of the classifier between the ANN and also SVM is still used only in the scaling or the fitting process only, not the standard deviation. Okay, maybe that's my answer.
Okay, thank you, Mr. Faisal Amri, for your answer.
Okay, thank you. Is there any more question? from the audience? Okay, if there is no question, then I conclude the presentation of Mr. Amri. And I think our last presenter, Mr. Ahmed, is not present right now. So I also will conclude this parallel session. And on behalf of Icramet 2021 committee, I would like to thank all presenter and participants for your engaging participation during this session. And we will have lunch break and we'll continue the next parallel session at 1 p.m. So see you later and Assalamualaikum warahmatullahi wabarakatuh.
Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development, and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by various research institutes, and have more than 70 research centers and supporting units. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Jurnal Elektronika dan Telekomunikasi or JET is a journal published by Pusat Penelitian Elektronika dan Telekomunikasi LIPI. JET presents high-quality articles on the latest research and development in the field of electronics, telecommunication, and micro or nanoelectronics engineering. JET provides a platform to share research in the areas such as digital signal and image processing, network theory and circuit design, radar and sonar technology, antenna and wave propagation, wireless and optical communication, microelectronic system, electromagnetic and electronics materials, emerging and advanced fabrication technology, and so on. JET is indexed by internationally renowned indexers such as DOAJ, Google Scholar, Mendeley, and etc. JET is also ranked as Center 2 in Kemendristek Green accreditation system. There are 2 JET editions published every year, and all of them are available in open access to support global exchange of knowledge. All submissions in JET are accepted online, and each submission will be blindly reviewed by at least 2 peer reviewers. Most importantly, all submissions are free of charge, and therefore, no article processing fee applies. For more info, please visit www.journalet.com or visit our social media accounts.
Imagine that you are responsible for designing a modular GPS smartwatch. With each segment of the strap containing a different electronic module, there are hundreds of possible configuration alternatives. How do you identify challenges with connectivity, signal integrity, and electromagnetic interference early on? With electromagnetic simulation technology, you can not only analyze individual modules, but also the entire product assembly. Here, the antenna sensitivity of the smartwatch is shown with the strongest signal directions shown in red. This allows you to evaluate your product connectivity performance in all possible configurations early on. Human proximity effects can also be analyzed, enabling designers to verify not only connectivity when the watch is worn, but also ensuring that it meets regulatory compliance and electromagnetic safety standards. In this case, you discover that the antenna becomes detuned when not worn on a user's wrist. causing the connectivity to degrade. With electromagnetic simulation technology, you are able to redesign the module's antenna to work on and off the wrist and verify the quality improvement. Now that you have considered electromagnetic challenges, what about considering structural ones? By also performing detailed structural simulations, you can assess the reliability of the watch. This includes advanced simulations such as drop testing and other harsh loading conditions for detailed evaluation of the watch's structural and functional integrity. Another critical component of the smartwatch is the touch screen. Simulating pressure-based sensing requires coupling between the electrical and structural simulations to ensure the screen is sensitive, but not too sensitive. Soon, touchscreens will provide haptic feedback. Electroactivated polymers, which deform with electrical input, can provide tactile feedback to your hand as you interact with this screen. Imagine a feelable button click. We feel that coupled electrical structural simulation will play a key role in evolving flexible electronic design, enabling the development of future products that will provide extraordinary experiences to consumers.
Next-generation technologies like radar and satellite communication with high data rates call for innovative testing solutions to develop and manufacture RF components. A critical part in the development and design of large communication systems, as well as single RF components for microwave devices like oscillators and amplifiers, is phase noise measurement. This is used to show developers if a signal source noise is as low as it should be. With the launch of the R&S FSPN, Roda & Schwarz is adding a new member to their phase noise analyzer portfolio, enabling increased efficiency and reproducibility of phase noise measurements and VCO characterization from lab to production. The R&S FSPN only takes a few seconds to perform VCO characterization. This not only speeds up the lab processing time, but also multiplies the measurement throughput in VCO manufacturing lines. As the leader in this area, Roda & Schwarz was able to develop the best phase noise and VCO tester on the market, whose pre-configured setup allows easy testing and instantaneous results for the lab, as well as for production applications. The R&S FSPN, unrivaled sensitivity meets high speed. Find more information and learn about phase noise and VCO testing on our website.
Penggunaan sinar radiasi ultraviolet C atau UVC merupakan salah satu metode dalam sterilisasi. Sinar radiasi UVC dipercaya dapat melengkungkan struktur materi genetik virus dan mencegahnya berkembang. Pusat Penelitian Elektronika dan Telekomunikasi LIPI telah mengembangkan alat sterilisasi ruangan portable berbasis sinar UVC. Sisusan atau Simple Smart UVC Sanitizer memanfaatkan sinar UVC yang dikendalikan secara cerdas. Sisusan memancarkan sinar UVC yang menyinari langsung permukaan benda di ruangan atau kabin.
Seperti kita ketahui, sinar UVC adalah mempunyai kemampuan untuk melemahkan mikroorganisme, termasuk diantaranya adalah bakteri, virus, pada suatu permukaan benda dan di suatu ruangan. Sisusan dapat digunakan untuk menghambat penyebaran COVID-19.
Parameter penyinaran dapat diatur melalui aplikasi Android, seperti lama penyinaran sesuai dengan luasan ruangan dan jenis virus atau bakteri yang akan dibasmi. Penjadwalan penyinaran dilengkapi sensor keamanan dari aktivitas manusia. Sisusan didesain dengan sangat sederhana, portable, dan murah sehingga dapat digunakan di rumah tangga, klinik atau puskesmas, sekolah, kantor, dan lain-lain.
Saat ini, kebutuhan magnet permanen di Indonesia relatif tinggi. Magnet permanen adalah magnet yang memiliki sifat kemagnetan yang lama dan tetap sehingga sukar untuk dihilangkan. Magnet permanen banyak dimanfaatkan pengaplikasiannya oleh industri dan UKM pada berbagai komponen elektronika. Namun, tahukah kamu, sebagian besar kebutuhan magnet permanen di Indonesia masih diimpor dari negara lain, seperti Cina, Jepang, dan Amerika. Salah satu magnet permanen yang cukup banyak digunakan adalah magnet barium ferit. Magnet barium ferit, atau yang sering dikenal juga dengan sebutan magnet keramik, adalah magnet permanen dengan rumus BaFe12O19 yang terbuat dari bahan baku utama oksida besi dengan teknologi serbuk. Untuk meningkatkan kekuatan magnet barium ferit, Pusat Penelitian Elektronika dan Telekomunikasi Lembaga Ilmu Pengetahuan Indonesia di Bandung telah menemukan sebuah invensi berupa magnet bonded hybrid. Apa itu magnet bonded hybrid? Magnet bonded hybrid merupakan penggabungan dari magnet barium ferit dan magnet neodymium iron boron (NdFeB) dengan menggunakan teknologi hot press bernomor paten P00201407033. Keunggulan dari invensi ini adalah harga lebih murah bila dibandingkan dengan produk impor. Jumlah, bentuk, dan spesifikasi dapat dibuat sesuai kebutuhan pengguna. Keunggulan lain dari invensi ini adalah menggunakan produk lokal limbah oksida besi, temperatur Curie, dan ketahanan korosinya lebih tinggi dibanding magnet NdFeB, serta kekuatan magnetnya lebih tinggi bila dibandingkan dengan magnet barium ferit. Saat ini, pembuatan invensi magnet bonded hybrid masih dilakukan dalam skala laboratorium di Pusat Penelitian Elektronika dan Telekomunikasi. Pengembangan selanjutnya, invensi ini dapat diproduksi secara massal dan digunakan untuk memenuhi kebutuhan industri elektronika nasional, seperti meteran air, printer, pengeras suara, keyboard komputer, alat bantu dengar, generator, dan motor listrik. Kami menantang Anda untuk menjadi teknopreneur melalui teknologi ini. Apakah Anda berani? Ayo membangun bisnis berbasis teknologi.
"5G is revolutionary. It promises extremely fast communication, ultra-reliable low-latency data links, and support for huge numbers of connected devices. To make it work, network providers depend on micro-base stations to provide high-capacity coverage through beam steering and massive MIMO, that is, multiple input and multiple output systems. The best route to each device is determined by pilot signals and computations on the base station side of the network. Through virtual prototyping with Simulia electromagnetic simulation, specifically CST Studio Suite, you can ensure the best possible network connections, even in complex environments where a hand or a large object in the street may block the direct signal path. You can also optimize antenna arrays and high-speed circuit performance, as well as ensure safety and critical regulatory compliance. Simulia electromagnetic simulation gives you the ability to simulate complex multipath environments, measure signal strength virtually rather than time-consuming manual measurements, and optimize microcell placement. Taking real-world scenarios into account, clean handoffs between base stations can be ensured with no coverage gaps. Simulia electromagnetic simulation provides efficient end-to-end 5G simulation solutions, allowing you to deliver high-performance designs in a short time frame and at lower costs, without compromising compliance, reliability, and safety. Let the revolution begin.
Penggunaan sinar radiasi ultraviolet C atau UVC merupakan salah satu metode dalam sterilisasi. sinar radiasi UVC dipercaya dapat melengkungkan struktur materi genetik virus dan mencegahnya berkembang. Pusat Penelitian Elektronika dan Telekomunikasi LIPI telah mengembangkan alat sterilisasi ruangan portable berbasis sinar UVC. Si Susan atau Simple Smart UVC Sanitizer memanfaatkan sinar UVC yang dikendalikan secara cerdas. Si Susan memancarkan sinar UVC yang menyinari langsung permukaan benda di ruangan atau kabin.
Seperti kita ketahui, sinar UVC adalah mempunyai kemampuan untuk melemahkan mikroorganisme, termasuk diantaranya adalah bakteri, virus, pada suatu permukaan benda dan di suatu ruangan. Si Susan dapat digunakan untuk menghambat penyebaran COVID-19.
Parameter penyinaran dapat diatur melalui aplikasi Android, seperti lama penyinaran sesuai dengan luasan ruangan dan jenis virus atau bakteri yang akan dibasmi. Penjadwalan penyinaran dilengkapi sensor keamanan dari aktivitas manusia. Si Susan didesain dengan sangat sederhana, portable, dan murah sehingga dapat digunakan di rumah tangga, klinik atau puskesmas, sekolah, kantor, dan lain-lain.
Next-generation technologies like radar and satellite communication with high data rates call for innovative testing solutions to develop and manufacture RF components. A critical part in the development and design of large communication systems, as well as single RF components for microwave devices like oscillators and amplifiers, is phase noise measurement. This is used to show developers if a signal source noise is as low as it should be. With the launch of the R&S FSPN, Roda & Schwarz is adding a new member to their phase noise analyzer portfolio, enabling increased efficiency and reproducibility of phase noise measurements and VCO characterization from lab to production. The R&S FSPN only takes a few seconds to perform VCO characterization. This not only speeds up the lab processing time, but also multiplies the measurement throughput in VCO manufacturing lines. As the leader in this area, Roda & Schwarz was able to develop the best phase noise and VCO tester on the market, whose pre-configured setup allows easy testing and instantaneous results for the lab, as well as for production applications. The R&S FSPN, unrivaled sensitivity meets high speed. Find more information and learn about phase noise and VCO testing on our website.
Jurnal Elektronika dan Telekomunikasi or JET is a journal published by Pusat Penelitian Elektronika dan Telekomunikasi LIPI. JET presents high-quality articles on the latest research and development in the field of electronics, telecommunication, and micro or nanoelectronics engineering. JET provides a platform to share research in the areas such as digital signal and image processing, network theory and circuit design, radar and sonar technology, antenna and wave propagation, wireless and optical communication, microelectronic system, electromagnetic and electronics materials, emerging and advanced fabrication technology, and so on. JET is indexed by internationally renowned indexers such as DOAJ, Google Scholar, Mandiri, and etc. JET is also ranked at Center 2 in Kemenristek Green accreditation system. There are 2 JET editions published every year, and all of them are available in open access to support global exchange of knowledge. All submissions in JET are accepted online, and each submission will be blindly reviewed by at least 2 peer reviewers. Most importantly, all submissions are free of charge, and therefore, no article processing fee applies. For more info, please visit www.journalet.com or visit our social media accounts.
Next-generation technologies like radar and satellite communication with high data rates call for innovative testing solutions to develop and manufacture RF components, a critical part in the development and this is used to show developers if a signal source noise is as low as it should be. With the launch of the R&S FSPN, Roda and Schwartz is adding a new member to their phase noise analyzer portfolio, enabling increased efficiency and reproducibility of phase noise measurements and VCO characterization from lab to production. The R&S FSPN only takes a few seconds to perform VCO characterization. This not only speeds up the lab processing time, but also multiplies the measurement throughput in VCO manufacturing lines. As the leader in this area, Roda and Schwartz was able to develop the best phase noise and VCO tester on the market, whose pre-configured setup allows easy testing and instantaneous results for the lab, as well as for production applications. The R&S FSPN, unrivaled sensitivity meets high speed. Find more information and learn about phase noise and VCO testing on our website.
Saat ini, kebutuhan magnet permanen di Indonesia relatif tinggi. Magnet permanen adalah magnet yang memiliki sifat kemagnetan yang lama dan tetap sehingga sukar untuk dihilangkan. Magnet permanen banyak dimanfaatkan pengaplikasiannya oleh industri dan UKM pada berbagai komponen elektronika. Namun, tahukah kamu, sebagian besar kebutuhan magnet permanen di Indonesia masih diimpor dari negara lain, seperti Cina, Jepang, dan Amerika. Salah satu magnet permanen yang cukup banyak digunakan adalah magnet barium ferit. Magnet barium ferit, atau yang sering dikenal juga dengan sebutan magnet keramik, adalah magnet permanen dengan rumus BaFe12O19 yang terbuat dari bahan baku utama oksida besi dengan teknologi serbuk. Untuk meningkatkan kekuatan magnet barium ferit, Pusat Penelitian Elektronika dan Telekomunikasi Lembaga Ilmu Pengetahuan Indonesia di Bandung telah menemukan sebuah invensi berupa magnet bonded hybrid. Apa itu magnet bonded hybrid? Magnet bonded hybrid merupakan penggabungan dari magnet barium ferit dan magnet neodymium iron boron (NdFeB) dengan menggunakan teknologi hot press bernomor paten P00201407033. Keunggulan dari invensi ini adalah harga lebih murah bila dibandingkan dengan produk impor. Jumlah, bentuk, dan spesifikasi dapat dibuat sesuai kebutuhan pengguna. Keunggulan lain dari invensi ini adalah menggunakan produk lokal limbah oksida besi. Temperatur Curie dan ketahanan korosinya lebih tinggi dibanding magnet NdFeB, serta kekuatan magnetnya lebih tinggi bila dibandingkan dengan magnet barium ferit. Saat ini, pembuatan invensi magnet bonded hybrid masih dilakukan dalam skala laboratorium di Pusat Penelitian Elektronika dan Telekomunikasi. Pengembangan selanjutnya, invensi ini dapat diproduksi secara massal dan digunakan untuk memenuhi kebutuhan industri elektronika nasional, seperti meteran air, printer, pengeras suara, keyboard komputer, alat bantu dengar, generator, dan motor listrik. Kami menantang Anda untuk menjadi teknopreneur melalui teknologi ini. Apakah Anda berani? Ayo membangun bisnis berbasis teknologi.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. consists of 7 deputies, supported by various research institutes, and have more than 70 research centers and supporting units. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
The global consumer electronics industry is changing rapidly. Simply making the best products is no longer good enough. Increasingly, consumers are looking for added functionality, personalization, and social and environmental sustainability. Adding to the challenge, advancements in the underlying technology come so rapidly that new products hit the market more frequently than ever, some as quickly as every 2 to 3 months. Industry transformations such as 5G further underpin the need for rapid innovation. Manufacturers need to find a way to innovate on reduced timelines without sacrificing aesthetic desirability, quality, or budget. With Dassault Systèmes simulation solutions, you have the capability to improve time to market for consumer electronic products through virtual prototyping. It allows you the agility to quickly simulate changes to the design and evaluate multiple solutions, all before a single part is built. The 3D Experience platform offers access to an unmatched portfolio of electromagnetic simulation and design tools, and provides seamless collaboration between simulation analysts and designers. As a result, you can extensively simulate all aspects of antenna design and communicate potential issues to your colleagues, allowing you to make quick changes and avoid unnecessary design iterations. Rapid antenna prototyping is enabled through robust and automatic meshing of complex geometry, combined with state-of-the-art simulation technology. This means you can simulate antennas on a full smart device in less than 15 minutes, instead of waiting days to build and measure physical prototypes. The 3D Experience platform facilitates efficient and smooth end-to-end workflows, from conceptualization to design, engineering, manufacturing, and finally, delivery to market. With Dassault Systèmes solutions, you can streamline your design, simulation, and production process today to produce the electronic devices of tomorrow.
Next-generation technologies like radar and satellite communication with high data rates call for innovative testing solutions to develop and manufacture RF components. A critical part in the development and design of large communication systems, as well as single RF components for microwave devices like oscillators and amplifiers, is phase noise measurement. This is used to show developers if a signal source noise is as low as it should be. With the launch of the R&S FSPN, Roda & Schwarz is adding a new member to their phase noise analyzer portfolio, enabling increased efficiency and reproducibility of phase noise measurements and VCO characterization from lab to production. The R&S FSPN only takes a few seconds to perform VCO characterization. This not only speeds up the lab processing time, but also multiplies the measurement throughput in VCO manufacturing lines. As the leader in this area, Roda & Schwarz was able to develop the best phase noise and VCO tester on the market, whose pre-configured setup allows easy testing and instantaneous results for the lab, as well as for production applications. The R&S FSPN, unrivaled sensitivity meets high speed. Find more information and learn about phase noise and VCO testing on our website.
Jurnal Elektronika dan Telekomunikasi or JET is a journal published by Pusat Penelitian Elektronika dan Telekomunikasi LIPI. JET presents high-quality articles on the latest research and development in the field of electronics, telecommunication, and micro or nanoelectronics engineering. JET provides a platform to share research in the areas such as digital signal and image processing, network theory and circuit design, radar and sonar technology, antenna and wave propagation, wireless and optical communication, microelectronic system, electromagnetic and electronics materials, emerging and advanced fabrication technology, and so on. JET is indexed by internationally renowned indexers such as DOAJ, Google Scholar, Mandiri, and etc. JET is also ranked as Center 2 in Kemenristek Green Accreditation System. There are 2 JET editions published every year, and all of them are available in open access to support global exchange of knowledge. All submissions in JET are accepted online, and each submission will be blindly reviewed by at least 2 peer reviewers. Most importantly, all submissions are free of charge and therefore no article processing fee applies. For more info, please visit www.journalet.com or visit our social media accounts.
The latest release for Dassault Systèmes 3D Experience platform delivers an elegant, powerful business experience environment. With role-based functionality, easily access apps and services users need with one click. The new 3D Experience Marketplace offers an ecosystem of qualified industrial service providers for operations like 3D printing, and self-defined 3D dashboards streamline collaboration for both users and management across industries to create innovative consumer experiences. Companies understand the need for realistic simulation to reduce costs and increase performance. In fact, simulation can go even further. We believe simulation is a comprehensive tool to reveal the world we live in. This can be clearly seen through the latest Simulia R2020X portfolio, which delivers enhancements that maximize the value of simulation for end-to-end industry processes. Requirements management, conceptual design, validation, manufacturing, and consumer end use all can be tracked and enhanced on the 3D Experience platform. A complete set of multi-scale and multi-physics capabilities power these industry processes, including connections to state-of-the-art established technology for structures, fluids and acoustics, electromagnetics, and multi-body simulation. Simulia R2020X also supports our mainstream product designer community, including tight integration with both CATIA and SOLIDWORKS. New structural designer and structural engineer roles provide a complete linear structural analysis solution to assess the performance of products throughout product development. And the structural professional engineer role provides advanced simulation technology fully integrated with design, especially with SOLIDWORKS. Customers can secure their existing investments in simulation methods, data, and results by connecting directly to the 3D Experience platform with Power BI to do even more. Increase the visibility and value of project data, collaborate with stakeholders, distribute best practices, and integrate simulation more fully into design and business decision-making. Finally, for maximum simulation efficiency, you need scalable access to both computing hardware and software licensing. Simulia on-cloud roles accommodate a wide range of computing requirements and provide access to the 3D Experience platform without requiring a local platform installation. Simulation is fully integrated with design, engineering, test, and manufacturing on the 3D Experience platform, bringing the virtual and real worlds together to power innovation and business and reveal the world we live in. Available on-premise and in public or private cloud, Dassault Systèmes 3D Experience Platform is a business experience platform that enables our clients to create delightful experiences from design to point of sale for their ultimate customers or consumers. For more information, please explore our website or contact sales for a personal demo.
Okay, good afternoon all. I think it is 1 p.m. and we are going to join the session 15 in the breakout room 3. Okay, first of all, the co-host, is there any share screen? Okay. Greetings, ladies and gentlemen. Welcome to the session 15 of 2021 Icramet. My name is William Damario Lukito from Institut Teknologi Bandung, Indonesia, and I will be the moderator of this session. In this session, there will be 4 presenters. The first one is Mr. Rohit Lahiri from, pardon me.
So from Bharat Electronics, India.
Okay, thank you, Mr. Rohit.
Yeah. Yes, sir.
And then the second presenter will be Ankita Mehrotra from Bharat Electronics Limited, India. And then, pardon me, the next presenter will be Ankita Mehrotra from Dhirubhai Ambani Institute of Information and Communication Technology. And then Rizka Khairunisa from Politeknik Siber dan Sandi Negara Indonesia. And Doga Canturt from Ozi Yegin University, Turkey. For me, the first presenter, whenever you're ready. I'm sorry.
So the video will be played by your side, right?
Yes, but before that, I would like to tell you, reminding some notes for all the participants. For all presenters in this session, please keep your video on until the session finished. We will have screen capturing session by the end of presentation. Also, please fill out the attendance from during the session. Our co-host will send you the link in the chat room. Please have your presentation file ready in order to answer some questions from your slide. The time for each presenter is 20 minutes long. Please make sure you are present during your questions and answer sessions. For the participants who would like to ask a question, please use the raise hand function at participant menu on your Zoom. For the first presenter, Mr. Rohit, are you ready?
Yes, I am ready, sir.
Okay, so the co-host will share the video.
Hi, good afternoon, respected chair and respected colleagues and friends. So I am Rohit here. The topic I'll be discussing on is novel engineering and design of compact SSS based highly selective interdigital KU bandpass filter. So basically we are 3 authors, myself Rohit Lahiri, Gaurav Anand and Asmita Singhal. And at present, I am Deputy Manager at Super Components Product Development and Innovation Center, Bharat Electronics, Bangalore, India. So basically, my agenda will be, I'll have just a brief discussion about what Bharat Electronics is and what Super Components Product Development Innovation Center is and what we are doing. Then I'll give an introduction of whatever I'm proposing, my paper. And then we'll go through the design flow of the low loss compact highly selective bandpass filter, why we have chosen SSS configuration and why interdigital topology, then 2D and 2.5D EM simulation model, then 3D EM model and simulation, then model development we'll be briefly discussing, and the measured results and the analysis of the results and a conclusion of that. So basically Bharat Electronics It was established in 1954 and it is coming under Ministry of Defense, India. And its key focus is on R&D for key defense R&D research. And it is one of the Navratna company and it has got this status in June 2007. It has developed many capability, means like it has developed a capability for a wide range of products in both civil and defense market. And besides empowering and strengthening India, in its product line, it also exports its products. And it has 6 overseas offices, majorly in New York, Singapore, Vietnam, Myanmar, Sri Lanka, and Oman. And it has 9 manufacturing units across whole India and 4 regional offices in major cities of India. At present, it has a strength of 9,000, more than 9,000 employees and 4,800 odd engineers and scientists as on 31st March 2021. It is having 3-tier R&D, which is consisting of CRL, which works on the futuristic technology, PDAC, which I am a part of it, Product Development and Innovation Center. It caters to the current needs of the innovation and even the future needs too. And there are different D&D groups which are making development. They are part of development and engineering and mainly work on the system level. And PDAC works on subsystem level and CRL works on the futuristic technology. The annual R&D expenditure is about 6.32% of the turnover of year 2021. So typically it invests around 6 to 8% of its turnover. Coming to Product Development and Innovation Center and Super Component, the capabilities are we develop transmit and receive modules in various bands. We develop frequency sources up to KU band. And even now it has been extended further also. Exciters, receivers and frequency converters, power amplifier modules up to KU band using both GaN and gas FETs, wideband receivers, front end and down converters, power combiners, power samplers and detectors, filters, all the passives and now active filters are also been tried to develop. Both microstrip, strip line, suspended substrate strip line, comb line, cavity filters. Limiters, variable attenuators, phase shifters, DLVs, directional couplers are what our strengths are. We are developing. Multi-layer digital and hybrid PCB designs, FPGA controlled based monitoring and control cards. So coming to our topic, compact triple S based highly selective interdigital KU band bandpass filter. So basically we know that bandpass filter is a very key component in RF and micro component modules like up converter, down converter, front end receivers and etc. Especially for wideband electronic warfare and avionics application, the receivers need multiple filter banks to split the entire wideband into a narrow subbands. The desired characteristics of this filter is that it should have minimum passband loss and it should be having wideband rejection, which like the stop band should be wider and high rejection, and it should be well matched in its passband. Solution should be economical and compact. So there are many filter topologies and planar transmission line configurations to realize this filter. But among the options, means like filter topologies can be like it can be microstrip, it can be interdigital, it can be comb line, edge coupled, and planar transmission line configuration can be microstrip, strip line, CPW, etc. But among this, it has been chosen as an interdigital topology and suspended stripline topology. So I'll be coming into it why we have chosen this configuration. The key design and engineering aspect of low loss, highly selective 4 GHz bandwidth KU band bandpass filter has been discussed in this paper. So basically, you can see the stripline, suspended stripline structure. Here, the dielectric epsilon r is having h, which is the height, and above it and below it, HU and HL is the air gap, which makes it suspended. So this has an advantage, like it can be used for low loss configuration. It has less effective dielectric constant because air is being introduced beside the substrate dielectric. It has a very good transition when we use a coax like a glass bead or something, and it is suitable for design for millimeter wave frequencies. It is as air is introduced, we can in fact realize much higher impedances, typically up to 150 ohms also. So track widths can be at least etched on the substrate. Then dimensions or tolerances of the structure can be relaxed, as we can realize more higher impedance, so narrow track widths won't be needed, which won't be realizable. Then it is suitable for design for very high Q factors. So we can easily fabricate filters which will give very sharp rejections and all. Selectivity will be very high and suited for mass production. Why interdigital topology? It has many advantages over the conventional topologies like end coupled, edge coupled, comb line, hairpin, etc. The main advantages are like it is compact to size. It can be realized on a compact size. It is used for wide bandwidths. It has low loss. Then second pass band is generally centered at three times the meter frequency. If we go with hairpin or comb line, basically it is the second harmonic which comes up. But this is giving more advantage as it gives us third harmonic. And grounding and the placement of the ground bias is really critical because this grounding plays a major role. So coming to our design. So basically what we have chosen is, we have chosen a substrate which is having an epsilon R of 2.2. So we can realize much higher impedances and the dielectric losses would be minimum. And for this 2.2, we for this configuration with height of 0.5 mm above and below the air gap, we are arriving to 50 ohms resistance as 1.5 mm track width. So for this 1.5 mm track width, what we see that to achieve greater than 60 dB rejection at 15% away for 4 GHz bandwidth, which is centered at 16 GHz, we see that we need around n greater than 12 sections. So we have chosen n equal to 13 because it gives an advantage of having symmetry. So for based on the n equal to 13, what we see is we are supposed to arrive this length, the width of this each resonators, and the spacing between each resonators, though all of them will be at lambda by 4 distance. So all these equations are used to arrive to the even and odd mode impedances, and based on the even and odd mode impedance calculation, we arrive with the length, width, and spacing. So basically we have used these equations as well as we have used software to arrive to the values of the resonators, the spacing, length, and width. So based on this, what we have done is we have gone ahead and we have modeled the 2D model in ADS. So 2D model has been done, and you can see that this entire length, all the opposite ends have been shorted. This 2D model, you can observe this in the 3D, which 2.5D model in the same ADS momentum, and you can see the substrate definition what has been provided. So it is a 5 mil substrate with a 2.2 dielectric constant, and air gap which has been provided is of 0.5 mm. The same thing has been designed in 3D, and the software uses CST. So in the 3D modeling, you can see that the desired air cavity, you can see this height. This height is determining the air gap. Similar pattern is on the back side, and this ensures that HUHL is being maintained, and this entire area is grounded, the top plane. And this is my feed port where I am feeding the RF energy, and it has been taken out from these ends. And you can observe that vias have been strategically placed at the ends of the short-ended resonators. Basically, the via placement plays a key role in getting the proper band pass filter structure. So this is the 3D EM simulated result. You can observe that the return losses are fairly very good. It is more than 15 dB. And insertion losses is also very good in the pass band, and we have some buffer bandwidth also. So as we can go through, that pass band is having minimum insertion loss in 14 to 18 gigahertz. You can observe the markers here, and then extra bandwidth of 2 to 3% of center frequency is being provided. So this is generally we follow in every design, because this helps us during the manufacturing to cater to any kind of compensation by shifting, or if by chance there is a shrinkage in the bandwidth. Also, return losses are more than 15 dB. And out of band rejection, if you see, which is at 15% away, it is more than 60 dB. In fact, we achieve at 10% away from this band edges also, more than 60 dB rejection, this and this. But at present, we have considered markers at 15%, which is the requirement for our project. So here you can see, this is the design PCB. This is on Rogers 5880 substrate. And this is the mechanical block which has been used, or a jig for testing. And you can observe there are two plates, which like bottom and top, and the substrate is inserted here. So where to maintain the suspended portion, you can see there's a cavity made. So this cavity and the pattern is etched in that area only. So this ensures that the top and bottom cavity is maintained, and triple S kind of structure is being analyzed. And you can see a bead transition, which is a coaxial transition. So basically, coaxial transition to triple S transition has been shown. The same thing fabricated has been shown here, the substrate. Here the glass bead is soldered here, which is the coaxial transition with the external wall. And this is the flange, the field reciprocal flange. So for testing, we insert this flange, which comes in the contact with the pin of this bead, and in turn comes in contact with the filter here. So this you can see and appreciate the miniaturization what we have achieved with this filter, and these screws play a key critical role in maintaining the pressure over the PCB and ensuring that the proper result has been achieved. So you can see that the module has been compared with a measuring scale, and the dimension is pretty much like 2 centimeter or 20 mm. And here it has been it's like compared with a coin, 5 rupee coin, Indian rupees coin. And application is, it can be used as a standalone jig, or it can be used as a drop-in. So it is like a hybrid MIC based, like a hybrid monolithic integrated circuit. So here if you see as a standalone, it is like a transition from coaxial to triple S to coaxial. And when we use it as a hybrid, we can use a microstrip or CPW kind of line to coax, then to a triple S, then again a coax to a microstrip or a CPW. So this is the result of the practically fabricated filter. We can appreciate that we can see the losses. In-band losses is much lesser than 3.5 dB, means like I am considering from 14 to 18. And the rejection, what we achieve at 15% away is much greater than 60 dB. So markers here are put at 15% away from this band edges. So in fact, you can see that it is much greater than 60 dB. So desired characteristics of minimum insertion loss from 40 to 20 GHz have been achieved, and achieving greater than 60 dB out of band rejection at 15% away from the band edges has been achieved. Additionally, a buffer bandwidth was provided, which I have told has, which like it was made for fabrication tolerances on both sides. So this comparison will give us the fair idea why what I was telling. So basically you can see the comparison. Here you can see that the centering of both measured and simulated result has occurred very satisfactorily. But you can see that insertion loss has increased, and moreover the passband of the measured result has shrunk a bit. So the degradation in insertion loss can be basically attributed to the manufactured PCB tolerance and the its definitions, the critical mechanical block scooping and tolerances, accounting connector losses, transition losses from coax to triple S to coax. And comparison between the measured and simulated result of return losses and group delay show a fair comparison and very satisfactory comparison. You can see that based on the comparison, we observe that excellent matching. So practically, if we see, at least we are achieving more than 12 dB of return loss, and group delay is very closely matching. In fact, the passband is having very minimum group delay. So this is very good for many applications. So coming to the conclusion. So conclusion, we see that novel engineering design and development aspect of compact suspended substrate stripline based interdigital bandpass filter of KU band 14 to 18 has been discussed. Key challenges discussed related to the design and manufacturing to meet high selectivity, appreciable passband, matching and minimum passband insertion losses. These are the key desired characteristics of any micro-integrated circuit-based application for wideband front-end receivers. Key choice of SSS-based transmission line and integrated topology has been discussed. The realized filter offers rejection greater than 60 dB and 80 dB at 10% and 15% of impact of band edges. The passband insertion losses practically achieved is less than 3.3 dB in fact, with return losses greater than 12 dB in the passband. The designed circuit is very compact. It is on a 5 mm soft substrate and realized in compact size of 2 into 1.5 centimeter square. Filter can be dropped or it can be used as a standalone. Then measured result shows satisfactory correlation with simulated result. Future scope of the work would be to optimize the bandpass losses and further extend the work to frequencies which are above Ku band. And we would like to acknowledge the product design group of Product Development and Innovation Center for their support in design and fabrication of mechanical enclosures. We would also like to thank in-house PCB department of Bharat Electronics, who are very capable for manufacturing of soft substrate PCBs with very critical tolerances and critical etching parameters. Also, we would like to thank all those who are involved directly or indirectly in this work. These are the basic references what we have followed. Thank you.
Okay, thank you very much, Mr. Rohit, for the great presentation. And now we will begin with the Q&A session. Is there any question from the participants? Okay, since
I want to ask. Okay.
Yes, sir.
Hello.
Okay, please, Mr. Yuyu.
What's the kind of the software for your simulation?
Yes,
and in the simulation, do you have the optimize? They have the optimizing. What's the difficult for the optimize? Okay, thank you.
Sir, actually what we do is first initially we arrive to the initial parameters of the length, width and spacing. After that what we do is we try to bring... Hello, you can hear me, sir?
Okay, yes. Sorry.
Yeah, sir, what we do is first based on the equations what we have shown and based on some softwares we arrive to the length, width and spacing of the parameters. Then I had showed you that ADS 2D and 3D plots, right? Then we try to tune it to bring it to the exact center, and we additionally give some buffer bandwidth, sir. What we have seen is when we try to simulate and fabricate, we tend to see that the entire response generally shifts towards the lower frequency side. So what we do is we give more additional bandwidth so that it caters to the shift as well as the shrinkage. So this is what we do, sir. So we generally give 2 to 3% of the extra buffer bandwidth in our simulations.
Okay, thank you.
Yeah, thank you, sir.
Okay, thank you, Mr. Yuyu, for the question and Mr. Rohit for the answer. And since we have already running out of time, maybe we can just move into the next presenter. But the presenter 2 and 3 is not available yet, so we can proceed to the last presenter. Before presenter, Mr. Doga Jantur, are you ready?
Yeah, I am ready. Hello.
Okay, whenever you're ready.
Dear Icramet Committee and others, this is Doğan Cantur, Master Degree Program student at Özyeğin University. And also, I am working as Senior RF and Microwave Design Engineer at Meteksan Defense, located in Turkey. It's my pleasure to attend Icramet 2021 and present our paper entitled Broadband High Power Amplifier Design using GaN HEMT technology on the behalf of Özyeğin University. This study belongs to me and my advisor, Dr. Ahmet Akgüray. Our presentation consists of motivation, introduction, methodology, fabrication and measurement, discussion and future work, and conclusion sections. Power amplifiers are one of the most important devices for radar, guidance, radio communication, and electronic warfare systems. It is the most dominant component determining overall power consumption and therefore the heat dissipation of these systems. Further, power amplifier output power and linearity are critical in establishing reliable communications in modern radios. In order to reduce power consumption and self-heating and improve reliability of modern RF transmitters, power amplifiers operating over wide bandwidths with high efficiency are needed. The motivation of this work is to design a broadband high power amplifier intended for point-to-point radios, electronic warfare systems, and test and measurement applications. In this work, a high power, high efficiency broadband power amplifier using GaN HEMT technology and operating from 0.5 to 2.5 GHz presented. The primary goal is to achieve higher than 50% PAE and 10 watt output power from over the band. In this study, Wall speed CGH4010F GaN HEMT device is selected to be able to meet sufficient power and PAE. Class AB design is decided. The proposed power amplifier is fabricated and small and large signal measurements are collected. Fabricated design is conducted for an input power of 26 dBm and obtained between 39.6 to 40.9 dBm output power. PAE of 45.9 to 61.4% is reached over the band. Good agreement is obtained between simulation and measurement results. Simulations are carried out in Cadence AWR design environment. As I mentioned before, the primary goal for this study is achieve higher than 50% PAE and 10 watt output power from 0.5 to 2.5 GHz. As such, it is necessary to use a transistor that can operate over this frequency range with acceptable gain and PAE. After careful consideration, low speed CGH4010F GaN HEMT device is selected. Once transistor is selected, a suitable DC bias point must be determined to meet the specifications on gain, PAE, output and harmonic suppression. Output power and harmonic suppression. For CGH4010F, the bias point selected as VDS, 28 volt, VGS, minus 2.1 volt, IDQ, 336 mA for Class AB operation. A DC bias network consisting of real RF chokes and DC blocks is then designed to operate the transistor at the selected bias point while minimizing noise from power lines. Next step is to perform load and source pull analysis by using the large signal model of the CGH4010F. Load pull and source pull is a design technique wherein source and load impedances present to the transistor are varied to find their optimum value to achieve desired performance from device. Load and source pull analysis are executed in an iterative fashion. First, the analyses are performed to obtain gamma L and gamma S respectively, using power versus efficiency contours on the Smith chart. Then the process is repeated using thus obtained deflection coefficients until desired output power and PAE are simultaneously achieved in simulations. Figure 1 represents the loadable contours for 2500 MHz. As seen in the figure 1, the output power of 41 dBm and PAE of 65% contours are highest grade contours. Thus, it is aimed to use impedance points located at the intersection of these contours for output matching network design. After that, gamma L and gamma S from the load and source pool analysis need to be realized with suitably designed input and output matching networks. Taking advantage of network synthesis tool in Cadence AWR design environment, microstrip-based matching networks are designed with DC blocking capacitors on the gate and drain lines. AWR design environments network synthesis tool allows a designer to select things such as network topology, the electric substrate properties, and design goals. After obtaining input and output matching networks, the schematic of the proposed power amplifiers composed is given in figure 2. Also, stability analysis conducted. Proposed power amplifier is unconditionally stable from DC to 2.5 GHz. A stabilization resistor is employed, which ensures stable operation, especially at low frequencies. In this design, 75 ohm resistor is used for stability. Output power, PAE, and harmonic simulation versus measurement results are given in fabrication and measurement results section. The design is fabricated on 20 miles thick Rogers 4350 substrate with 3.66 ER and is shown in figure 3. The dimension of realized design is 120 and 40 millimeters. The small signal analysis is conducted for the proposed system. Simulated and measured small signal S11 and S21 are provided in figure 4. Simulated S11 varies between -4.5 to -6.5 dB, while measurements show better than -4.8 dB reflection coefficient throughout the band. On the other hand, the small signal gain S21 exhibits more divergence between simulation and measurement. While the measured gain is higher at the lower end of the band, 0.5 to 1.2 GHz, it is lower than simulations in the upper half by as much as 2 dB. Also, the large signal analysis is conducted for the proposed system from 0.5 to 2.5 GHz. In this section, output power, gain, PAE are analyzed for fabricated and simulated systems under CW input signals. Measurements are conducted for an input power level of 26 dBm with swept frequencies. Figure 5 presents the measured output power and gain versus simulation. A large signal gain comparison between simulated and fabricated designs are also given in figure 5. Large signal of the fabricated systems varies between 13.6 to 14.9 dB, while it is between 14.2 to 15.5 dB in simulations. The measured output power is between 39.6 to 40.9 dB. On the other hand, the simulated output power is between 40.2 and 41.5 dBm. Figure 6 illustrates measured PAE versus simulation over the band. Measured PAE is between 45.9 to 61.4% over the band, and simulated PAE is between 54.1 to 63.3% for operating band. For output power, PAE, and gain, measured results are better than simulations at most points between 0.5 to 1.3 GHz. However, beyond this point, there is a drop in measured results compared to simulated results. Levels of the simulated high harmonic products are provided to reveal large signal analysis in depth. Figure 7 shows the levels of the fundamental tone, second and third harmonic products. The highest second harmonic level is 18.1 dBc at 0.8 GHz, and the highest third harmonic level is 10.9 dBc at 1.9 GHz. Figure 7 also depicts the simulated output third order intercept level for the proposed system. The minimum level of the output third order intercept is 50 dBm at 1.9 GHz. For the proposed design, minimum 39.6 dBm output power, minimum 45.9% PAE, and minimum 13.6 dB large signal gain is achieved. Simulation is performed by taking into account the large signal model of the transistor with the designed microstrip lines. Because as parameters of the RF connectors used at the input and output of the RF lines are not available, this part couldn't be simulated. In addition, fabrication defects on the implemented design lead to some degradation in output power and PAE, especially at the high end of the band. These factors are thought to be the cause of difference between simulation and implementation results. Table 1 presents a comparison of some recent state-of-the-art designs and proposed work in terms of bandwidth, power, gain, and PAE. This work achieves the widest with good gain and PAE when compared to literature. For future work, for proposed design, we decided to get new layout by using lambda/4 transmission lines for RF choke instead of bobbins to eliminate parasitic effects. The proposed broadband 10-watt power amplifier can be used as standalone, and also it can be used to derive to another power amplifier to reach higher output power level. For future work, this study is used as a driver power amplifier for a new design with simulated 48 dBm output power and 50% efficiency for same operating frequency. Simulation and fabrication stages of the new Class AB high power amplifier design are completed. Because the lab tests of the new design are not completed, we couldn't add the measurement results to presentation. Figure 8 illustrates the fabricated PCB design of new Class AB high power amplifier. In this work, a broadband high power amplifier design that uses GaN HEMT technology at 0.5 to 2.5 GHz operating frequency is present. For the proposed design, wall speed CGH4010F transistor is used in CW mode. The proposed power amplifier is fabricated and small and large signal measurements are conducted. Fabricated design is conducted for an input power of 26 dBm and obtained between 39.6 to 40.9 dBm output power. PAE of 45.9 to 61.4% is reached over the band. Large fractional bandwidth, good output power, and PAE are the main advantages of this design compared to other works in literature. Good agreement between simulation and measurement results is obtained. Thank you for your kind attention. I will be glad to answer your questions.
Okay, thank you, Mr. George, for the great presentation. And now we will begin to the question and answer session. First, is there any question from the participant? You can just raise your hand. Okay, Mr. Yuyu, please.
Okay, thank you. I want to ask for how to the requirement or consideration for the temperature with your power amplifier. I think how the use of the heat exchanger, heatsink.
Heatsink.
Yeah, they need the heatsink for your amplifier.
Yes, we used heatsink below the amplifier to heat dissipation.
Yeah. How the temperature temperature.
Okay.
Temperature for your power amplifier.
Actually, as I remember, 18.5 degree, but I'm not sure because I couldn't record the temperature values for that design, because there is not any spec to heat dissipation. We focus on in that design PAE and gain and output power actually.
Okay, thank you.
Thank you.
Okay, thank you, Mr. Yuyu, for the question and Mr. Turt for the answer. So, is there any question? Okay, maybe because we still have time, personally, I want to ask Mr. Turt, could you kindly elaborate the application of your proposed design and how to implement it?
Okay, as you know, for electronic warfare systems, high power amplifier is important. I think that these type of amplifiers for implemented CW design have large scale for actually jammer applications, lightband jammer, and also you can use this design for radar systems. In my previous work, I have designed a jammer, and we need this type of wideband power amplifiers. This is the usage area, I think, that electronic warfare generally.
Okay, thank you, Mr. Tut, for the answer.
Thank you.
Maybe we can move into our next presenter, that is the previous skip presenter, the presenter number 2. For Miss Ankita, are you ready?
Yes, sir. Could you please give me 2 minutes? I'm ready. I'll be ready in 2 minutes.
Okay. For Miss Ankita, whenever you're ready, please share screen video.
Good afternoon, one and all. I, Ankita Mehrotra, is here before you to present my research work, that is design and analysis of a broadband low noise amplifier using 0.25 micrometer gallium arsenide PHEMT process. Along with me, the other author is Professor Sanjeev Gupta, who is also my supervisor. The contents of today's presentation are as follows. I'll be going through each of the content as we proceed in the presentation. Coming to the introduction. Why LNA? LNA is a crucial block of any receiver. Basically, whenever a signal is received, we need to amplify the signal so that the signal is detected at the receiver end, and we also need to reduce the noise. So this is the main use of an LNA. It amplifies the incoming signal from the antenna by giving a less effect of noise. Why HEMT? The other LNAs which are designed for a lower frequency normally use CMOS. But there are many disadvantages of CMOS, because of which I have considered to use HEMT. HEMT basically stands for heterojunction electron mobility transistor. It has basically has got heterojunction, that is a junction using two different materials, which makes it better for getting high gain at a very high frequency range, and it introduces low noise as compared to CMOS. Also, it gives a balanced choice between the performance of the circuit and the fabrication. The hem that I am using is from the foundry UMS, that is United Monolithic Semiconductors. Now my design is basically ranges from 20 to 30 gigahertz. So why am I going for a millimeter wave design? Millimeter wave design is one of the key important factors in today's research areas. It has got many applications like HD video applications, satellite communication, radar applications. It has got a massive data rate and along with high security and low latency. So latency basically means that the delay between the input and output is low. When we consider the designing of any LNA, there are some design steps which need to be followed. So the first and the most important design step is the selection of the device. As I said, that there are many disadvantages of CMOS, because of which I have chosen p-HEMT over CMOS. Along with the selection of p-HEMT, we also need to select a proper quiescent point where our device works at the best possible configuration. So it is very necessary to choose a proper Q point. Over here, I have chosen the drain voltage to be 3 volts. And since I have used a self-bias mode, it only uses a single supply. Then comes the biasing network. So as I told you, there are different types of biasing networks. Dual DC supply, which uses 2 DC supplies, one at the gate, one at the drain. One is the single DC supply, which might use a single supply at the drain. Another is a self-biasing network. So I have used a self-biasing network in my design. In self-biasing network, we give a particular voltage only at the drain, and at the gate, we set the values of the inductors and current in such a manner such that the gate is automatically biased. Next is the stability considerations. Whenever we go for a LNA design, we always need to take this into consideration, that is the unconditional stability. There are many types of stability. One is unconditional stability, another is conditionally unstable. So in that, what happens is, if we do not go for an unconditional stability, there might happen that the gain or the return losses might get affected wherever the transistor is not stable. So the unconditional stability is a very important criteria, where we want that K should be greater than 1 for the operating frequency of 1 gigahertz to 60 gigahertz. The range 1 gigahertz to 60 gigahertz have been specified by the UMS foundry for the transistor that I am using. Then comes, after the stability consideration, we come to the matching networks. After the biasing network and the amplifier design is done, the matching is very important. Matching is basically important because we want maximum power, which needs to be transferred from the input to the output, or from the source to the input. So we consider over here the characteristic impedance to be 50 ohms, to which we have to design a matching network. Next, the criteria are noise figure, gain, and return losses. Also, now I give an introduction to what is actually a broadband LNA. Broadband LNA reproduces a wide range of signals without significant loss through the passband. It is a single amplifier which produces flat gain for a very wide range of frequency. This not only helps in the size reduction, but also it reduces the cost reduction, because in a single LNA, we get a coverage of a wider range of frequencies. So there are 2 types of LNA which we can design. One is, we can design a broadband LNA with multiple stages, or where will be having multiple stages, and each stage will be designed for a particular, for example, if I consider in my case, I have designed an LNA which is having 3 stages. So all the 3 stages are designed for 20 to 30 gigahertz to provide a broad range of frequency. In a similar manner, we have another design where we use multiple stages, but each stage is designed for a particular frequency. Example, if I consider 20 to 23 will be one stage, 23 to 26 will be other stage, 26 to 30 will be other stage. So with this also, the responses overlap each other, and then we can get a good response. And this also uses compensated matching networks. Okay, there are some important methods which can broaden the bandwidth. So this important method includes the use of parallel resistors and capacitors in the matching networks. So in the matching networks, if we use parallel resistors and capacitor structure, at lower frequencies, the resistor part is dominant and increases stability, but decreases the gain and introduces additional noise. At higher frequency, capacitive part is dominant, so the structure can broaden the bandwidth and increases stability. Also, there are various broadband design topology. It is already mentioned over here. Out of this topology, I have used feedback amplifier because it has got advantages over the other topology. Also, I am planning to design a feedback amplifier with current sharing approach, which will be told to you what it is exactly in the next slide. So RLC feedback technology, it is just a feedback topology where you use R, L, and C components as a feedback network which connects the output to the input using different voltage supplies at the drain. However, in current sharing approach, this approach is made in such a manner that a single supply is used for the complete network. It reduces the use of multiple supplies. So single supply is used for multiple stages or multiple transistors instead of many supplies, and they are formed in such a manner that with the supply from the one network, the other network is automatically getting the current, and then the voltage across it flows, and then the supply to the transistor is provided. Okay. I am doing my research work with collaboration to SACISRO. They have given me some specifications, which was to meet the specifications. I have made a chart out of it, and then I can specify whether I have met the specifications or not. So these are general specifications where I have to get the gain around 22 dB and the return losses around 12 or 15 dB. But the 10 dB gain is also considered, and I have designed accordingly. So I have used the transistor biasing over here. So this is the transistor biasing network. It uses self-biased topology. Also, it uses an RLC feedback topology along with that. In the source part, we have got the parallel resistor and the capacitor combination that I have told you. It is used for the broadening of the bandwidth. This is the design of multi-stage LNA. This is my single stage LNA. After the single stage LNA, I have done the matching network. I have matched the input and the output of the first stage. Output is matched to the input of the second stage. The second stage output is matched to the third stage. The third stage output is matched to the load side, and the first stage input is matched to the source side. These are some of the results that I have got here. As I have told you, the stability factor should be above 1 for the complete range of frequency from 1 to 60 Hz. So I have shown the complete range of frequency where the stability factor is much above 1. The noise figure 2, NF2 indicates that it is the output noise figure. Noise figure minimum gives you a glance of what is the minimum noise figure of the entire network. These are my S11 and S22 parameters, where my S11 parameter is slightly lesser than 10 at particular frequency. 98% it considers above 8, minus better than 8 dB. But my S22 is much above, better than 10 dB. So this is my gain. Here I am getting a flat gain between 20 to 30 gigahertz. It gives me approximate bandwidth of around 12 gigahertz, which starts below 20. This is the yield analysis. What is the yield analysis? Basically, in yield analysis, we get to know the performance of the device if the components are given in a particular range. For example, here I have considered the yield analysis. I have considered now 100 iterations. For the 100 iterations, I have set inductors to be varying from plus or minus 0.5 and the capacitors plus or minus 5% and capacitors varying from plus or minus 10% of the range. With that range, I have got an yield analysis, which is very much useful when we tape out the design, because we should know that out of the 100 productions that we will be doing, 96.8 LNAs which are produced will be giving us a proper result that is desired. I'll zoom this slide for better visuality. So I have made a comparison of various work. Basically over here, the frequency range changes from 9 to 25, 80. So this is basically the frequency range in which I am designing. Each of the previous works have either used source degeneration or a self-bias with bypass capacitor. However, my network or my topology which I have used is a bit different than others have used. Since my PHEMT is having 0.25 micrometer of the gate length as compared to other, the others are designed for a lower gate length, they will be advantageous over my gate length, because as the gate length reduces, we get a more advantage. Basically, in gate length, lower the gate length, better is the performance of the device, and higher the gate length, the performance degrades. But since my foundry, which I had availed from SAC ISRO, it was demanded to be 0.25 micrometer, hence I have used this gallium arsenide PHEMT. But even though I have used it, my results have been very competitive and it has been better than the previous works, especially in case of gain. The gain response is very flat. It varies only plus or minus 0.4, whereas for other designs, it varies either 1 dB or more than that. The third reference that I have taken basically uses 4-stage design, and mine is a 3-stage design. So I use lesser components as compared to the 4th one, which has got a better gain. My noise figure is slightly on a higher side, and the other parameters are within the range. Finally, I would like to conclude that I have got a maximally flat gain for 22 to 30 gigahertz. I have designed for 20 to 30 gigahertz, but the maximally flat gain is approximately ranges from 22 to 30 gigahertz. I am getting a bandwidth of around 12 gigahertz range. Moreover, the minimum noise figure is less than 2 dB. However, the output noise figure is less than 3 dB. My output and input return losses are much within the range. So these are my references. Thank you. And if there are any questions, please do let me know. And please do let me know if I can make some improvements as well.
Okay, thank you for Mrs. Ankita for the great presentation. And for Ms. Ankita, could you please turn on your camera?
Yes, sir.
Okay, now we will begin with the question and answer session.
Okay,
Is there
sir.
any question from the participant? Okay, maybe there is no question from the participant, and now I would like to ask you a question. Is there any phase difference at the output of LNA, and how do you think it will affect the performance of LNA?
So could you please repeat your question?
Is there any phase difference at the output of LNA, and how do you think it will affect the performance of LNA?
Fixed difference at the output.
Yes.
So basically, when we consider the output parameters of LNA, there are several output parameters that are gain, the noise figure, the return losses. Out of this, the main important parameter is the noise figure. So there might be a different and the gain, of course. So here, as I have shown you, my noise figure is a bit on a higher side. So for lowering the noise figure, we have to make changes with the topology, or we have to make changes with the matching networks. So we can deal with the output in this manner.
Okay, thank you, Mrs. Ankita, for the answer. And there is a question from Mr. Doknachantur. What steps followed to solve compromise between gain and noise figure in that LNA design?
Okay. The steps that I follow to solve the compromise between gain and noise figure basically is since I am designing for a broadband, I'm designing a broadband amplifier. So my primary focus was to get a maximally flat gain. However, even though my noise figure is more as compared to other designs, but it is not significantly higher. It is in a considerable range. So when we do when we consider the components and when we consider the optimization of the components, at that time we have to choose a particular parameter, prioritize a particular parameter over the other, where I have prioritized the gain to be maximally flat first rather than the noise figure. So the steps which I followed was, first I consider the a cue point selection, and then after the cue point selection, I place the components according to theoretical design. I have an DC feed inductor that was placed at the drain side. That is the main important component, so that only the DC gets fed to the transistor, and there is no AC component that is that is getting fed to the transistor. Also at the gate and the at the source side, I had done matching, because of which also we get an improved gain. And to reduce the noise figure, I have and to get a stabilized gain, I have done the this topology, that is feedback topology, so as to get a stabilized gain. To get a broader gain and a maximally flat gain, I have used the components capacitor and resistor in parallel at the source side. So these are the steps which I followed.
Okay, thank you, Mr. Truth, for the question, and Ms. Ankita for the answer.
Okay,
and
thank you so much.
That question conclude your presentation.
Okay, thank you.
And before we move into the next presenter, I would like to remind to every presenters To fill the attendance form, the link will be found at the chat box. Okay,
Sir,
maybe
I
we
do
can.
not, sorry to interrupt. I do not have the link for the form, attendance form.
Okay, maybe the co-host of this session will be send the link in the chat box.
Okay.
Okay,
Okay,
now
thank you.
we may begin with this next presenter. For Rizka Kairunisa, are you ready to present your research?
Yes, I'm ready.
Oh, I think the presenter is the representative, right?
Yes, right.
Okay. So please present your research.
Hello everyone, my name is Mia Hidasti. I read Duvin Nova, Fauzan Budi, Ega S.I. Christian, and Mrs. Rizka Khairunisa. We are from Polytechnic Siber and Sandinegara. Today we want to present to you our research about access control prototype using modified Kapota with timestamp protocol based on Arduino Mega 25 and 6. As for the outline that I will describe is introduction, proposed design, simulation, result, and conclusion. Introduction. In an organization, a security system is needed to ensure the supervision and protection of organization resources. The application of access control in a room can limit access to unauthorized parties. Text-based password is easier for user to remember, but the authentication using only one factor, there are still vulnerabilities. So, this is necessary to apply more than one factor. In the research of Shahid et al., an access control system has been implemented by applying RFID and password. However, there are still vulnerabilities in the form of replay attacks when using RFID. A replay attack is one type of attack that is dangerous because it aims to steal information or access. This attack will be more dangerous if access to stolen information is classified as limited confidential information. Therefore, it is crucial to implement a protocol that can overcome the replay attacks. In the research by Shafila et al., proposed a modified Trampota protocol tested to be safe from the replay attack. However, the tests carried out are still in a software-based environment. There has been no further research that implements it in a hardware-based environment. So, in this research, the modified Trampota protocol will be implemented in a hardware-based climate and combined with the password as a room access control system based on Arduino Mega and wireless module and RF34L01+. In 2018, Rajaguru et al. Proposed the RFID protocol authentication encryption protocol without tag anonymity or Trampota. to overcome several attacks on RFID, one of which is ripple attacks. However, the study of Shafila et al. Found a vulnerability in the scheme proposed by Rajaguru et al. Though Shafila made modifications by adding a nonce and timestamp, this protocol is called the Modified Rapporta Protocol. The result of Shafila et al.'s research, simulated using the Skydim tool simulator, showed modifications to the scheme proposed by Rajaguru et al., adding of timestamp, overcome the ripple text. The following is the scheme proposed by Rajaguru and the modified scheme proposed by Shafila. The difference between two protocols is timestamp, adding timestamp in the message. In this research, using proposed design is as follows. In general, devices made using the same components consist of the Arduino Mega 25 and 60, while module and RF24L01 Plus, and several supporting components such as RDC and servo. On the device side, there are three main entities, namely tag, reader, and server. The use of timestamp occurs in the communication process between tag and reader. Notification displayed from the reader will be displayed in the log data section of graphical user interface or desktop application. The tag device is used an intruder device with different function or using different programs. The system workflow begins as follows. First, the user must bring the tag on by the reader. Then, the user select Authenticate button on the desktop application to start the device authentication process. Then, from the desktop application, we'll send a trigger to the reader server device to run the modified Rapporta protocol to authenticate the device. After the process on the protocol is complete to the tag sends a notification that the device has been authenticated to the reader. When the reader forwards it to the desktop application and displays the notification in the notification box, the option Authenticate User will be active. Furthermore, user can access user authentication menu. Here, user can register, log in, change password, or delete account. If the login is successful, the open button will be active and the user can press it. From the open option, the desktop application will display a welcome notification and the trigger the reader move servo. If the user's device incorrectly entered the username and password or the tag ID value owned by the user tag does not match the value stored in the reader database, and access denied notification will appear and the open button will not be active. And simulation, transmission tests, distance testing is carried out to determine the extent to which devices can be connected to each other and to determine the effect of device distance on the distance authentication space. Authentication speed. We corrected the experiment by placing the hardware as shown in slide. We varied the distance between the text to the reader and server from 10 centimeters to 160 centimeters. Then we measured the time needed for the device to communicate. In addition, this experiment was carried out in the open space with line of sight communication. Each experiment, connectivity data, and device authentication speed are tested. In implementing these replay attacks, the intruder device utilizes the tag device with different function or program from the text. The intruder will perform a replay attack by forwarding message to the reader pretending to be a valid text. This replay text scenario requires the time interval used to check the timestamp value. The time required is determined for 40 seconds. If the timestamp sense exceeds the specified time interval, then the message is considered valid and communication is lost. In this replay attack, the sending of message 2 will be defined using delay. The time interval is determined based on the results from the transmission test that has been carried out with the acquisition of the average protocol processing time of 27.16 seconds. Taking into account the presence of obstruction and other disturbances, therefore 40 seconds is taken as maximum time tolerance for message transmission. Based on transmission distance tests, it can be seen that from experiments carried out for a distance of 10 centimeters for 140 centimeters, then the time obtained can be said to be stable, ranging from 26 seconds to 28 seconds. This shows that distance has a significant effect on the authentication speed of the device. But the device has a distance maximum for mutual communication is 140 centimeters, and the average time required to authenticate the device is 27.16 seconds. For the attack test carried out on the modified Berdaulat protocol scale that has been implemented on the Arduino Mega 5T25 and 60 board, it shows that this protocol scheme is proven to be able to overcome this attack by giving a time limit of 40 seconds, starting from the start of the protocol bank 1. If the attack is carried out for a period of more than 40 seconds, timestamp considered unable to guarantee freshness of the message. And then from this research, we obtained the result in the form of implementation of the Berdaulat protocol uses present encryption algorithms, uses secure hash algorithm 256 for the max calculation process. Based on the testing, it shows that the modified Berdaulat with timestamp protocol scheme can run well. And the result from the implementation get the average time needed for the device kit is 27.16 seconds. The shortest time of time in the experiment is 26.26 seconds. When the distance is 40 centimeters and the maximum distance aside is 140 centimeters. And last, future study suggests using additional power amp or PA, low noise AMP or LED antennas in the wireless module on RF24L01 plus, which might increase the distance between devices. Also, suggest key management implementation so that the system can accommodate tag or reader addition needed. Then that is all that we can present. I hope so this research can be useful for you. Thank you very much.
Okay, thank you, Ms. Nia, for the interesting presentation. And now we will begin for the question and answer session. Is there any question from the participant? Okay, so for Ms. Dewi, please turn on your camera and turn your microphone.
Okay, thank you for the opportunity. I would like to ask Ms. Nia about the presentation. In the previous design and in the conclusion slide, it is stated the encryption algorithm is present. And I want to know why the author chose present as the algorithm for encryption in this RAPWOTA protocol. Is there any standard or something like that? Please answer my question. Thank you.
Okay, for Ms. Nia, please answer the question.
Okay, thank you for the question. I will try to answer the research conducted by Rajaguru et al. Or Shafila et al. Do not explicitly mention encryption algorithms. They just said it is necessary to use an encryption algorithm to run this authentication protocol. However, in the research of Rajaguru et al., he suggests using the present encryption algorithm in the conclusion section. Besides, based on the recommendation, the RAPWOTA protocol is implemented in a hardware environment. Therefore, the present algorithm is suitable for application in a hardware environment because the present algorithm is one of lightweight algorithm for processing encryption. And present algorithm have a high level of efficiency when implemented to hardware based on the research of Isha Bardwaj in her paper entitled A Review of Lightweight Cryptography Algorithm for Data Security and Authentication in IoTs.
Okay, thank you for Ms. Dewi for the question and Ms. Nia for the answer. And is there any question from the participant?
I'm sorry, could I ask one question more?
Okay, please.
Okay, and as long as I know that you choose hashing method with SHA-256, and why did you choose that hashing method? Thank you.
Okay, I choose SHA-256 method because even though the paper states that it requires a 32-bit MAC function, the small present algorithm was used. However, after the integration process, the resulting MAC value is not appropriate and interferes with the validation process in the protocol. So we try to use the SHA-256 algorithm because the differences in the length of the MAC value does not affect the running of the protocol because the MAC values generated from SHA-256 can still guarantee the integrity of the message. Besides, SHA-256 is lightweight as well and reducing the computation load. Maybe enough for me. Thank you.
Okay, thank you again for Ms. Diri for the question and Ms. Nia for the answer. So, because we almost running out of time, maybe I will conclude this presentation. And so after all of the four presentation, the previous presentation conclude this session 15. I would like to kindly remind all the presenters again to fill the attendance form given in the chat box. And on behalf of the 2021 Icramet Committee, I would like to thank the presenters and participants for your participation. And stay safe and keep healthy. Have a nice day. Thank you.
Recording in progress.
Good morning. Do you hear me, please?
Yes, good morning.
Good morning. How are you? Okay, thank you. Yes. Okay.
Assalamualaikum, Prof. How are you?
How are you, Professor Army?
How's everything there? Good.
Very good. Good. So we are starting at 2:30 your time, right?
Yeah, sure.
Okay. Very good. So it's a 40-minute talk, right? Or
it's around 45 minutes, including Q&A sessions.
Sure.
Yeah, maybe.
Okay,
Yeah, you can arrange 30 minutes for talk or 15 minutes for question and answer.
Yeah. I'll try to make sure that I go at the right pace, but definitely I will take note of the time, and because I have a little bit too many slides here, but sometime maybe towards the end I will skip some maybe high-level slides so that we can give enough time for the Q&A part.
Okay, thank you, Prof.
Okay. Everyone, thanks for promptly joining with us again. By now, we have completed all 54 paper presentations. I would like to thank for all presenters and also co-authors and participants who has actively contributed to the paper presentation session. Hopefully, the talks and the discussion will be beneficial for your next research project. Distinguished guests, invited speakers, presenters, and participants. Finally, we have arrived to the final keynote talk sessions. We have 2 keynote talks before us. First will be presented by Professor Muhammad Slim Alowini from King Abdullah University of Science and Technology, Saudi Arabia, and Air Vice Marshal Juleksi Tambayong as the Head of Research and Development of the Ministry of Defense, Republic of Indonesia. To moderate the session, first I will introduce you to Dr. Nasrullah Army. Dr. Nasrullah Army received his Master of Engineering degree from Toyohashi University of Technology in Knowledge-Based Information Engineering Department, Japan. He then received his PhD from University of Technology Petronas, Department of Electrical and Electronic Engineering, Malaysia. Since 1997, he joined as a researcher at the Research Center for Electronics and Telecommunication, Indonesian Institute of Science, LIPI, or now is known as BRIN. Currently, in addition to his position in National Research and Innovation Agency, to his position as researcher, he is also active in giving lectures on the telecommunication transmission in Telkom University. His research interests are in cognitive radio, dynamic spectrum access, wireless communication, wireless sensor, and wireless sensor network. Okay. To Dr. Nasrullah Army, you can start moderating now.
Okay, thank you, Ms. Gita. Now we reach to the final session, keynote talk by two speakers. The first speaker is Prof. Muhammad Slim Alowini from King Abdullah University of Science and Technology, Saudi Arabia. He would like to share a previous talk regarding how can 6G respond to 6G communication, respond to pandemic. And the second speaker is Air Vice Marshal Juleksi Tambayong. He is coming from the Ministry of Defense, Republic of Indonesia, and he wants to share the issues of regarding dual-use technology to overcome the pandemic. Before start the talk, I would like to introduce these two keynote speakers. First one is Prof. Muhammad Slim Alowini. He completed master and PhD degree from Georgia Institute of Technology and California Institute of Technology, USA, in 1995 and 1998, respectively. And Professor Alowini also distinguished professor of electrical and computer engineering. And he also affiliate professor of applied mathematics and computational science. He affiliate professor of statistics also, and principal investigator of the communication theory lab, CTL of the King Abdullah University of Science and Technology, from Makkah, Saudi Arabia. And Prof, you have 45 minutes for the presentation, and including question and answer session. you can manage for the slide, so we can keep the time strictly. Time is yours, bro.
Okay, thank you very much, Dr. Nasrallah, for the nice introduction. I would like, of course, to thank all the organizers of the Icramet conference for inviting me to deliver this keynote and for giving me and my group the opportunity to present some of the research we are doing at KAUST in the area of wireless communication for beyond 5G type of systems. So let me share my screen. So as mentioned earlier, the title is How Can Beyond 5G or 6G Respond to Pandemic? So in a way, what should we learn from what happened over the last 2 years to kind of take more advantage of our wireless communication systems and networks? So as you know, compared to, I would say, previous wireless generation of communication system, let us say that this brainstorming that typically come in our research community before the start of any new generation of communication system, when we talk about 6G, this brainstorming start relatively early with, as you may remember, a first 6G summit organized in spring 2019 in Finland. So it was like 1 year before the pandemic hit us. And then, of course, we all know that we all were hit with the COVID-19 pandemics, which actually forced the second 6G summit that were supposed to be organized face-to-face in March 2020, and that was moved very quickly, pretty much over a weekend, virtually at the last minute, as I mentioned, because of the different lockdown restrictions that start being implemented worldwide. And actually, this led many of us in the wireless research community to start thinking about how current, emerging, and future wireless communication system, and more generally ICT tools, can basically help us fight a pandemic, not only actually fight the pandemic, but also save the economy during a pandemic. So, you know, obviously this is all happening again because 5G is being deployed worldwide. And we know that sooner or later 6G is coming by the end of this decade. So this exercise is obviously a natural exercise that we go through every 10 years. Now, that's the theme of my talk, is at least a starting point. How can wireless communication help us fight the pandemics and save the economy? So essentially, along three of my colleagues here at KAUST, Dr. Nasser Saeed, Dr. Ahmed Badr, Professor Tariq Al-Nafouri, we wrote during the start of the pandemic in spring 2020, a perspective paper mentioned in the slide in front of you, was published about a year ago. We wanted basically in this paper to emphasize how wireless communication technologies are being now used to help combat the pandemic by, let's say, number one, for example, monitoring the spread of the virus. Number two, enable healthcare automation. And number three, permit virtual education and more generally, video conferencing. We wanted also to convey that in one hand, the importance of digital inclusiveness in the pandemic is becoming very kind of critical. And we wanted to advocate for possible solution to connect the unconnected or underconnected. And then, on the other hand, we want also to explain that the challenges posed by the use of wireless technologies that the wireless technologies are facing today, like let's say concerns about privacy, security, and misinformation, have also to be dealt with in a very kind of urgent fashion. So in addition, it was, in our view, important to highlight the importance of wireless technologies in the survival of the global economy. So it's not enough to fight the pandemic, but we need to make sure that the economy is still going. And this can be done by enabling automation of industries and the supply chain, by empowering e-commerce, and of course, supporting occupations that are at risk. So the final kind of message we wanted to kind of convey as part of this perspective paper is that the rapid development of wireless technology during the pandemic is likely to be useful in the post-pandemic, because hopefully sooner or later we get out of this pandemic and we'll go back to the so-called new normal era. And we kind of project that in this new normal era, we'll be taking advantage of some of the development, some of the kind of user scenario that we got used to as part of our usage of technology or ICT tools during the pandemic. So let me focus now on fighting the pandemic and in particular monitoring the spread kind of aspect. As we know by now very, very well, obviously limiting mass gathering, keeping social distancing, using contact tracing, I would say are some of the key guidelines that need to be adopted in order to minimize the spread of the virus, both in indoor and outdoor environment. Now, in this context, a variety of wireless communication technologies, including drones, cellular positioning systems, and GPS, can be used to monitor the transmission of the virus. Basically, example of this is in metropolitan area, as you see in the left side of this view graph, network of drones can monitor crowds to maintain social distancing. And, you know, there are many countries where they introduce the so-called pandemic drones to enforce basically social distancing. These UAVs can also monitor body temperature and the presence of flu, sneezing, and I think even like, for example, coughing, you know, in public places. So once the drones collect this critical data, this must be communicated to the authorities in real time so that timely action are taken. So in addition, of course, to these pandemic drones equipped with real-time wireless connectivity, one can assist with the data collection and instantaneous reporting of these valuable data. So that's kind of the advantage of this kind of deployment. In outdoor working environment, outdoor positioning technologies can maintain social distancing and safe working distance for critical workforce. However, when we are in indoor environment, maintaining safe distance may be more challenging due to sometimes the unavailability of GPS signals like in indoor environment. In this case, we need to go either to kind of Wi-Fi type of solution or Li-Fi type of solution along the lines of the recently developed so-called proximity trace technology, which is a joint sensing and communication technology for workforce distance monitoring while maintaining essential business, as illustrated in the right slide in front of you. So this technology can basically offer both a passive or active option, and by that I mean in the passive approach, each worker interaction are tracked in the, if they test positive for the virus. Now, in the other hand, in the active approach, workers are informed in real time using sound or visuals to maintain, or let us say, enforce social distancing in an active way. Now, I would like now also to mention that in our view, the COVID-19 outbreak is also, let's say, proving to be a catalyst for beyond 5G and 6G innovation, especially in healthcare automation. So indeed, wireless connected medical robots can now, for example, deliver drugs, can check the patient's vital signs such as temperature, etc. And also, this robot can be used to disinfect hospital rooms. So all this, of course, we are doing using robots for all this in order to reduce the exposure of medical personnel to the virus. In addition, in an integrated, fully connected healthcare system, the general medical staff at the hospital can consult with experts, let's say, more specialized or competent medical doctors in particular fields miles away through a fully connected remote video connection type of networks. So that's another important aspect where wireless communication can play a big role. Now, let's say finally, let us also quickly talk about how the COVID-19 pandemic has been reshaping almost every single aspect of our world, starting with education. As you know, across the world, school, university have been for many months closed, and they are coming back and forth, depending on the situation of the different waves of COVID-19. And this have forced many students and professors to move online as social distancing measures continue to be enforced here and there. So besides wireless network coverage, connection speed is, of course, a key factor in efficient e-learning. This is where actually emerging and future wireless network can play a significant role. I'm talking here about these networks that can enable, let's say, seamless augmented reality and virtual reality type of environment where students can attend virtual classes as illustrated in the left figure displayed in front of you. On another front, in the midst of this kind of COVID-19 outbreak, e-commerce is emerging as a critical strategy for preserving jobs, and the combination of beyond 5G, 6G, and technologies such as, let's say, IoT, AI, blockchain, AR, VR, all of these kind of emerging technologies, they are all here to transform, I would say, the e-commerce ecosystem. So finally, I would kind of conclude on this kind of motivation part of my talk about this interaction between wireless communication, ICT, with this pandemic situation, that two primary reasons for the crumbling of global economies are the shutting down of whole industries and the disruption of supply chains. However, the industrial IoT paradigm can actually enable smart and adaptive manufacturing by employing smart sensor and reliable connectivity to interconnect and digitalize traditional factories, as illustrated in the slide in front of you, of course, on the right figures. So these are basically some of the important remarks I want to start with to kind of make this interesting, at least from my perspective, connection between how wireless communication are emerging and how they have been used to kind of fight the pandemics, save the economy, and hopefully how can we learn from this to be better prepared for the rest of the pandemics, but of course potential other pandemics that can hit us in the coming years. So one key aspect when we talk about obviously beyond 5G, 6G, and so on, is that we have to remember that connectivity matters the most. Why I'm saying that? Because while talking about these kind of amazing kind of technologies that are kind of beating all kind of records in terms of speed of connection, in terms of capacity of use that can be connected simultaneously, in terms of extremely low latency, we tend to forget that we are still living in a world where basically roughly half of the world population, or a number somewhere between 3.2 billion to 4 billion, are still unconnected or underconnected. The reasons are many. I'm not going to focus here on, let's say, social type of reasons that goes from the fact that many of these people lacks, let's say, computer skills, I mean, how to use a laptop or a smartphone, maybe lack of relevant, let's say, digital content to that population, or lack of understanding of the language mainly used in the internet, English. So that's maybe one reason behind this digital divide. But I would like to focus on rather maybe some of the technical / economical reason, such as, for example, the lack of sometime availability of a reliable power grid, or the difficulty of backhaul at low cost, very remote areas. It doesn't make much business sense to lay hundreds of thousands of kilometers of cables to reach very sparsely populated areas. So, and this digital divide or connectivity divide, we kind of have seen as part of the pandemic that is becoming in a way the modern face of inequality between the have and have not in this digital context is not affecting only people in rural areas or people in remote areas in developed countries in developing countries. It can basically touch the heart of some of the big cities in the world. I'm talking here about the low-income neighborhood, the refugee camps, the slums, favela of the world, where basically, let's say, this low-income neighborhood population cannot afford to basically be connected because basically the subscription can be too expensive for the kind of income they make. So affordability is, of course, another aspect. And if you want to kind of democratize internet access, you need to, of course, solve these affordability problems at different levels. At the backhaul level, how to can reach this remote area in a cheap fashion, at the access level, also at the device level. You want people to use smartphones that are able to browse internet at a relatively comfortable speed without being super expensive. Now, obviously, if we are able to bridge this connectivity divide over the coming few years, then we can start providing better remote health services, remote education services, have opportunity for people to start access, let's say, financial type of transactions and eventually new job opportunities. And in a way, we can break this vicious cycle of digital divide by developing and making some of these isolated and rural low-income area grow economically as part of this benefit that comes with connectivity. And one can ask the question, why is it so difficult to basically connect more people? I mentioned that at the high level when I start talking about this in this talk, but if you want to look at it in a more, I would say, specific way, you can look at this view graph where basically we are kind of illustrating how the quality of experience depends on the cost per user in remote low population density areas. And what you notice is that one can use classical geosatellite. The problem with that these have been designed for broadcasting, so they are not very suitable for internet browsing, and current services are still quite expensive when you rely on satellite for internet browsing. Or if you use like this point-to-point optical fiber or microwave wireless link, as I mentioned earlier, it becomes very expensive to kind of connect these sparsely populated areas. So the holy grail of global connectivity is to come up with systems that can basically benefit from both worlds, that can give you the satellite type of coverage with an optical fiber type of speed. Okay, so which means you have a super high quality of experience, but the cost per user is low. And that's what we would like to achieve as part of the evolution of our networks in order to be connecting more of the unconnected or underconnected. Now, how can this be done? This can be done by doing it in a completely reverse way. We do it in a highly dense urban environment. You don't want to go for this super dense small cell. Rather, you want to go for macro cells. You want one kind of tower or one kind of base station to cover as much area as possible in order to be able to connect as many users within these sparsely populated areas. So one way to do it is to take advantage of TV towers and attach to them some base stations, trying to use the, let's say, the UHF, VHF band, which have very nice propagation characteristic, and that can give you these macro cells of tens of kilometers. Now, if you don't have TV towers or you don't have hills on the top of it, typically TV towers are put to gain in altitude. What you can do, you can create artificial super towers in the air. This is being developed in the US, for example. There are a few companies like RTU Wireless and Alteros that are kind of building these tethered balloons or airships or aerostat, depending on the technology being used. So they are tethered, which means they connect to the ground with a cable. This cable provides power supply to the payload that includes an aerial base station, and also provide or you can say you can insert within this cable a fiber optic to give a high-speed kind of backhaul connection to the payload. And the type of coverage you can achieve with this kind of tethered balloon is roughly, I would say, a few tens of kilometers, 40, 50 kilometer radius around the tethered balloon. And the tethered balloon can be backhauled using either fiber optics on the ground or satellite link on the ground. So that's an area of I think I like it personally. We have worked on it. We have a survey paper on this topic. It's under review and it's available on archive if you're interested by this technology. Now, if you want to gain in terms of coverage, you need to go even higher. And by that, I'm talking about high altitude platform station. Sometimes they are called high altitude pseudo-satellite, HAPS in short. These are drones or balloons or airships that are flying in the stratosphere. By that, I mean at an altitude roughly of 20 kilometers, just for calibration point. Airplane fly at 10-kilometer altitude. So we are way above airplanes. We are in the stratosphere. We are trying to take advantage of the favorable wind kind of condition stratosphere to make these kind of high altitude drones stay stable. So they are acting like a pseudo satellite. They are not in an orbit. They are basically in a fixed location, trying to cover an area with a radius of coverage roughly of 100 kilometers. That's what we are talking about. Now, the two projects I'm showing here, unfortunately, these are projects that were not able to be kind of pursued. They were kind of successful technically in the sense that they were able to kind of do some successful demos. Aquila was led by Facebook, ruined by Google, but eventually they had to stop because there was no good business case. But the good news is that HAPS is being pursued by a few other, let's say, startups that have more expertise in the aerospace engineering kind of area. Because as you can imagine, I mean, this is not really just a telecom type of project. I mean, telecom is just to attach a base station to this flying device. So really the innovation or let's say a lot of the effort that have to be developed is in making sure that these higher platforms are stable and are flying in a very safe fashion. So most of the effort is there, and there are many companies worldwide in Japan, UK, and US trying to develop this HAPS technology that hopefully will become part of our ecosystem and that will help connect the unconnected. Because one of the main advantages of these HAPS is that, contrary to satellite, you can connect to them directly with a standard phone. Now, you probably have heard, and I will talk down the road about all these mega satellite constellation projects. These will not allow you to talk back to a phone. You will always need the ground infrastructure to act as relay between your phone and the satellite. But with the HAPS, the budgeting is such as you can connect with your phone directly to the HAPS, which means the HAPS is going to act as an aerial base station, 4G or 5G, and you'll be talking back to it. And of course, the HAPS will be backhauled through a feeder link that will be connected to a gateway on the ground so that you are connected to the internet. Now, as I mentioned, you need to backhaul all these networks. So it's not enough to have access like through these towers or these HAPS. You need to have like a global backhaul. Now, the traditional solution is to rely on geostationary satellite. This is evolving. People are talking for the next generation geostationary satellite, which are supposed to be like this very high throughput satellite that will have a global coverage with super high speeds. But if you want to lower the latency, then you have to go to lower orbits. In that case, you are not anymore geostationary, so you'll be kind of rotating, and you need a lot of satellites to be able to cover simultaneously basically the whole Earth. And you probably have heard about all these mega constellations being launched by the big tech companies like SpaceX, Starlink, or Lightspeed from Telesat, or OneWeb, or Amazon Kuiper. All of these are proposing a mega constellation that are going to be in operation within the coming few years. Some of them are already kind of having some operation in the northern part of the globe, but this is going to be expanding more and more as we move forward. And obviously, it's going to, I would say, create this kind of umbrella that we are looking for to kind of provide backhaul anywhere you are in the world. So the key point here that I would like to highlight is that what is different between what we are doing now and what happened, let's say, 20 years ago. Those of you who may remember the late 90s, early 2000s, where people were talking about, there was a big boom about also mega constellation with Iridium and with Teledesic at that time. Some of them kind of survived like Iridium, some of them collapsed like Teledesic. But at that time, satellite communication and mobile communication were going on two different worlds. the key point here is that we are looking at integrated system, that from the end user perspective on the ground, the phone will be the same. We are not going to buy special phone for satellite and another special phone for the ground network. We are using the same 4G, 5G phone. It is the network through, for example, satellite backhaul of the base station on the ground that's going to take care of this in a seamless way for the user of this integration between the space, the air, and the ground network, so that basically user kind of connect to the internet. And this kind of collaborative approach between these different networks are going to make them, I think, progress all rather than having some failure as we have seen in the past. So what kind of new normal we can see in few years? One aspect we would like kind of to emphasize is that one has to remember that we are all aware of this United Nations Sustainability Development Goal, SDGs, which basically are supposed to be achieved by 2030. Incidentally, 2030 is the year where 6G is expected to be deployed. So there is like here nice kind of timing that kind of lead us to say that we hope that 6G, contrary to the previous generation of wireless communication systems that were essentially driven by profit and financial consideration, 6G should be driven at least in part by these SDGs, which means 6G should be more efficient, and I'm here not talking about spectral efficiency only, but also power efficiency, be more green. This is something I'm not emphasizing here, but that's of course an important aspect. We want 6G to have no bad effect on environment and human health. All of these kind of concerns about health have to be cleared and justified. Digital inclusion, as I just mentioned earlier, is critical. We want to make sure so that everyone can benefit in beyond pandemic time and even during any pandemic of the IT technologies. We need to have more digital inclusiveness, and we need to connect the remaining 3+ billion that are currently unconnected or underconnected. As we rely more and more in our daily life on this wireless network, we want it to be more secure and more private. And of course, because actually we rely more and more on these, we cannot afford anymore to see an outage of this network. So we need to see more resilience, more robustness, and more dependability coming out of these networks. So the power consumption problem is an important problem that 5G is facing. Initial measurements, China is ahead of many countries in 5G deployment, and initial measurements there are showing that basically 5G are quite greedy. So there should be an effort to develop, I would say, network that can communicate with the right quality of service, but with much less power, because you want to have less, I would say, CO2 footprint, but also you want to lower your costs as an MNO, so that basically the end user also ends up being less at the end of the month. Now, that's another important aspect that often people are kind of confused, and as you may remember, this kind of, I would say, the fact that 5G started being deployed while the pandemic started made all of these fake news go around over the net, claiming this connection between 5G and COVID-19, that 5G can create all kinds of diseases. So I think we need to make sure that we combat the misinformation, and to combat misinformation, we need to probably do some more serious research in terms of characterizing, I would say, the effect of these millimeter wave, terahertz, and beyond, not of course in the ionized part of the spectrum, but we are not there, obviously, we are all using the lower part of the spectrum on our health. From a thermal perspective, all the studies confirm that we are way below, I would say, the threshold that are critical, but maybe there are some other biological effects that need to be, I would say, checked or be kind of better understood. And this is some research that has to be conducted by our colleagues more in biomedical and medical field. But from our perspective as engineers, what we need to do, I would say, we need to make sure that we learn how to design what I call EMF-aware network, electromagnetic field radiation aware network, which means network that are able to operate according to the required quality of service, but try to minimize their EMF radiation or exposure. And this is feasible if you understand the problem. We did recently publish few papers showing how one can design this EMF aware network that minimize the EMF that is being kind of radiated. Now, another important aspect I would like to highlight is that obviously, if you reach this objective of connecting more people worldwide and connecting more areas, you can get out of this, I would say, narrow concept of smart city to something much broader, like smart villages, smart rural areas, smart living in general. And this can lead to some kind of form of counter-urbanization. You don't have to kind of deal with these mega crowded cities and that tend to be polluted, etc. People may choose to live in, I would say, more friendly, less crowded, suburban or even rural environment, as long as they are very well connected and they can still get access to a good health, good education, and do at least most of the days of the week their job remotely. So if this is achieved, I think this can lead to decongesting the big cities and lead to a more smart world rather than just focusing on smart cities and forgetting about the rest of the world. Another interesting aspect that we see as part of the development of this wireless communication network is that they can help emerging and future transportation system. Again, because of this congestion that we are seeing in cities, there is this kind of move towards using beyond underground and ground type of networks, transportation networks here I'm talking about, is to use the so-called near ground space that is lightly used now by helicopter. This is a space that is expected to start being used extensively, for example, by drones for delivery, by flying cars, by flying taxis in order to move people. All of these flying, typically autonomous vehicles at an altitude somewhere between a couple of 100 to 500 meters will need some kind of connectivity. They will need connectivity in order to communicate among themselves, in order to communicate with the ground, in order to navigate in a safe way. That's objective number one. But also they would need connectivity because many of these cars will have passengers, will have maybe some kind of merchandise to be let's say, tracked with some IoT devices. So we need to, again, connect all of these vehicles to the network. And in that context, integrated ground, air, space network are there to help basically from the space in particular, monitor and connect these flying, let's say, vehicles. Let me now, I have maybe 5 minutes or so. Let me basically give you one example of a project we did showing how we can bypass one of the key problems around connected and unconnected, which is basically when you are in an area where you have a lack of power grid. And the idea here is to rely on renewable power access points. So one of my PhD candidate, Murillo Matrascia, proposed this kind of concept. I mean, obviously, many villages and rural areas have some wind turbines for basically energy generation. And the idea is to take advantage of this wind turbine and to attach to them some base station. And with that, obviously, this wind turbine can become not only just a source of energy, but also a source of information. And the base station can be powered by the energy coming from this wind turbine. So you are kind of solving two problems with one shot. And obviously, the wind turbine have to be backhauled because the information is not there. This can be done through satellite link or through basically using this kind of project done by Facebook, where they have this robot called Bombix, which basically kind of wrap optical fiber onto power lines. So that can basically, through fiber optics, you can backhaul all of these wind turbines that are basically that become connected, and through a base station attached to them, they can start basically providing, I would say, connectivity to the region in general. Now, the question, where should we place this base station? Obviously, on wind turbine in areas where there are some wind, favorable wind statistics. So we did some studies in Western France, in Ethiopia, in Southern Argentina, where basically there are some very favorable situations there from a wind statistics perspective. So this is an example of Western France, where we kind of found out about this kind of wind turbine farm. Based on the population density in that area, we were able to select few wind turbine and equip them with base station. And with that, we were able to show that just using the current wireless kind of deployment there, this is the kind of average rate, you get a lot of red, which is not high. Then if you put some wind turbine in selected wind, some base station on selected wind turbine, you tend to get more yellow, better kind of data rates. And then if you kind of select some extra location for this wind turbine, because maybe some wind turbine are not located ideally from a population density coverage perspective, then you can further increase your basically data rates with the kind of extra help that this base station attached to wind turbine can provide. We did the same exercise in Argentina, and we're able to show the same kind of behavior where basically wind turbine can provide, once connected, much better coverage and data rates, I would say, than without base station attached to wind turbines. One last concept I would like to emphasize is that when you do research in the area of connected and unconnected, automatically you find yourself doing research in this other kind of a very related area, which is networking on demand, pop-up network, or network in the box. This means that you may be finding yourself situation like where you are very well connected, but this connectivity can be lost at any point because of any kind of disaster, a tsunami, an earthquake, a volcano eruption that can basically destroy the ground infrastructure, in particular the ICT and telecom infrastructure. So you find yourself that you need on the spot to create a network that will connect the people that are now unconnected. And this can be also for offloading situation where you have super high capacity for a short period of time and you need to provide some extra capacity, or when you send basically people or scientists in the middle of nowhere and you want video stream some videos at any given time and need again to connect them. So you need there a network on demand. So when you talk about a pop-up network or network on demand, you need to solve the backhaul problem. How can you kind of access the internet, a spectrum access or access solution, a power supply, typically through renewable energy, and you want all of this to be done quickly in an emergency type of situation. You don't want to wait hours until you've deployed your network. So one example we did in a paper that is going to appear, has been accepted, is going to appear in a special issue of 6G early next year. Consider here that you have a disaster that hit this kind of area in red. And then obviously, because of this disaster, these base stations have been destroyed. So there is no connectivity anymore here, whereas it's still available here. So what you do, you send some network in the box in the form of drones. These drones are going to act as aerial base station that are going to give access, and there can be backhaul through the other base station to the network. And the question we ask ourselves, how many of these drones should we send given the radius of this disaster, at what altitude this drone have to fly, etc., etc. So it's a stochastic geometry based kind of framework. Some of the conclusion we reach, there is always an optimum number of drones you need to send. If you send too many drones using the same kind of spectrum resource, they can start interfering with each other and the performance degrades from a coverage probability perspective. And then the other important lesson we learned from our study is that obviously the larger is the disaster zone, the better it is to go for a HAPS type of solution rather than having multiple drones where basically you start having like 40 or 50 drones over a large area. It's better to go for 1 or 2 HAPS to cover, for example, a 100-kilometer area that is subject to a disaster. So that's obviously the conclusion that also we reached. With that, I would like again to thank you for your attention. I would like to thank all my group members and collaborators that contribute to this work. It's a collective and teamwork to be able to do research on all of these topics. And I will be happy to take some questions.
Thank you for the quite interesting talk, and hopefully you can attract many questions in this Q&A session. Okay, first question. You can also read the question in chat room, Prof. As we know that this is a first question, as we know that the emerging of 5G technology is driven by use case which classified into the MPP. UR, LFC, and MNTC, and enabling technologies such as massive MIMO, millimeter wave, etc. For 6G, what kind of use case that drive the emerging of 6G? Does it cover other use cases that are different from what previous wireless generation covered? And what makes 6G different from previous wireless generation, particularly 5G? Okay, that's it.
Yeah, thank you for this very comprehensive and excellent question. In my view, I mean, we are still at the early stage of this brainstorming exercise of beyond 5G and 6G. But one easy way to answer this question is to say that the user scenario we had for 5G can be kind of just kept for 6G, but pushed further, which means if you are talking about, I don't know, like 1 gigabit per second type of peak type of data rate transmission, for 6G, we'd like to see 1 terabit per second because we'd like to see, virtual reality type of application, holographic communication, and so on. Latency may be kind of even further be slashed. If it is 10 milliseconds now, or by 5G, maybe wants to be like 1 millisecond indeed for 6G. So the same kind of use scenario, the same kind of metric, but basically with higher expectation. That's one aspect. The second aspect is, as you know, 5G have these 3 user scenario, MMTC, URLC, and this EMBB. These are 3 kind of, to a certain extent, independent use scenario. But for 6G, you may end up to need both scenarios together. You may want to see EMBB with URLC, which means you want super high-speed connectivity, but with ultra-low latency for virtual reality, for holographic communication. So you can see the combination of 2 user scenarios coming together, which make not only the expectation higher for individual use scenario, but a combination of 2 use scenario needed for certain application. And that's something that 5G was not planned for, and that 6G can be designed for. And then third, I would say, comment I would like to mention is a little bit related to what I have been talking about, is really 4G, 5G, and so on, have been focusing on this kind of how can we keep better connect the connected, or what I say in some of my talks, super connect the connected. That's our kind of usual game. It's the Olympic Games of telecommunications. How can we beat the record of the previous generation? But one thing we are forgetting, and we keep forgetting, is that we still have half of the world population unconnected or underconnected. So 6G should focus also on democratizing internet access and making sure that, of course, we need to keep doing these Olympic records for people who are in urban, super connected areas, but we need also to make sure that 6G will have some use scenario where we will achieve this very noble so-called Gaia objective. Gaia stands for Global Access to Internet for All. And that's something that should be part of the DNA of 6G. I hope I answered the question, but I think that's in a way what I want to mention regarding this issue. I think Dr. Nasrallah, you are muted.
Yeah, sorry. Yeah, thank you, Prof, for the answer. And the next question is coming from Arum Jenny, raising hands. Please direct to Prof. Iruni.
Okay. Hi, Prof. Slim Aloini, and nice to meet you. I know that you're a very prominent professor in these topics, right? So 6G topics have always been of my interest. I have 2 questions. First, now 6G has not been implemented yet, only 5G, and in my country is mostly 4G. 5G has only been implemented in a really small area. I wonder what would happen if 6G had already been implemented in this pandemic era. What do you think the aspect that would have been better? Will the deployment of 6G also affect the eradication of the virus, in this case indirectly, and in what manner? And the second question is, will millimeter wave communication system be the key technology for 6G? If not, what will be the key technologies? Because I saw that MM wave has also been proposed for 5G. Thank you.
Thank you. I understand the second part of the question. I didn't understand the first part. What did you say? What 6G eradicates what? I
mean, if 6G is already here right now, do you think our condition in this pandemic era would have been better?
So okay, good point. So okay,
you mentioned so many things about it, right?
Yeah. Okay, I see.
I wonder.
I see what you're saying. Yeah, I see.
Okay, thank you.
Thank you. Okay, so basically, obviously 6G is not here yet. I mean, even 5G, like we said, most countries is still not being deployed. So, let's forget about these 5, 6, 7G. Let's talk about wireless communication and the amount of connectivity. Obviously, if the world were much better connected than it was when the pandemic hit us, many people, many countries would have, I would say, lived better the pandemic. Many jobs would have been preserved. Many more students would have been going to school and learn online. As you know, UNESCO reports were alarming. I mean, there are few countries were able to survive because they have very good connectivity. Many countries, even sometimes within the same countries, a big divide between urban and rural environment. So I would say, if what I'm talking about, which is this global connectivity, was there, I think we would have coped in a better way in education sector and some economical sector, basically in terms of fighting the pandemic and making the economy and our social life kind of more or less survive. Of course, I mean, the pandemic is there. We will still probably have some health issues, as we still are all, as you know, now there is like revival of the pandemic in Europe. I'm not sure the situation in Indonesia. Here things are more or less under control, alhamdulillah, so far, but I'm not sure how is it. I know in Europe now the situation is back, to this kind of critical situation. So what I'm trying to say, there are things that, a pandemic is a pandemic, but with a better wireless connectivity, many things can be solved. And what the pandemic showed, that we're not fully ready because a lot of issues didn't go as expected. That's, I think, my answer to the first question. The second question is, yes, it's a natural evolution. So if you want to go to this higher speed, you need to go to higher part of the spectrum. So millimeter wave have been proposed about 5G. They are still, they are lightly being used, to be honest, in the early deployment, but I would see them being deployed more and more as we move from 5 to 5.5, eventually to 6G. And as you may know, actually now the big kind of research topic that a lot of people are investing in, as you know, China is always leading now in wireless communication with the top kind of Chinese university and Huawei in terahertz communication. Of course, there are also some European and US university also. So terahertz are actually a very active field, which is basically pushing the envelope. Millimeter wave is going to be saturated at some point. If you want to go for this holographic communication, terabit per second, then you can go to the upper part of the spectrum, and the terahertz is the next thing. And then even further, reaching at some point the optical band. That's a band that actually has been proposed for many years for wireless communication. I have been myself quite active in optical wireless communication. Here I'm talking about free space optics and VLC or Li-Fi. It's an area that kind of never picked up for terrestrial application at the big scale, but at some point we really will be needing all these super high speed connection everywhere, and the spectrum congestion will become a problem. Eventually, we may need to go and start using the optical power spectrum as part of mass deployment.
Okay, thank you, Prof. Salim Aloini. So from your answers, now I know that the democratizing the communication technology and also make a better global connectivity is the key for everything in our life, right? Thank you so much.
Thank you.
Okay, this is one question from Chatum from Dr. Julia Berdaus. I have a silly question, perhaps. We have now 4G, 5G, and maybe it will be 6G communication. How about the next technology? Is there any limit theoretically?
Is there any limit? That's the question, right?
Yes, yes.
I think there is no, I mean, as researcher, as scientists, many of us in this room, right? I think we believe in a world where there is never a limit in terms of research progress, because let's assume that we solve all the problems I mentioned, but maybe 30 years down the road there will be some people living in the moon or maybe in the Mars, and we will have developed wireless communication system for people living in these planets, and then communication system between us and them in real time. So there is nothing that can stop us from dreaming out of the box. So I would say that there is always new challenges, but you cannot always predict what are the challenges way ahead of time. There are people who are visionary, like Tesla, who was able to have a vision 100 years ago of what basically we are talking about today, and about 5G and 6G. But those of us who are just like our standard researchers, we just take these challenges one at a time. So now we know what are our challenges for the next 10 years, but I'm sure that once we solve these kind of challenges, or at least most of them, there'll be new challenges that will come to us. Like another interesting challenge, actually, that we tend to forget is the underwater world. Underwater communication is still very much an unexplored field. What we have now is very low speed. There are some ways to go high speed with optical communication, but still at the experimental stage or at very low kind of deployment stage. But more than 70% of Earth is covered by water, and only 5% of this water have been explored. So basically, if you want to have full coverage, full exploration of the underwater world, you need a lot of kind of full connectivity to a certain extent, and other, of course, underwater technologies. So as I said, I don't believe in limits in the sense, human limits, of course, but in the sense that basically this problem will come one at a time.
Okay, thank you. Thank you for the answer, Prof. Still any questions? Yeah, if no question coming from me, the question is you know that pandemic is happening, and 6G is part for implementation. And even in Indonesia, as Arun said, that 6G hasn't been implemented. And what the challenge fighting pandemic using the current network like 4G, Prof?
Sorry, we lost you, Dr. Nasrallah. We don't hear anymore.
Yeah. No, actually, what the challenge fighting pandemic using the existing network like 4G, because you know that in Indonesia 5G hasn't been implemented. Yeah, then 6G is far from implementations. And what we can do with the current network to face the pandemic?
Yeah, I mean, this is a question that comes always. Or like for many kind of countries. Sometimes when you are like basically, sometimes the investment is too much, not worth it to go incrementally from one generation to another. So I've seen sometimes people jumping a generation. So maybe Indonesia maybe need a little bit more time, and a few other countries to fully deploy 4G. So until it mature in let's say Indonesia, and then after a few years when that technology matures 4G, instead of getting into 5G, by then maybe 5G would have evolved to 5.5 or close to 6. Then basically you jump right away from 4 to 6 and you bypass 5G because maybe it's too much of an investment now, given that Indonesia is a huge country, and you know maybe it's not worth it to kind of go through all of these cycles on a 10-year basis. So I have seen countries doing that before by, for example, jumping right away from 2G to 4G and skipping 3G. This happened in a few countries. So it may happen also for between 4G and 5G and 6G in some countries.
Okay, thank you for the answer. Prof. Iluni, time is over. Yeah, maybe over the limit. And we would like to give some appreciations. Yeah, this is
thank you.
Token appreciation from the committee of Icramet 2021, and hopefully we can see you in the better condition. Yeah.
Hopefully.
Thank you, Prof.
Yeah. My pleasure. Thank you again for the invitation, and looking forward to meeting you hopefully face to face at some point in some conferences throughout the world. Thank you very much.
Thank you, Professor Muhammad Slim.
Thank you. Thank you.
Okay, we moving forward to the next keynote speaker. He's coming from research and development of Ministry of Defense, Republic of Indonesia, will be delivered by Air Vice Marshal Seleksi Tambayong. Is head of research and development of the Ministry of Defense Republic of Indonesia. Before start the talk, I would like to introduce. Sorry, what about the CP? Not introducing the. Yeah, I would like to introduce Marshal Seleksi Tambayong. He completed PhD in 2008, PhD degree in semiconductor technology from University Kebangsaan Malaysia, and in 1996, bachelor and master in electrical engineering, University of Technology, Aachen. Yeah, and research experience, he assigned in 1988 is Air Force Academy, and 1988, Ida Flying School Batch 40, and 1997 Air Force Unit Command School Batch 61st, and 2000 Aviation Instructor School, and 2002 Army Command and Staff College Batch 38. And 2008 Strategic Intelligence Officer course and Defense Task course, and 2013 Indonesian Armed Force Staff and Command School. Seleksi Tambayong would like to deliver the topic regarding dual use technology to overcome the pandemics. Please, time is yours.
How do you read me, Mr. Nasrullah?
Yeah, you, sorry?
How do you read my voice?
Yeah,
okay.
You can hear your voice.
Okay, distinguished guests, ladies and gentlemen. Thank you for inviting me to give a keynote speech at this annual conference on radar, antenna, microwave, electronics, and telecommunications. As we all understand, the theme of this year's conference is about the utilization of microwaves and electronics to overcome some of the challenges during the COVID-19 pandemic. However, since I'm representing the Ministry of Defense, I will talk more about the defense perspective of the pandemic and what the military can do to help the government to overcome the pandemic. Nowadays, the world is facing a pandemic that seems not going to end soon. And globally, we are just facing the third wave of the pandemic, as we can see from the slides. In Indonesia, we are just past the second wave of the pandemic. Even though there is a decrease in the new case of COVID-19 in Indonesia, we should not loosen up the health protocol. Since the start of the pandemic, more than 4 million people were infected by the virus, and more than 100,000 have died. Even though the vaccination program has successfully vaccinated more than millions of people in Indonesia, it is only a couple of % of Indonesian ginormous population. The insurgence of the new variant of COVID-19 is also the reason why we are still a battle with the virus, even though it has already been 2 years since the first case of COVID-19 infection is reported. The government, as regulatory body in Indonesia, has put out some regulations to minimize and prevent the spread out of the virus by applying the social distancing measures as well, continuing the public service announcement to always wear a mask anywhere in public spaces and go to wash our hand regularly. The COVID-19 as a pandemic is not affecting the health stability of a nation, but also affecting the national security if it is not dealt properly. From a military point of view, a pandemic can be classified as non-military threat. Here, a threat can be classified as military threat and non-military threat. For examples of military threats are military aggression, war, etc. As for the non-military threat, the examples are natural disasters and also pandemics and the others. To defend a nation from military threats, we need to use military defense. On the other hand, to protect the nation from non-military threats, we need to use near military defense or non-military defense. What is the difference between the two? Military defense utilizing military force as the main component, while the reserves and medical institution become the supporting component. On the other hand, to cope with near military threat, such as pandemic, the governmental body that is related to the threat needs to be on the front line to overcome the pandemic, and the military becomes the supporting component. As the supporting component during the pandemic, the military of Indonesia has supported the government by deploying human resources support, medical support, logistic distribution, and help to maintain security and public order. The government, with military support, has established the Integrated Joint Task Force Command to help the Ministry of Health to manage the emergency hospital. In terms of logistic distribution support, the military has helped the Ministry of Health to distribute the vaccine throughout the regions, to keep the public spaces as a safe area for the people to do their activity. The military also joined the police to make sure that the social distancing protocol is obeyed. Ladies and gentlemen, you might have heard about a term of dual-use technology. In general, it is a paradigm where the technology can be used for more than one purpose at any given time. In the military, dual-use technology means that the technology that the military has might also be beneficial when used for civilian purposes. Some of the examples of such technology are internet, global positioning system, microwave, or nuclear and artificial intelligence, and etc. These technologies were originally invented for military purposes. However, in the development, these technologies were adopted for public use and proved to be beneficial. In collaboration with the national defense industry, we at the Ministry of Defense are currently developing a technology that not only can be used for military purpose, but also can be used to overcome the near military threat. This technology is called C4ISR, Command, Control, Communication, Computer Intelligence, Surveillance, and Reconnaissance. The reason why we are currently developing the C4ISR system is because from a military point of view, to be a winner in a modern warfare is not only to have a superiority in physical equipment, but also superiority in informational system. This new paradigm is called network-centric warfare, what we call as NCW. By definition, the NCW is a paradigm where a competitive advantage can be acquired by those who have the information advantage. This new paradigm in warfare needs to have an enabler for it to be implemented. In this case, the enabler is the C4ISR system. C4ISR system technology will indeed need to be supported by robust information technology and computer networking. The main advantages to adopt the NCW system is to have a situational awareness at every level of the command structure. When effectively implemented, it will give the commanders a true real-time common operating pictures, and allows forces to self-synchronize and collaborate horizontally. It also provides commanders at all levels the ability to target the enemy with the most effective and lethal mix of weapons. To improve situational awareness, the speed of execution is also increased as decision-making database on the broad and deep information stream is available even to the smallest tactical unit. In fact, tactical units as well as tangentially interested parties can follow the development of the decision-making process in real time. In addition to increasing the lethality of combat forces, improved situational awareness can reduce both incidences of fratricide and collateral damage to non-combatants. Last but not least, the NCW provides an efficient means of integrating single service, joint, allied, and coalition forces into a single homogeneous information operation environment. Of course, some challenges need to be overcome if we want to have a robust NCW system, such as the complexity of integrating numerous different communication systems, bandwidth usage in the battlefield, where it should prioritize the bandwidth to the one who needs it the most, not the one who is closer to the access point. Having an accurate locational awareness is also a problem because of the limitation of GPS signals in remote areas. The network-centric warfare will need to have a secure communication channel, because if we have the network system but the data traveling through the channel is not secure, it is like we are giving away our information to the enemy and the system will be completely useless. A well-developed NCW system can also be used outside its military purposes, such to create environmental awareness at the time of the pandemic. Even though the NCW system that we will have is still in the development phase, I'm sure that it can be used to help the government in the form of a command and control system that can reach to the remote area of Indonesia. This technology will surely be beneficial to gather information at the time of pandemic, such as to gather information about the spread of the infection, health socialization, vaccine distribution, and other medical logistic distribution to remote areas. At the Research and Development Agency, for instance, we are also developing a device that we call the COVID radar. This device can be used as an early detection mechanism for pulmonary disorder. The reason why we developed this device is that because we see that there is a need for portable imaging device that can be moved and can be easily set up to detect a pulmonary disorder, which can be linked to a COVID-19 infection. We have created a proof of concept that this modified radar technology can be used as an imaging device to see whether a person has a pulmonary disorder or not. I know this device is far from perfect and still need further clinical testing. However, if this device is successfully developed, we believe that this device can be used in public places to complement the existing device to limit the spread of coronavirus disease. It is only one example from our program in Research and Development Agency, and we also make many projects. If we can say it is connected with the electronics or microwave radar. In this time also in our agency, we make also the radar ground control intercept And I think next year also we will make the radar what we call it as a man-portable surveillance radar. Before I finish, I just want to give some final thoughts from my talk. The pandemic is not only a threat to health system stability of a nation, but also a threat to national security. This is a threat for all of us, Indonesian people, and the world in general. Thus, we should not only depend on one situation to overcome the situation. We should utilize and integrate every resource that we have, holding hands together so that we can survive the pandemic. Ladies and gentlemen, I hope I've been able to give you an idea about the pandemic from the perspective of national defense. We have seen in looking at the history that cooperative measures during the pandemic are what we need. I've also noted the Ministry of Defense as a regulatory body also taking part in this fight with the pandemic by providing command and control system for the government to have situational awareness, as well as developing a device to detect the pulmonary disorder. Ladies and gentlemen, thank you for the opportunity to address the conference today. And thank you, ladies and gentlemen, for your kind attention. If there's any of you have some suggestions or questions, I'll be more than more happy to answer the questions. Thank you very much.
Thank you, sir, for your talk. Very nice talk. We have more time for Q&A session if you can. From floor, if you have any question, you can write down in the chat room or direct it to Dr. Tambayo. Yeah, from Dr. Yuyu, we didn't have already developed a GCI radar antenna. Is it possible we can cooperate? Sir, you can also read the question in chat room. It's about the collaboration between BRIN and TNI.
Pak Nasrullah, is there any questions?
Yeah, we have a question. You can read also in chat room. Yeah, we BRIN. It is about the collaboration between BRIN and TNI. Yeah, we BRIN have already developed GCI radar antenna. Is it possible we can cooperate?
So far for a project for the radar GCI, actually we have already worked together with PT Land and also some civilian companies and also ITB also. We work together to make the GCI radar. In this year, actually, we have already made the SSR system, what we call it as secondary surveillance radar. And for the next year, I think we will continue the program to make it complete as a GCI system, including the primary surveillance radar. So in terms of cooperation, we already involved with others, what we call it as a triple helix. Not only government, but also industry and academicians.
Yuyu, Dr. Yuyu, satisfied? Yeah, any question? From Teguh, maybe you have any questions?
Not yet, sir.
Okay, sir. Question. With the current technology implemented to test the pandemics, what the challenges actually with the current technology implementation? Like you said that you integrated GPS, yeah, global positioning system. What the problem or the challenge appears so far?
As I mentioned before, actually we just started in the beginning of the C4 ISR program. So not all of the area in Indonesia already covered by internet or electronical system. So it will be the constraint for us to, as I explained before, actually when we have faced the pandemic, we use the existing, the C4 ISR has already deployed in all area Indonesia, but not all area covered by what we call it as C4 ISR. We need to improve the network system that can be covered all area of Indonesia. Because as we know, the military in Indonesia, they already spread out in all area of Indonesia. In terms of personnel, we already in all area Indonesia, but in terms of equipment and network, electronical network, we need to improve. We need a satellite, military satellite. So as I already explained, in terms of disaster, the system, the military system already exists. We can swift to use by government. I think what we need to improve for the future is the network that can be covered all area of Indonesia.
Thank you, sir. Still have any question?
Yeah, Pak Ruli, I have questions.
All right.
Thank you, Pak Marsda Juleksi Tambayong. I am Budi Prawara from Research Center for Electronics and Telecommunications. Yeah, as we know, the origin of virus SARS-CoV-2 came from another country. And now, yeah, we have some regulation to protect our country from, for example, people that coming from abroad enter to our country. What do you think about our protection system now? Is it already enough to protect our country from the people who enter? Yeah, we do hope that the regulation now is enough to for example, when the people enter to our country, they need for a quarantine, for example, 3 or 5 days. But we don't know when he quarantine. Is it the individual always stay in the quarantine place, or they can, for example, go to outside to somewhere, then the virus will spread again. So, and the second questions is what now we worry about the end of year, yeah, and the new year, because in our experience, the case will increase again in this event. So what is the military effort or some idea to keep the confirmed case? As we know now, we have the confirmed positive case lower than 500. I think it is if we can hold this confirmed case, I think next year will be better. Thank you.
Yeah, thank you, Pak Budi. With all respect, that actually I don't want to make a statement beyond my capacity. When you ask about the quarantine and others, I think it's not my capacity. But as I mentioned before, in terms of military support, of defense support to government in facing the pandemic, the system what already exists for command and control, and in the system of C4 ISR, all the effort will be given to government to support the government. So how to detect the personnel, I think in the system of command and control also, the military can support the government. As I mentioned before, in near military or near military threat, the military will support the government to cope the problem. And in the end of year also, we will support what the government already decide what we can do to minimize the impact of end of the year vacations. So in terms of our duty, as I mentioned before, as a supporting component, we will do our best to support the government in terms of technology, the C4 ISR system. We will use the utilization of the system will make the government, I think, easier to collect data, make the situational awareness. I think in our capacity, that's the answer from our side. Thank you very much.
Yeah, thank you, Pak Tambayong.
Thank you, Pak Budi.
Yeah. Okay. Still have any question? If not, maybe we can end this session. Yeah. Okay. Thank you, Sir Juleksi Tambayong. Yeah.
Excuse me.
Yeah.
I have a question.
Oh, yeah. Nofrita, sorry.
Okay. Thank you, moderator. Thank you, Vice Marshal Juleksi Tambayong. I'm Nofrita Dayanti. Your presentation is very nice. My team said you are different from other keynote speaker because military. She said that seperti mendengar Bung Tomo. Okay, I just want to know is there is a possibility of research collaboration between our institution, Research Center for Electronics and Telecommunication, and your institution on focusing on program to the prevention of control of pandemic. We know that we have the facility and human resources, and your institution is has it. This morning, Pak Budi delivered talk about our products research for overcome the virus, such as a ventilator and oxygen concentration, detection kits, and other products. I think your staff noticed that this morning. If we have a research collaboration, I think it's easier to implementation of our products to, for example, for military hospital anywhere in Indonesia. If Balikban Kemhan promote that, what do you think, sir? Are you interested and have funding? Thank you.
Thank you, Bu Novita. You asked about the research collaborations. Actually, nowadays we already make a cooperation with some university. For instance, with the ITS Surabaya and also UNER. Last time our minister already visited these two universities. And in terms of biotechnology, with University of Erlangga, they already proposed us some research, including virus, vaccine, and others. So I think our door will be wide open for your proposal to research cooperation. In this morning also actually already make a presentation with Brin in hotel in this morning, and I already explained the business process from us perspective. As we know, actually all R&D under the ministry will be integrated to Brin, but unfortunately our agency, defense R&D, not included. So in the process business, we need some researchers from Brin and also infrastructures, for instance, laboratorium or others to support our programs. We also actually with ITS already make oxygen concentrator with ITS and also oxygen generator in this year, but because the refocusing in our budget, we only make one program, only oxygen concentrator, not oxygen generator. So as you propose to research collaboration, I think I can say that our agency will wait for your proposal, and if we compare it, it will be the priority for next year. I think in terms of budget, we can discuss later. Thank you, Bu Novita.
Okay, thank you, sir.
What about others? Any questions? Or we can end this session. Yeah, thank you, Marsda and Ijuleksi Tambayong. Very nice talk, and maybe next time we have research collaboration. Before ending the session, we would like to give some appreciation. Yeah, this is a token of appreciation. Yeah,
thank you, Pak Nasrullah.
Yeah, in recognition for delivery of keynote talk in the 2021 Icramet. Yeah, maybe we can see in the next chance. Yeah, with research collaborations. Thank you.
Thank you, Pak Nasrullah.
Yeah,
Bapak-bapak dan Ibu, ladies and gentlemen, thank you.
And then we would like to thank for all the participants and for the people who addressed the question to the keynote speaker. And I would like to return to the MC.
Thanks once again to Dr. Nasrullah Army to have moderated the final session of the keynote talks. As well, thanks to the keynote speakers, Professor Muhammad Slim Aloini and Air Vice Marshal Juleksi Tambayong for having delivered his speeches. Distinguished guests, invited speakers, presenters, and participants, we already completed 6 keynote speeches and the 15 parallel presentation sessions, and that have been brought to us all in Icramet 2021. We have come to begin our closing ceremony. We would like to announce you the awards we confer for selected paper and presentation. The Best Paper and Presenter Award will be announced by Dr. Suyoto.
Okay, thank you, Mrs. Ardita. To distinguished speakers, all presenters, and participants, on behalf of the organizing committee and TPC team of Conference Icramet 2021, I would like to announce the awards given to the best paper and the best presenter. The criteria for the best paper, considering the feedback from the reviewer that cover the novelty or the originality of the paper, its argumentation and discussion, clarity, similarity rating, and the quality of the overall submission. And the best paper goes to the title of Broadband Dual Polaris Planar Antennas for Radar with Printed Circuit Balloon by the author Juan Timay and Fernando Rodriguez Morales from University of Kansas, USA. Okay, round applause to get the best paper. Okay, next. And for the best presenter award, we consider the promptness of the submission, presentation timing, clarity, and logical flow of the presentation. Also, the quality of the answering question, and the best presenter goes to Professor Ahmed Hussein from Prince Mohammed University, Saudi Arabia. Please give a round of applause. Okay, congratulations to all the awardees. I hope this token of appreciation will further motivate you to contribute to your research discipline. Thank you.
Thank you for Dr. Suyoto for announcing the awards, and also congratulations for the awardees. We have come to the end of the 2021 International Conference on Radar, Antenna, Microwave, Electronics, and Telecommunications. With this, I would like to bid farewell to all of you. Thanks for having me as your MC for the 2 days of Icramet 2021. For your information, the certificates will be circulated after the conference ends, so please check your email regularly. Till we meet again, perhaps in the next conference, hope you stay safe and healthy. Now, to close this conference, please welcome Dr. Novrita Idayanti as the Chair of Icramet 2021.
Thank you, Ms. Ardita. Honorable guests, distinguished keynote speakers, presenters, participants, ladies and gentlemen. On behalf of the Icramet 2021 conference and the organizing committee, I am delighted to deliver this closing remark on the success of the event. I believe that during the conference, we have all had insightful, interactive discussion and the outcome of our research. Finally, I would like to thank our distinguished keynote speakers who shared their valuable experiences, IEEE Indonesian section and chapter, Himpunan Does Java, authors, presenters, reviewers, our patrons, the Salt System, PT Rode and Swart Indonesia, PT Berkah Handaya Perkasa, PT Pembangunan Perumahan Persero, and BRI Bank, and all parties who have contributed their best effort and assistance in organizing the event. Thank you for the great contribution and looking forward to see you in the next Icramet. May God protect and bless us abundantly. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Warahmatullahi wabarakatuh.
Sukses. Selamat Mbak Novi, sukses.
Terima kasih.
Selamat buat semua planet.
Tunggu makan-makannya.